Hello, everyone, and welcome back to day 2 of Flutter Vikings. So, we are so glad to be live once more. Sarah, by the way, you are muted.
Not any.
Um, this is so exciting for me. To be honest, last night, even though I was so tired, I couldn't sleep well because I still was excited. Like, the excitement didn't let me go. So I couldn't sleep very well, but I'm still excited, super energetic for day 2. And I'm very, very happy to say that we have a lot to share again today. And I hope that all of you will enjoy day 2. Sarah.
Yes, I am pumped myself. It's going to be a great day. Yesterday was an amazing lineup, and today it's even more amazing speakers. There's just so many good speakers to enjoy. So let's jump in, get started. This is a live event, so we have a code of conduct. We just want to remind you that it's important to be respectful and kind to your Flutter developer friends. At all times, but especially now during the event. And you have the ability to chat with other participants and speakers and sponsors and so on if you go to the platform. So be sure that you are in the platform. If you're just on YouTube, you can only watch. So there you can exercise being a great person and following the code of conduct. Okay, next. Yeah, again, we have 7 hours of talks and an AMA to top it all off at the very end with the Flutter team. It's going to be a lot of fun, a lot of great learnings, and I hope you enjoy it.
And activities. For sure, no conference, no online conference is like very fun if there is no swags and prizes and no activities, no engaging activities, right? So we
True.
have so many of them in under activities page. You can find them either on our website or you can go to Valhalla if you are on platform. In parentheses, if you're watching us on YouTube, we have prepared a platform for you with a lot of fun as well as a lot of virtual spaces that you can go and explore and even do networking with a lot of like other Flutter developers. So please consider registering a free ticket. An email come to you and you will get an access to our platform so you can come and visit us over there and chat with us. And under Valhalla room, you will see activities as well. You go there and read about those activities. It's a lot of things that you can do from a drawing dash with Flutter, writing an article about Flutter, and maybe doing some code lab, building Vikings, and so on and so forth. And of course, all of these comes with prizes. You have a chance to win Dash. You have a chance to win Flutter in Action book, Vikings t-shirt, Flutter t-shirt, stickers, book reader, cash up to 4,000. In fact, we have around 7,000 USD cash. So you have a chance to win that. You may win noise cancellation and many, many more. And don't miss this chance to look at our activities and play around, do something, and hopefully you can win some swags. And just one important thing. When you registered a ticket, you have received an email with your ticket card. On that card, you will have booking reference. Everywhere in our platform, you are required to enter booking reference. We are not asking your email, your name, nothing. You need to enter your booking reference. So there is a chance to win swags, but you need to have a free ticket at least. So consider registering your ticket. Next, platform.
Uh, yeah, so Majid mentioned a little bit earlier, but we can just go into some more detail about the amazing platform you get access to if you have a ticket. So if you haven't gotten one yet, please go to the link on fluttervikings.com and register, and then you'll get an email with a link to this amazing fun platform where you can go to these different spaces and talk to other participants in the conference. And there's also, it's like a little virtual world where you can walk around and do things, and you can take selfies with the other people there and put on hats, and there's the photo booth. It's a whole world there that's been made for you to explore. And then of course, it also gives you easy access to the main stage where you can see the main show, and also you can react to the speakers as they are speaking, which is very nice for them to know that people are engaged, and you can give them little hearts and thumbs ups and everything as they're talking if you like what they're saying. And yeah, you can also see the activity details there, so you don't have to leave the platform to look anything up. You can just go into the agenda, I think, and see everything you need to see. So there it is. And oh, look at this. We've got a collection of amazing tweets from yesterday where people were having fun in the platform. You can see some people took pictures, group pictures there in the little world, and then someone photoshopped themselves with Majid, which is amazing. And different people went in the photo booth and got Dash doing Viking activities. So it was I think everyone had a lot of fun. Oh, and look, there's Khan from the Flutter team. She was also watching. Actually, I know that a lot of the Flutter team was watching. So it's fun for everybody to participate and submit their pictures on Twitter or wherever on social media, and we are looking for them, and we'll make a Twitter photo album or Twitter wall, whatever you want to call it, afterwards. It's just to remember the good times. All right, that's it for me.
All right, great. So this conference could not happen without the generous offer from our sponsors. So we need to appreciate what they've done for the conference and what they helped us, which we could actually use and bring you this conference in this format that you are seeing. So I have to thank Google, Invertase, Stream, CodeMagic, Superlist, Rebel App Studio, the AdSign Company, Very Good Venture, Software, DevAngel, Bouvet from Norway, Manning Publication, and Microsoft. Thank you very much. It is amazing that you are supporting Flutter community and Flutter Vikings for sure. And for sure, we need to say enjoy the conference, day 2. But before
Yes.
that, let me tell you a quick update of yesterday. You see, we had around 1,400 attendees yesterday during the 8 hours of live stream. This is amazing. And we had over, I can quickly tell you, we had
That's
over 4,200 hours of watch. This is just amazing. I have
that's
to
right.
thank all of you for coming and watching and making this conference a great success. Thank you very much. And this is what we want. We want to bring joy as well as a level of let's say we want to have all the knowledge there you want to learn as well as joy. And we see the numbers yesterday, and these are excluding the YouTube live stream, by the way. We're just talking about our platform. And this is amazing. So thank you very much. I hope that you enjoy again today. we make sure that today's talk are also top notch for sure. Stay tuned. We also gonna go live with Flutter team when they are going to update Flutter desktop or announce the Flutter desktop. And we will watch it together on this stream. You do not need to leave here. We will watch together. We will celebrate together. And there will be free talks, desktop talks right after, followed by AMA sessions by Googlers. So Fitz, Craig, Frank, Chris Sells, they all be on the stage answering your questions. Feel free to send your question in the chat. We will capture them and we'll ask them, and hopefully you will get your answer. Anything else, Sarah, that you want to share?
Just to add to that last point, in the platform chat, there is no YouTube chat. So if you want to ask questions in the AMA, you need to be in the platform. So.
Exactly. And, all right, Sarah, today we have two special MC. They are like top-notch MCs in all over the world. And one of them will be with us in the first half. Let me introduce him to the conference attendees. Salih. Hello, Salih.
Hello, everyone. Hello. How's everyone doing?
Very good. How are you? Are you ready? Excited? Nervous?
I
How about the
am
heart
really
rate?
excited. My heart rate goes over the top, but to be honest, I'm living for this stuff. So I'm happy that I'm doing this and I'm in this position with my heart rate and everything.
That's good. So then we will leave the stage to you. You will be our host for the next few hours. Enjoy the conference with our attendees and see you maybe sometime later.
Okay.
Awesome.
Bye. Have a great day,
Bye,
everyone.
bye. Hello, everyone. It's really great to be here. It's really nice to meet you. Let me introduce myself a bit. My name is Salih. I am one of the Flutter Google developer experts around the world, and I'm working for a company called Superlist as a Flutter developer. I'm really excited to be here because it's a really important conference for me. I know a lot of hard work going behind the scenes, so kudos to everyone who is involved in this. And last but not least, let's not forget about also the sponsors and everyone, and including the attendees. It's really important that attendees are here and actually sharing everything with us. Awesome. So slowly, let me introduce our next speaker. It is Lukas Klingsborg, and he is a member of the Bluefire open source collective team. If you don't know it, it is the team that is actually doing this big, crazy project called Flame Game Engine. It is a 2D game engine that is working on Flutter, and it is the only game engine for Flutter right now. And I am looking forward to this talk because he will talk to us about how we can develop games using Flame Engine in Flutter. So let's go and see his talk.
Hello, everybody. I am Lucas from the Bluefire open source collective, and we're making the Flame game engine. So today I will have a basic presentation about Flame, basically, and what has changed in our V1 version that we released in December. And other people that are in the Bluefire open source collective is Luan, which was the person that created Flame from the beginning, like 4 or 5 years ago now. And then we have Eric, and we have Henan, and we have Jochum, and we're all in like spread out over the world. Like I'm from Sweden, and then we have Luan, he lives in Canada, and Eric is in Brazil, and then we have Henan that lives in Portugal. So yeah, we're super spread out. Hard to organize meetings, but we're doing quite fine. So let's get started. Start with, what is Flame? Some of you might not have heard of it. It is a 2D game engine for Flutter, and it is the biggest game engine for Flutter, and it is also pretty much the only game engine for Flutter, but we're still the biggest. We have, the game engine is just a Flutter widget, so it can live anywhere inside of your Flutter widget tree, which can be quite handy if you don't want to have like a full screen game. Maybe you just want some part of your app to be a game, or not even a game. You could just need some features that are quite powerful in Flame, like the effects system or something like that. You want to do something cool inside of your app. And we have grown quite a lot lately, especially since we had a co-release at the same time as Flutter 2.8 was released by Google. We released Flame 1.0, and we had a shared article together with them, so we got a lot of publicity from there. So right now we have 2,800 stars and 2,200 commits and 500 forks on GitHub. So, and we're going up at like, I don't know, 100 stars every second week or something. So it's really growing very quickly, and the community is also growing a lot. Like our Discord channels are exploding. And yeah, like I said, we just released version 1 a month ago. So now we have a bit more stable API than we did before. We had the 18 release candidates before we released V1. We thought it was just going to take maybe a few months or so. And we started with release candidates like last October or November, like 2020. But then it ended up taking more than a year because we found so much things that we wanted to change. But now finally we're at a state where we feel we can have a more stable API. Yeah, so just like the widget tree inside of Flutter, like we have a game widget which can live anywhere inside of the widget tree, as I said earlier. And inside of Flame, oh, right, we're going to talk about this first. And inside of the game widget, you can put any game that extends Flame game, or you can build your own game using the game mixin. But then you pretty much build your own game engine from scratch. You only get a tiny bit of pieces from Flame. But if you extend Flame game, then you will get all the power of Flame. And this is like the boilerplate code for a Flame game. You have your game, and you have an onload method where you load all your assets and stuff, and you add something that we call components. And that is what all of Flame is built around, components. And this is what it would look like then in your main file. You just create an instance of your game and put that instance into your game widget. And of course, if you have a full-blown Flutter widget tree, this game widget could be anywhere within that tree. So similarly to the Flutter widget tree, we have something called a component tree inside of Flame. And everything that you add to the game is a component. And even the game itself is a component. So you could add a game to a game if you would want to. And this becomes quite powerful because then you can compose components consisting of different other components. So if you want to have, for example, your player and you want to have some text or something underneath, or you want to give a weapon to the player, and you can just add components onto that player and they will follow the player around and get transformed together with the player. And this component tree system, we call it FCS, Flame Component System. And if any of you have done game development before, you might have heard of ECS, which is Entity Component System, which is the most like common system like this within game development. But we have FCS, which is quite different. But we also have a package for ECS if you're more comfortable with that, which is called Oxygen. But that one is not as mature as FCS is. And then a very common question that we have is that, can I add my Flutter widgets inside of Flame? And that is currently not possible. It sounds like it would be quite easy to build, but it is quite complicated actually. But what you can do is use our Overlays API. And then you can register your different Flutter components in our Overlays API or on the game widget. And then we can show, you can tell the game that, now I want to show this overlay, or now I want to show that overlay, and now I want to remove these overlays. And then they will just show these widgets on top of Flame, which can be quite handy when you want to use features which are like better in Flutter, I would say, like building menus, for example. It's very quick to build in Flutter, but it can be a little bit tedious to build it inside of Flame. And inside of all these components that I have talked about, and inside of the game, we have something called a classic game loop. So for anyone that have done game development before, you have probably heard about this before, but I'll briefly go through it. So in the game loop, you basically have two methods, the update method and the render method. And in update, you get this DT, which is delta time, and that is the time from the last time it ran update. And inside of the update method, you will update all of the logic that has to do with your component or your game if you're in your game class. And if you want to like manually move something, for example, and you have to take DT into consideration, because otherwise, if you run on like 120 frames per second instead of 60, for example, your game character would move much faster than it would otherwise, because then this DT will be smaller than otherwise. And in render, all of the render logic is done. So first it does update and updates all the components and all of your manual things to their new state, and then it renders the new state. And then it goes back to update, and it gets a new delta time for how long it was until it last did its update. And so this is what a component, the like most basic component could look like. There you have your update method, and you have your render method, and you have like the canvas if you want to do any manual canvas operations. But a lot of the time, you don't actually even have to put any logic inside of update or render, because Flame has so many built-in components that you can use that automatically does the update and render logic for you. So you only have to tell it like what it should do, not exactly how it should be done. Yeah, and then you can build this component tree however you want. So here, for example, you have a component, and in onload, you can add another component. You can add a component anywhere. Like if you tap your parent, for example, you could add another component there. But if you wanted to add child components directly in the beginning, then you should add them in your onload method. And then as soon as, so we can go back here, for example. How do I go back there? So if when your parent component that has been added to a game gets their update method called, and this is all done automatically, then all of that child their children update methods will also be called. So it will like traverse through the whole tree and call all the update methods through that component tree, and then call all of the render methods in order. And so you shouldn't do this. Like, you should never have to call update or render manually, like, because that is always done by the engine, and it takes a lot of other things into consideration that you wouldn't think about. So if you do this, you really have to be certain that you know what you're doing, because usually you don't have to, and if you do it, you will probably end up with weird things happening later. So never just create a component and call update and render manually. Add it to the game or to the component, like this, like I showed you before. Then we have our one of our like very fundamental components in Flame is called the position component, and every component that moves around on the screen, or like that has a position or a size and a scale and an or like is rotated with an angle, those components are position components. So you could, like, for example, your player is a position component. If you have a little score thing in the top, that's a position component. But all of those are, or they are extending from position component. There are some other components, but they come from there. Things that are not position components would mostly be things that aren't visible. So say that you have a component that doesn't really do much in the render method, or it doesn't want, you want to manually translate it and do canvas operations with it, then you could extend the basic component thing. But mostly it's position components. And here I have written vector2, that it's position, a vector2 scale, a vector2 size. Vector2 is just like a tuple that you, x and y, that you can do different vector operations on. And that comes from a library called Vector Math from Google. But in here, we actually don't, we have a class called notifying vector that is extending this one, which means that you can also listen to it. You can add a listener to it. So if you want from another component, you want to do something if the position or size or scale changes in here, then you can add a listener to this component's position, for example, and then you can react to that in the other component, which can be quite handy. And all of these they're backed by a transformer matrix that is then transforming the canvas and putting your component into the proper state. Right, and we have a lot of different position components. For example, a sprite component, which is just an image, basically, that you can show in your game. And we have the sprite animation component, which is, it's an animation. So if you have, for example, you want your player to run, you have an animation of your player running in a sprite animation component. And we have like a parallax component where you can put several layers as your background, and you can get some form of depth feeling to it. We have a good example of that in the examples.flameengine.org that we will go through later. And we have things like text component, if you want to put the text somewhere on the screen or whatever you want to do. Shape component, if you want basic shapes drawn on the screen, and a lot more. Like, there is a whole bunch of components, position components in Flame. So this is the basic sprite component that I talked about. Like, say that this is your little pixel art player. It doesn't do much. So usually you don't use just a sprite component if you don't want something to be like static. Maybe this would be a rock or something that is just on the ground that your player can't do anything, but because your player will usually be animated, or your enemies or whatever. So then we have the sprite animation component, and here you can see how it's animated. That it just stands there and breathes or whatever it does. But a lot of the times your player wants to have different states that it can be in. Like here it's resting, for example, but then also you might want it to walk or run. So then we have the sprite animation group component, which is quite a long name, but we felt that it's better to have it descriptive than to have a shorter name that will not be as descriptive. And in the sprite animation group component, you can change the state of your sprite animation, so that now you can see here that when I'm clicking down or tapping down the mouse here, it starts to walk. So then it just swaps the state of that component. And we also have a sprite group component, which is not a sprite animation, but then you can just swap between sprites instead, depending on states, which could be used for example, buttons. You want to have a state that is up, and you want to have a state that is pressed, or things like that. Right, and you almost always want to take input in your game, otherwise it will be a quite strange game, I think. And here we get a lot of help from Flutter, but we have built like wrappers on top of the input system and gesture systems on Flutter. So we have like the tap detector, and so that is just tapping on the screen, for example, or if you're clicking with the mouse, that is also tap. Secondary tap detector, that is like right-clicking on the screen. Double tap detector, quite self-explanatory. Long press detector. Multi-touch tap detector, so you can do cool things with like putting many fingers on the screen if you have some crazy game logic around that. Or a multi-touch drag detector, like you can drag around several fingers on the screen. That one is hard to do if you're using web, or like if you're at a computer, like because you only have one mouse, right? If you're not on some very special system that supports many mouses. And vertical drag detector, like only detecting drags up and down, and same with horizontal. And force press detector, like some screens and such can see how hard you're pressing. And pan detector, that one is a little bit of a confusing name, I feel, but that is like when you just drag your finger around on the screen. Because you don't have to do panning just because you're dragging around your finger on the screen. It is like a drag detector, I would say, but it's called pan detector in Flutter. Because it, kind of like a drag detector. And then the scale detector, so you can make things smaller and bigger. And mouse movement detector, like if you're doing a game for desktop or for the web, then you might want to have more specific things for when you do mouse movement in game. And scroll detector, detecting scrolls. And of course, you can detect keyboard events. So these ones you put on your game. But a lot of the time you want to do it on a component level. So you want to only react to input that is affecting your component. So if I click something, for example, then Flame can recognize whether that tap was on top of a component or if it was on the game or whatever. So then only if you have the tappable mixin on your component, then Flame will only send you these tap events if your component has that mixin and that the tap is within the bounds of that component. So then you can react to like on tap cancel, on tap down, and on tap up, and you get some information about where the tap was, etc. And we have similar for draggable for drags. So this is kind of like pans in that one. So if you want to like drag around your component on the screen, then you want to have it draggable, and you want to react to on drag start, on drag update, and maybe on drag end, and change your position depending on how the drag was done. And then we have hoverable, which is for like mouse mostly, that you can like it recognizes whether the mouse is on top of the component currently or not, which can be quite useful. And yeah, we can. This is like a lot of text, so it's better I just show you in our excellent examples directory, which is on examples.flameengine.org. And I'm just going to see if I can get that tab up. So, and here, this is powered by something called Dashbook, which is also built by Bluefire, or mostly by Eric. And this one is very useful for other things too, if you want to showcase a lot of different widgets, for example. And in here you see, like, we have lots of different examples. Like every time you do a PR to Flame, which has a new feature in it, it has to have an example in this directory, and it has to have like tests and a documentation. Like that's the basic thing. So that's you will always find a lot of examples here of old and new features. So here we can take an example with here, yes, two basic squares, and if you tap on them, they like move around, but if you tap somewhere else, they don't. Like, so that's something Flame will handle automatically for you. And then we have other inputs also, which are a bit more advanced, like a joystick, for example. You can just react to joystick things. You can style this joystick however you want, and different like buttons, and yeah. And then another thing, I told you I would show you the parallax quickly too. So this is what the parallax would look like. Like the layer in front, it moves the fastest, and the layer in the back moves the slowest. Like, you can imagine being on a train or in a car or something, and if you're looking at the horizon, this is what it would look like. And then for version 1 in Flame, we have a whole new effect system, which is very powerful. So you can do, instead of manually handling all these movements and stuff inside of the update loop, you can just apply an effect and it will do it automatically. So these are move effects, for example. So you can see like, this is moving along some path, and this one is having, so every effect can add a controller to it too, which can, so if you see this one, it doesn't move completely linearly. It uses the curve. Inside of Flutter, there is a curves library, or not a library, but it's built in, and you can choose a lot of curves that can change animations. So you can see that it goes a little bit fast in the beginning, and then it slows down, and there's like, I don't know, 50 curves or something to choose from within there. So you can do a lot of different cool things. And we have a lot of different effects to do, yeah, whatever you could possibly want to. And if you want to add your own effect, that is also very simple, because it's very easy to create new effects in the new effect system. Yeah, was there anything more I wanted to show you in here? Let's see. No, we'll probably take that for another time. let's get the slides back. Wherever those went. There they are. And Flame is also very modular. So if you want other things, you want other libraries that already exist inside of Flutter, either you can use them directly, of course, but we also build something called bridge libraries, which kind of contains wrappers for those libraries, so they will be more easy to use inside of Flame. So for example, we have a physics engine that we have ported, or we have done a bit of the porting work. There has been a massive work from other members of the Dart and Flutter community too, of porting Box 2D to Dart, and that one is called Forge 2D, and it's maintained by us at Bluefire too. And then if you want to use that within Flame, then you can use our bridge library, Flame Forge 2D. And you see the same here. So these big blobs out here, they are the actual libraries. And then we have the bridge libraries here, which provides wrappers to use within Flame. So audio players, for example, is another package that we are maintaining for playing audio and stuff, which you usually want to have in your game. And we have a really cool editor called Fire Atlas, where you can create like sprite sheets and animations. So you can really check that out. It's very nice. You can like run it in the web or whatever, because it's just a Flutter app. And then from those, it can pack down the animations into something called FA file, like Fire Atlas files, and then you can read them from Flame and just directly have them as animations on your screen, which is very handy. And then Oxygen, as I spoke about earlier, which is our entity component system, if you don't want to use the Flame component system. And recently, a work has been started to create an like AI library, like AI in the sense that you usually use in game development. So, for example, you want your enemies to follow the player, or you want them to run away from something, or so that one is called Radiant, but that package isn't done yet, but it looks very promising, and that's built by a community member called Pasha. And we have some other features that I haven't spoken about either yet. And we have a camera and a viewport. So if you want to like move around the camera or like follow your player throughout the world, you can use the camera and just follow component. And a viewport, if you want to have your game shouldn't give advantages if you have screens of different aspect ratios, for example. So you might want to use a viewport for that, so that you have like a fixed resolution. And we have a collision detection system. And do note that this is only for collision detection. It doesn't, you have to do what should happen when the collision happens. So like if two balls are colliding, you have to act on the on collision call that they should bounce off each other or whatever you want them to do. If you want to have all that like physics thing, then you should use Forge 2D. But usually you don't need the full-blown physics engine, and then the collision detection system is much easier to use. Because then you don't have to use all of the Forge 2D bodies and stuff, if anyone is familiar with the Box 2D things. And the effect system I showed you a little bit about, and gesture input handling I also showed you, and sprite batching. If you're doing like, you're rendering lots and lots of sprites, then you want to create a sprite batch so that you don't have to do lots and lots of render calls, but you can do a sprite batch and then do one render call to render all of the sprites, which can be quite powerful. And the physics engine I already mentioned. And if you're having some problems, then you can just, inside of a component, you can set debug mode equals to true, And then when it's rendered, you will see some boxes around it and where its hitboxes are and the positions, and which can be very useful when you're confused why your code isn't working. And if you put that on a component, it will only put the debug mode on that component and its children. And if you put it on the game, it will be on all of the components in the game. Yeah, so how do you get started with Flame? Like I said earlier, you have examples on our examples page. And these links can also be found on flameengine.org if you don't remember them. And we have great documentation at docs.flameengine.org. And we have a short tutorial at tutorials.flameengine.org. And we're developing this page, so it will be more tutorials there later. But it's quite a good way to get started to understand how the Flame components system works and stuff like that. And there are many unofficial tutorials, which you can find a list of them in the Discord, the Flame articles and tutorials channel, I think it's called, and it's pinned. And yeah, what should you do if you get stuck with your Flame game? We have a great community around Flame. So you can like join our Discord and just ask your questions there, and people are very friendly and will answer, and you can discuss how to do different things. And yeah, it's always good to have some people to talk to when you develop, I feel. It usually helps a lot. And we have, you can always tag something with Flame on Stack Overflow, and we will reply as quick as we can. And yeah, if you want to have it more formal or whatever, or if you want to file a bug, then use the GitHub issues. And yeah, that was all for me. Thanks a lot for having me, Flutter Vikings, and I hope to see you in August on the live conference. Yeah, questions?
Awesome. Great talk, Lucas. Thank you very much. I've seen Lucas and a couple of other folks like Hanan in the platform chat. So go ahead, ask them your questions, and I'm sure they are more than happy to help you out. By the way, I pulled in the microphone a bit closer because I've seen a couple of people saying that this is a bit lower than they wanted it to be. So I hope the sound is okay now. So perfect. Let's go to the next topic without losing anybody. So next person is going to talk about background operations in Flutter. And our speaker's name is Sakina Abbas. She is the co-founder and CEO of React3. It's a company that is helping multiple international companies to provide consultancies and actually mobile or any solutions. One thing that is really important and really, I think, impressive from Sakina is she is the first female Google developer expert for Flutter and Dart in Pakistan. I'm sure we have a lot to learn from her about working with background services in Flutter. So stage is yours, Sakina. We are looking forward to your talk.
Hey guys, hope you're doing well, and I hope that you've been having fun learning about interesting and exciting Flutter concepts from experts from all over the world. My name is Sakina, and today we'll be talking about just as an exciting concept in Flutter, which is working with background services. What will this session teach you? It will essentially teach you how you can execute your own custom Dart code in your Flutter application without having to depend on either user instructions or having to keep your application open in the foreground in front of you at all times. Let me just give you a quick introduction of myself. Hello, my name is Sakina Abbas, and I am the co-founder and CEO of React3, along with being a Google developer expert for Flutter and Dart. I initially started off with native Android development, but then eventually transitioned towards Flutter development, which is what I'm currently doing at my company, along with some fancy stuff like DevOps. As far as community contributions are concerned, I am a core member of the Flutter Karachi, Pakistan community, along with being an active women in tech speaker for Google Developers Space Singapore. And these days, I'm also leading a Flutter fellowship at AssemblyF, which is all about collaborative learning and networking. So before we delve into the nitty-gritties and the technicalities of background services in Flutter, let me quickly pose a series of questions in front of you, which will essentially establish or paint certain scenarios in your head for when and why would you even need to work with background services in Flutter, if at all. So we've all used Spotify. It's a great application. And let's say when you're just listening to music, you switch on over to another application, let's say WhatsApp. You want to talk to your friends while you're listening music on Spotify. The music does not stop. It keeps on playing, which is great. But if by accident or either intentionally you close the Spotify application from the list of open applications, the music stops playing and you have to reopen the application in order to be able to start listening to music on Spotify again. You might have witnessed a similar user experience in YouTube, but the difference, however, here is that the moment YouTube's mobile application goes into the background, whatever you were watching, whatever you were listening, it's stopped. And you need to resume it and you need to tap the button again in order to just get back to whatever you were doing. This leads to a question that should an application's code only be executed with user interaction? In other words, is it necessary that a developer has to rely on a user actively engaging with their application, or at least having it open in foreground at all times in order to be able to execute certain code in the background? This leads to another question that, have you ever felt the need to just execute some of your code in the background without having to depend on any of these things? I know I have. An example application over here would be a social networking application such as LinkedIn, Twitter, Instagram, maybe. So you might have noticed that obviously the first screen that you land on is your newsfeed screen. You just scroll through a couple of posts, you switch across tabs. Maybe you're talking to a friend, maybe you just switch off your phone, or maybe you just go over to another application entirely. And then when you get back, you will see that when you come back on the home screen or the newsfeed screen of your application, it displays a neat button that says new post here, so when you tap on that, it fetches and it loads those new posts and it renders them very neatly on your screen. Now, obviously, it's a very expensive task. So would you be needing to execute the code for fetching those posts and then rendering them on the client side, like while your application is up and running in the front end, in the foreground, I mean? Or would you rather have a more convenient way of just doing it separately so as not to compromise your application's performance? So definitely something to think about here. Now, your final question would be that, hey, can Cloud Function or Lambda do that? Can they achieve that? I mean, technically, yeah, there are serverless services that definitely execute code on without having to depend on user interactions or your application being open at all times. A good example over here is obviously when you want to push notifications to certain devices. This specific triggers, these are obviously being run, or they're being triggered in a separate environment. So they're basically from the server side. So what they're doing is that someone has written code in those Cloud Functions that they would want to be triggered when a certain specific event happens in the database. So it kind of has to do with the server side of things. The distinction here in the use cases that we've discussed here, however, is what if you want to execute client-side code in the background? What I mean by client-side, I mean the code that is running on your device itself. A good example over here would be, let's say in Uber Captain's application, when you book a ride, they get it, and obviously you want to track where your ride currently is. So on your Uber Rider or your Uber Captain's application, the application is actively collecting their latest latitude and longitude. They're just posting it to maybe an intermediary database from which those coordinates will later be fetched and then somehow processed and then rendered on the customer's application who just wants to track where their rider currently is. So you cannot expect to achieve these kind of tasks with Cloud Functions or Lambda, right? Now, there are already multiple applications. There are many applications, in fact, which leverage and harness this power called background services. Some of them being like obviously Spotify, Uber, and other related applications. So let's understand how or even if you can achieve a similar kind of experience working with your Flutter application. So can you execute Dart code in the background? And my answer to you would be yes, you definitely and absolutely can. Before we figure out how you can do that, let's just look into the basic understanding of a general Flutter application's lifecycle. It's very important to have some knowledge, if not all, of how a Flutter application generally works when you're working with background services. And the reason why this is necessary is obviously so that you can code your services accordingly. Like, when should your service be running? Should it even be running in foreground? Should it only be running in the background? For how much duration should it be running? Because you also need to be able to look at performance issues at the same time, right? I remember when I first was working with background services, I did not pay much heed to the application's lifecycle. And I noticed that the code that I had written, the background services that I had written and I was managing, they were working not too correctly. Everything was kind of out of order. So I had to do a little bit of Google searching, and then I eventually found out why it was happening the way it was happening. So that's another story for another day. But right now, let's look at a general Flutter application's lifecycle. Please note, this lifecycle is not being spoken of in the context of a widget's lifecycle, but instead the entire application's lifecycle. So from the time that you first open the application and the first screen is just getting painted on the canvas, the onCreate method is being triggered, and then after that, the onStart method is triggered, and then the onResume method is triggered. So while the application has it's in the foreground and you're just using it, just switching tabs, etc., etc., it's in its resume state, and onResume is the last method that is called when that has happened. Now you're just using your application, and let's say that you press a button, let's say a phone button that pushes your primary application into the background, and it opens up your phone's dialer, let's say, so that you can talk to a specific person. Now what has happened over here? When your application was going into the background, the onPause method is called, and after that, it just goes into the background. Now, when you come back to your application, the onResume method is called again, and your Flutter application is back in its resume state. So let's say that you were filling out a form in your application when you've had to switch between applications. When you come back to your primary application, the form would still be there, and you wouldn't have to go through all the way through the splash screen, the home screen, and so on and so forth. Now, when you just kill the application, what happens is that it first goes into the background for a very minor delay, on which obviously the onPause method is called, and then the onStop method is called, after which the onDestroy method is called, at which point your application has stopped, it has been killed, and yeah, that's pretty much about it. So if you want to work with a Flutter application's lifecycle in your app, like you want to make a distinction whether your app is in the foreground state, if it's in the background, and you want to perform certain tasks based on that, you can do that by overriding this method called did change app lifecycle state, which will be accessible to you if you extend your widget with widgets binding observer. So as you can see over here, we have four main states called inactive, paused, resumed, and detached. By the comments and by the code, you can see that basically inactive and paused are when your application has gone into the background. Resumed is the state, obviously, when you are currently when you're currently using an application in the foreground state, or when you come back to your application after it was in the background and you just bring it back into foreground again. And detached is the state, obviously, when you have killed or terminated your application. Over here, I am just playing around with this Boolean variable called isAppInFG, which I'm setting to false when the application is in the pause state, and I'm setting it to true when it's in the resumed state. Now your question would be that, do we need to work with this method, or do we need to work with an application's lifecycle when we're working with background services in Flutter? And my answer to you would be kind of not really, because at the end of the day, it all depends on what your use case is. In my case, for instance, what I wanted to do was, so I was showing these client-side notifications, these local notifications, but what my requirement was that as long as the application is in the background, or if it's terminated, then based on specific triggers, I will dispatch this notification locally, all right? But if it's in the foreground, then I will not dispatch the notification. So this is what did the trick for me. Now let's get to the most interesting and exciting part of this session, which is background services and isolates. So you've heard me talk about background service, or at least say the phrase or the words so many times during this entire session. So what exactly is this background service? You can think of it as a process which essentially runs behind the scenes in the background without any user interaction, or it doesn't necessarily have to be that the application is in the foreground. It could be It could not be, but this background service is something that is just running entirely separately in a separate thread, you could say. Some sample kinds of use cases or applications which might want to work with background services are, as we were talking about, a music streaming application like Spotify, then an application which needs to fetch the user's current and live location over a specified duration, let's say every 1 minute or 5 minutes, and then obviously do something with that location. So let's say push it to an intermediary database so that it can be utilized on another application on another client. Then we have scheduling-based applications, and a great example of this would be Google Calendar. So if you notice that when you have an event or a meeting coming up, it will shoot you a notification 15 to 30 minutes prior to that event that, hey, you've got this session coming up. So obviously, in use cases like these as well, you might want to work with background services. Now, how can you actually achieve background services in Flutter? And the answer to that is isolates. So what is an isolate? Isolate is what you might call a separate thread that executes any Dart code in the background. Why am I saying in the background? Because it has its own memory, it has its own space, and it's just running entirely separately from the main thread. And if you want to communicate between your main application, which just by the way, if we're talking about Flutter applications, it's already running on a main isolate, quote unquote. And if you want to work with your own custom isolates and you want to communicate, you want to establish communication between your main application and your isolate, then you would be able to do that by message passing, for which you need to set up your receive port and your send port. So if you were to visualize this to get a better and a clearer understanding of this, on the left, you can assume that this is your standard Flutter application, and on the right is your custom isolate that you're working with. Now let's take an example of a social media application, let's say. So let's consider Twitter, right? So on Twitter, when you land on the home screen on your newsfeed, you can see a couple of tweets. And once you're done scrolling here and there, maybe you switch over to another application. And let's say you come back to your application, let's say, I don't know, 20 minutes later. And if you're still on the home screen, you will notice that you will be seeing a button or an indicator saying new tweets available or new posts available, something like that. So that when you tap on it, it will just reload the new data that's available to be shown on your newsfeed, and it will automatically scroll you there. So what's happening here? Basically, now you do understand that fetching this latest data, fetching the latest snapshots that need to be shown in your newsfeed, it's not a very, it's a very computationally expensive and intensive task. So you do not want to run it on your main thread, otherwise it would just hog your performance and resources, causing lots of delays, lags, janks, etc., etc. So let's say you take that piece of code and place it in your isolate, and your isolate is just fetching all that data in the background while you, the user, can use your main application, and you can just navigate to whichever part of your application you want to without seeing any kind of delay, right? Now, once the isolate has done performing its task, it needs to notify your main application that, hey, I've done my work, I've got this data ready, and you need to show it to the user. So when your isolate needs to communicate that to your main application, it does that via message passing. So we have receive port on one end, we have the send port on the other end, and this is how you just notify each other that, okay, I have data available, show it on your show it in the UI. Or maybe if you want to request for more data, then you can also communicate vice versa with the isolate that, hey, I need more data like that, just bring it to me. So this is kind of how it's working. Another thing that you might want to make note of is that because they're two completely separate threads, that means nothing is shared between them. If, let's say, in your main application, you were maintaining your state in some way, or maybe you were using some variables classes, you can't access them directly inside your isolate and expect them to have the same value. Why? Because that is running on an entirely separate different thread, and your isolate is not aware of what's happening over there. The only way you can aware each other of what's being requested or what's being sent or transmitted is via message passing, which we will now look into in code. So here we have a main method, and over here, as you can see, I have initialized my isolate, which is returning me a send port, which I'm then utilizing to send some data from my main thread to my isolate. Now, if we look into our init isolate method, you can see that it's of type async, and it's returning me a send port in the future so that I can then utilize that in my main thread for sending messages from my main thread. Now, as you can see, I have also configured my receive port over here, and then I'm actually actively subscribing and listening to this to my receive port so that I can keep track of whatever data is being sent to me, and then I can process it accordingly. Inside my listener, what I'm doing is that the way that I'm making this distinction that, hey, who was the source or what's the source of this data that I'm actively getting over here? So if the incoming data is of type send port, then it means that the main thread basically sent data from the main thread, obviously, to this isolate, and then I can process it accordingly, and then I can just make use of it however I want to. If the data is not of type send port, then it means that I am the one, like the isolate is the one that has sent this data. In this case, we're just printing it out for simplicity's sake. The main thing or the main crux of this, however, is this line right here, in which we're actually spawning our isolate and we're creating it. So obviously, when we're working with isolates, we want a specific chunk of code to be executed in the background. And what is that chunk of code? It's right here, my isolate. This is the method that I'm passing over here, along with the send port, so that we can establish this two-way connection of communication with each other. Now let's look into our my isolate method. It's not doing much. I mean, technically you could be performing any task you want over here. Let's say a really long Fibonacci series, or prime numbers, or fetching the latest posts that need to be shown on the user's newsfeed, just anything at all. If you were to do anything like that, this is where you would be ideally doing it. So over here, we have initialized the receive port so that we can just listen to any incoming data. And obviously, I'm also sending some data in my send port so that we can establish this two-way connection. And here in my listener, I'm not doing anything special. I'm just printing the data that has been received from the main thread to my isolate, and I'm just exiting it over here. Obviously, it's not necessary that you exit it. It's just for simplicity's sake, so that it does not keep on running inside a loop. And then in the end, we're just sending some data from the isolate to the main thread. Now, there are some important considerations that need to be made over here, such as whenever you're working with background services or isolates, make sure that this specific method in which you are basically working with your isolates, they are not inside a specific class, and instead they are top-level functions or they're just static methods. The reason being because your main thread is separate and your isolate needs to be separate. So if you will have that inside your class, and let's say you bring your application in the background, or let's say you just terminate your application, then the code that you had expected would still be executed. It would not, because you have just killed off the main thread. Right? So that's how you keep your isolates up and alive and running. The other thing which is very important to make note of is whenever you're working with third-party services in your isolates or background services, such as Firebase or local databases like Hive or SQLite, and you are aware that you need to initialize them in your main method so that you can utilize them later on from anywhere in your application. I know you've already initialized it in your main method, but when you're working with isolates or background services, you need to reinitialize them over there again as well. Why? If you want your isolate to be communicating with the database, let's say you're actively getting the user's live location, you want to push it to the database. So obviously for that, you will have to reinitialize your Firebase app or your Firebase service inside your specific isolate, because it is running in a separate thread, in a separate plane, in a separate execution, whatever you might want to call it. Now, I understand that that was a lot of information for you guys, like what's up with this receive port, what's up with the send port, where will we configure what kind of port, how will we establish this connection, how will we stop the service? You probably have a lot of questions in your head, and I get it. It can be daunting when you're just starting off with isolates and Flutter, which is why we have some third-party solutions that you can very happily rely on. So you can actually just feel free to screenshot this slide, and you can find them anywhere on pub.dev. So the first one that we have is Flutter Background Service. This is the one that I have actively been using in some of my projects, which require background services. And this is something that I will also be showing to you in a live demo right towards the end of the session. Then we have Flutter Isolate. It's just syntactic sugar for the vanilla Dart isolates that we just saw. So it kind of makes the ports and the communication a little bit easier and friendlier for you. And then we have Flutter Background Geolocation, which is more specific towards location-related services and functionality in your in your application's background. It's a really popular package, and it's got a lot of powerful features in it that you can definitely feel free to check out. The only downside, however, is that even though it's free for iOS, for Android, at least in the production mode, you need to purchase a license. So if your team or if your organization has the budget for that, then that's great. If they don't, then that's okay as well. You will just have to write your own custom code, either using Flutter background service, isolate, or just the vanilla isolates in Dart that we just saw. So let's quickly have a look into our code and see things in action. As you can see, I have two files under my lib directory. One is called main.dart, the other my isolate. My isolate is nothing new. It's just something that we just saw in our slide. So I have my init isolate, I have my isolate method, I have my main method. So let's just quickly run it. And as you can see, it has printed a couple of things in the console, and then it has exited due to the specific line that I've coded. So what you can see here is that it's printing the statement called, this is from my isolate. So this is right here in our isolate. This is what our isolate just did. It sent a message to our main thread, and it was printed in the console. And on the contrary, we're also sending some data via the send port in our main thread, and we're just sending this list of strings called hello, world, and the isolate was able to successfully capture it and also display it in the console. Okay, so it's pretty standard and fair enough. Now let's look into our other file, which is actually using Flutter background service. If we just quickly look into our pubspec YAML, in fact, let me just build this in the meantime so as not to waste any time. Right. So while the application is building, you can see that I have basically imported Flutter background service and audio player in this specific project. What this application is doing is when it has loaded, you will see that it's basically playing the specific audio from the network. It's a 1 second audio, so it just plays it once, and then it plays it again and again and again and again until and unless I actively stop the service myself. So it's playing this inside a loop, and what it's doing is that every time it has stopped playing it just once, it increments a count, and it sends it to my main thread so that that count is visible in the UI. Okay, now I do not know if you guys can actively listen to this annoying sound that's being played, but I can, and just in case you can't hear that sound, it's perfectly fine, and it's good that you can't hear it. It's really annoying. But you can see the logs being printed over here, and just to make things interesting, you can also see the number of times that this track has been played. Now let's take it into the background. Let's just explore, blah, 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 and we come back. And as you can see, when we closed our application, the last count was somewhere around 16, and when we reopened it, it's now somewhere in its 20s. Now let's do something even more adventurous, and let's just terminate the application entirely. Let's reopen it up again. And as you can see, the count is 36, meaning it still has been playing the track. And again, I don't know if you guys could still hear this annoying audio, but I can. And you can also see the logs being printed over here every time it's playing the audio. Now, when we want to stop this service, we can do that by clicking this application over here, at which point you can see that it has only played it 45 times. And then we start it again, and it's playing it again. Oh my God, this is really annoying. I'm just going to stop it right away. So let's do a quick walkthrough of the code. What I have here is my main method, which is not doing anything special. Then I have my onStart, which is my service. So inside my service, I've done the Flutter binding and ensure initialize just to ensure that I can access these services without running into Flutter-specific exceptions. Then I have initialized my background service, my audio player for playing the track. And then I have initialized the URL from which the track will be playing. I also have initialized a count variable. So we can keep track of how many times the specific track has been played. And then I have set up a listener so that we can listen to any events that are being sent to our service from our main thread. In this case, what we're doing is that if the event contains a key call action and the value is stop service, then we just stop our service. This is how we are basically controlling stopping service. So we engaged with our UI, it sent a message to our service, and we caught it and we stopped it. The other thing over here, what we're doing is that we're just listening to the state of our audio player. And every time it has completed playing the track, it will just prepare this map of data that we will then be sending to our main UI thread, which we are doing right here. And we're just then printing it for simplicity's sake. Then we just repeat the track all over again. And this line, we're just utilizing this to play the track for the very first time. And then this specific chunk of code takes care of the track being played in the loop, right? Now let's look at our UI code. Here we have our widget called My Homepage. And as we can see, we have two variables, is running and play count. Then inside our init state method, we have basically, this is the specific point where we have initialized and started our background service with this specific method called onStart, which we just saw. And then we have set up a listener for our background service so that we can catch and process any data that our service is sending to our main UI. In this case, what we're doing is that we're checking if the event is not empty, and if the event has certain thing called count and it's not null, then we're just extracting that value from the map and we're just putting a set state on it so that it can be shown on the UI. And in our build method, we're not doing anything special. We do have a floating action button, which is of interest here, because what we're doing is that what we want to achieve is that when we press this button, we want to check whether the service is actively running or not, which is what this method is doing for us over here. It returns a bool of whether a service is actively running or not. If it is actively running, then what we're doing is that we're sending data to our background service with this specific map of action, stop service, which is then being caught in our service. And right here, our service is being stopped. Then if our service is obviously not running, which means that our service is currently stopped, then we are just starting our service all over again. And then we're just doing a set state on the is running bool so that we can toggle between the icons on our floating action button. And lastly, over here inside our text widget, we are displaying the play count variable, which, if you recall, we did a set state on it using the value that we received from our service. So that was pretty much it. And if you have absolutely any questions, feel free to reach out to me on my socials listed there.
All right. Again, another great talk about something very deep, actually. If you are new to Flutter, it might be a bit hard topic for you, but believe me, working with isolates and knowing what they are and the power of them is a really important topic. So thank you, Sakina, for this amazing talk. And I'm sure everyone will be contacting you if they have any other questions. Okay, so we had a UI talk, we had a deep dive talk, another UI talk time. And this talk will be from Alois Daniel. I hope I'm pronouncing your name properly, Alois. And he's a Flutter freelancer. Actually, if you're into the Flutter community, I'm sure you have heard about him. He is like one of the creators of for the Figma packages. Like there's a Dart generation for Figma to Flutter. And his talk is actually about custom design systems from designs to widgets. So I'm sure we will see a lot of Figma, a lot of Dart code, and how you can actually set up your system. So stage is Alois now, and I hope we will learn some really great stuff from him.
Hey! Hello everyone! Today I will not only cover Flutter development but also UX and UI design and how we can improve our collaboration with the design team. But before we start, I will present myself briefly. So I'm Alois, I'm a French Flutter freelance developer, and I also like to contribute to open source and to the Flutter community in general, which led me to become a Google developer expert, which I'm very proud of. On my free time, I also like UX, UI design, drawing, and playing music. I'm currently working for a company named ClickUp. We are building a product named ClickUp as well. The purpose of the product is to improve productivity inside companies. by making it easier to create process and to collaborate with the various teams inside your company. So don't hesitate to try the product at clickup.com, and don't hesitate to send us feedback. Okay, let's dive into the topic. Before starting, you may wonder what is exactly a design system, and I will try to give you my definition. My definition, not really, in fact, I only extracted this from the Envision blog, and I find that it corresponds quite well as what I imagine when I'm talking about a design system. So a design system is just a library of basic building blocks and standards that you will reuse to create applications. I will switch to Figma to show you an example of a design system. So let's start with this example. So before we start, I'm in Figma. Figma is a great tool. I highly recommend your design team to work with it because it works in real time. So it's really great for collaboration. And it's also a great tool for designing. They also can use other tools like Adobe XD or Sketch, for example, but this one is my favorite personally. I even created all of the slides that we've seen just before inside of Figma, so it's very versatile too. Okay, so let's take this example. This is a custom shop for Vikings, so they can sell their products. And I imagine 2 pages like this, so a designer could give you this, the development team. And you can see that it has a specific layout and specific navigation, and we will see that it can be a problem. After more basic stuff like UX researches, workshop with the end user, they will produce some more refined design like that one. This is in fact a prototype of what the development team must implement to create the application. But that not only provide you the screen of the application, they also provide you a prototype of the design system. So, like I said before, it's a library of components and standards. They could also write something in a document to explain what the design system is to make things clearer for you to implement. But it's at least that. So the things are separated into layers. The most basic one at the top and the more complex at the bottom here. In the top category, you can see the most basic resources, which are colors, the text styles, the spacing values, the corner radiuses, the shadow, and all these elements will be used inside the app. This allows you to have a consistent experience. This forces the designer to reuse these components and to make sure that every one of the screen is consistent with the others. And it will also help us implement the design system actually. So you have the color. You can see that each resource has a specific name. So you have the color with the name here. You have text styles with specific names, title 1, title 2, title 3, paragraph, and so on. And for the color, it's the same. You have accent highlight 2, and the various other color that you will have inside of the app. You can also have the icons with their name too, and you have the images too with specific names here too. So these are the most basic resources. Then you will have a bit more complex components, which are in fact composed of multiple basic atoms, as I named them. Here, for example, the button is composed of a text style, an icon, color, border radius, and spacing. So you can see that everything that composes this button is in fact defined just in the layer above. And it's the same principle for all components. So you can have multiple layers of components like this, and you end up with the actual pages from the app. The designer can even prepare an interactive prototype for the app with Figma, so the developer can understand well how the app should work and how the user should interact with the app. For example, here we have something that is a scroll view. We can understand that this area is scrollable, that the bottom bar stay fixed on the screen. and you can try interactions. I will restart so you can see the initial state. We can see that we have a bottom bar with a notification bar that the user can close it. You can see that we can interact with a product tile to get to navigate to the detail of the product, and that's it. You can navigate back. So it really gives you a better idea of what the app should look like when implemented. Same for the filters at the top. Let's switch back to the slide. So how could we implement it with Flutter now? You may guess multiple things. In Flutter, we have three main libraries to implement our apps. We have the Widgets library, which is in fact just the most basic widgets, and they are generally neutral and not too tied to a visual experience. You have the Google Material Design implementation, which is in fact a more advanced design system with more components and more rules. You also have specific theming mechanisms too. And finally, you have the Cupertino, which mimics the iOS look and feel. I won't cover too much Cupertino today because I think it's too specific in most cases. Let's start by studying material design. It's probably the one that everyone will go when he starts Flutter application. And for a reason. You have a lot of learning content about it. You have a lot of components. You have everything to make you create an app very quickly. So it's probably the easier to use when building an application. But if you use it for the app I just showed you before, you may find that it can be difficult to implement such an app with material design. Because, for example, we don't use the regular list styles. We have a specific header on our home screen. We have a very specific notification container. We haven't a material bottom bar. And finally, the designer doesn't want us to create a ripple effect. So you may wonder which part of material are relevant now in this app. If I want to summarize material design and material library in Flutter, I would say that it allows you to build app really quickly. It has a lot of advanced built-in widgets. It covers accessibility and it has responsive visual components too. So it's probably the best option when implementing most of the apps. But I find several drawbacks. You can have different naming conventions between your design teams and the material design system because it already have a theme with specific names, and your design team may not have thought it the same way. They could, for example, a title could have been named header, and you have to switch between the two conventions to make sure everything is working as you expected. It's doable, but it's always more complex. I find it also hard to tweak sometimes. It's hard to modify the visual appearance of several widgets, and it can be an issue for specific pages. And finally, I find it that it can be boring because more and more apps are using material design, and you have the same ripple effect, you have the same pickers, and so on. And I find that all apps have a tendencies to look the same, in fact, because of this. So it can be dangerous for that, in my opinion. The second option is to build your own material design system equivalent from scratch by using the most basic widgets from Flutter. This means that you will have to re-implement all of the theming area with colors, typography, and so on, but you will also have to re-implement a lot of components so that they match what you have in your design system prototype. This also means that we will try to stick to the widgets.library and we will avoid the material library. The advantage of this approach is obviously that everything can be customized. It also allows you to respect the design prototype naming conventions that the design team has defined. And obviously too, the drawbacks are it will ask you to do a lot more work, and it will be really difficult to maintain since you will have to follow the Flutter evolution. How can we choose between one or the other solution? In my opinion, you can go with material design system when you're working on small projects or prototypes, or on projects which the design systems has been thought around material design from the beginning. This ensures you that you will use the same conventions, the same principles that are in the material design system. Even if material design system is very generic, it has, like I said, a few things that are fixed and standardized, which can be a good thing. But I really think that the design team should learn this before doing the design system for your app. On the other side, for big projects which require long-term support and a very specific and customized visual experience, or with potentially multiple apps with a shared design system, I would go with a completely custom design system. I find it really clean to have a standard for your company, and you're sure that everything is really customized for your products. You can also eventually mix the two solutions. Just be careful to not create a messy code base by using the concepts from both design systems. I will try to explain you how I implement this kind of custom design system, at least an example, a very simple example, by taking the design system I showed you before. For this, we will use one of the most basic widgets from Flutter, which is the inherited widget. I'm sure you know stateless widget and stateful widgets, but maybe you never created your own inherited widget yet. And that's the widget we will use to create the theme of our app. So the shared resources, colors, and so on in our app. I will show you why. The first thing I have to say is that inherited widget is everywhere in the framework. When you're using the theme from material design, you're in fact using an inherited widget. The same for media query too, for example. It's really one of the core mechanisms behind Flutter. So it's really a simple, basic, and very well tested widget in the framework. So what is an inherited widget? An inherited widget is a widget that can be accessed from any one of the descendants of this widget. So you can access it from the context, from its build method. It allows you to share data with the whole widget tree. And as you could imagine, it's really useful for our use case. We will be able to share our colors, our typography, and so on with the rest of the other widgets from our apps. And the other great thing about inherited widget, it can notify any of the widgets that read it of a change. So it will automatically trigger a new build from these widgets. And this is great for theming too, because we will be able to notify of a temp change, for example, when switching from light to dark, and all of the widgets will be updated automatically. To implement this, I generally create a dedicated class to store all of the resource values. So I start by creating a simple Dart class, which is named app_theme_data. You can even split this class into smaller one to make things more organized. For example, I like to create a class for the colors, a dedicated class for the typography, for the images, and so on. The only thing you have to make sure is to implement the equal operator and the hash code, because this will allow us to compare our instances by value and to notify the other widgets very easily just by comparing instances. To implement this, I will highly recommend Equatable and or Freeze, which makes things a lot easier to implement. If you create a data class like this, it will be really easy to implement an inherited widget. An inherited widget just extends inherited widget class, and you have to store the app data as a property. Add a static method named off to make things easier to access this widget from the descendant widgets, because it will be used almost everywhere, so you don't want to call depend on inherited widget of exact type everywhere in your code base. So we make enough static function to make things a lot quicker to invoke. And finally, don't forget to implement update should notify, which will notify every one of the descendant widget of a change. So here we just say that if one of the properties of our data changes, then we have to notify the descendant widget of a change so they can rebuild themselves. And let's see how I implemented this with Flutter. So this is how I do this kind of design system, how I implement it. So I first start by creating a dedicated package for all of these resources and components. This allows me to reuse it in other apps, for example. It's very handy for that. And it forces me to have something that is not tied to an app logic too. So I find it really great to have an isolated part for the design conventions. And this way we can easily share it or test it. So inside my package, I have a directory named theme. And inside of it, I have a subdirectory named data. And this subdirectory, I have all of the data I just show you in the slide. So the root one is named app theme data, and I have a property for each one of the children data classes. Yeah, I also like to create a factory to create a default theme data. You may create one for light or dark theme, for example, and other variants to make responsive implementations easier. So if I go to the color data class, you can see here that in fact it's just an equitable implementation with a property for each one of our design system resource. And if I go back to the design system, you can see that everything matches with the color names that the designer gave us. So this allows you to really respect the naming conventions between you and the design teams. And finally, I have a factory to create an instance with the colors that we have here. And we could have a second factory for a dark theme, for example. It's quite the same for all of the resources from the theme. So we have the same thing for icons, images, border radius, shadows, and spacing, and typography, obviously, with the text styles. Maybe the only specific thing is you may wonder how I created a specific icons, and for that I used a plugin for Figma named Icon Font Exporter, which is very handy. It allows you to export a TTF font file that you can import in your package later. Okay, one thing I'll also like to do is to create really basic widgets that are just on top of these resources. For example, I like to create specific gap widget for Flutter. Gap is a package, an external package, and it's just an equivalent of a sized box, but it detects the direction of a flex box. So in a row it will be an horizontal spacing, and in a column it will be a vertical spacing. Just a quick way to create spacing, and I created a widget that only read the current theme value from the off static function and then return the widget. For example, I like to do the same for the app text. So it's a specific text widget for our app, and I created factories for all of the styles from the theme, and this way we don't have to read the theme for every one of the text from our app. We just invoke this widget instead. So it makes things even more simple to implement. And last thing I wanted to show is the golden widgets. If you're not familiar with golden widgets, it's unit testing, and you will be able to render widgets as image from a command line. So it will allow you to verify that your theme renders correctly. So you can generate an image like this from all of the components from your design system. And I find it great. So I generally build a library. So it's just a regular widget, which stack all of the sections from our design system and print them as a vertical layout like this. And this is really handy because you can share this image in a PR, for example, or with the designers, so that they can validate quickly the rendering part of your design system implementation. If I have to summarize, I would give you those tips. The first one is to align your naming conventions with the design team. This improves a lot the communication and avoid styling mistakes. And it's better to improve the productivity of your development team. The second one is to create a dedicated package for your design system, because if you want to reuse it in other projects, you will be able to. The third one is to use golden tests when implementing a design system so that they can be shared easily with other people. The number 4 is to create base widgets like the gap or the app text, so that layouts are really simple and clean and a lot easier to analyze when you come back on your code later on. Number 5 is to use packages when possible. They can solve really complex problems or things you wouldn't have enough time to implement yourself when implementing an app. So don't hesitate to look if a package can simplify your work. And the last one is to use tools to improve the collaborations and the asset export process from your design team, because it's something you will have to do on a regular basis. So I highly recommend you to find the right tools to accelerate the process behind implementation. We have our theme with all the colors and so on, but now how can we implement the actual screens of the app and all the other components? So they are, in fact, simple widgets. Like any of the things that you would implement with Material, it's the same for our custom theme. You will just have to make sure that you're using the theme, that you don't have magic numbers or colors that are defined into your build methods, but most of your widgets will be just regular Flutter widgets. For example, here I'm implementing the price label at the bottom, and it's just a container with a row with a specific box decoration and a text and an icon. So you just use your theme to create more advanced widgets. And that's it. Obviously, several widgets will be more complex. If I take a button, for example, you have a lot of logic behind it, the user interactions, and or you have another effect, you have really specific behavior. And for this, I highly recommend you to check out the material design implementations to extract what is only relevant for you. So for example, the ink response widget from the material design has a lot of logic regarding the current state of a button. For example, all of this, you can see that it defines shortcuts. You have a focus management, a mouse region to handle the cursor on desktop. You have semantics, and you have a gesture detector to handle the tap. So all of this can be complex to reinvent. So I recommend you to always see if you don't have a quite similar widget in the material design library. And I will show you how you can implement this widget. So I generally put them into my design system package, and I put them into a widgets subdirectory. And if I take the price label we had before, you can see this. You have something like this, but the most advanced part is the button. So what I like to do when implementing a widget is I like to split it into two parts. So the first part handle the logic, the interactions, and so on. And what I call the layout part is just the visual layout of the components I implement. This allows you to test it really easily. So I will show you with the product tile, it will be clearer. So what I like to do is to separate my widgets into two parts. So I have one which manages the states inside of your app, for example, the tab management with the users. And I like to have a second one which manages only the visual layout part. So here I have a product tile layout, and I say that the product tile layout can have two states, one idle and the other is over. Those one matches what is defined is our design system. If I take the two here, we have an over variant and an idle variant. So the naming conventions are the same between my layout implementations and with the design prototypes. So I generally define just a layout widget, and then on top of it I have my actual real working widget which uses this layout widget and adapts it regarding the current state of the app. Here I use an app tab builder for the user interaction, and this is just what I show you with ink response. It's just a simplified version of the ink response widget from material design. And you can also use golden tests. So like I said before with the theme, golden test allows you to render your widgets as images. So here, for example, with the product tile, I'm rendering it as images to validate that the layout is corresponding to the initial prototype and that the colors and so on are well. Again, this can be shared in your PR or with your design team, and it allows you to test that your widgets are responsive. So it's very handy for that. Okay, and finally your app. I like to structure my app like this, but that's not relevant for the presentation. But if I take the home screen, for example, it's in fact just a view which is composed of basic widgets, and that obviously uses the theme that we define in our design system package. But it's also a regular widget. Several tips for this part too. Really, you should always read the material design widget implementation first before going into your own widget implementations. Like for the theme, I recommend you to respect the naming conventions from the design team. Here, for example, we have an idle state and we have also an over state. So this makes communication easier again. Don't forget accessibility to make your components responsive. It's something that can be easy to forget because we don't have the same issue as other people. Finally, every one of the tips I showed you are just personal preference, but I really like this when switching from a design system from Figma to an implementation in Flutter, because you really can see the transition between the design system and the Flutter implementation. And also it allows you to test your various layout in a quick way and to render the various states without having to simulate tabs on user interaction. So it's just a bit more of effort to implement, but it's a lot easier for a lot of things later on. Obviously, I just show you a small part of the implementation. If you want to go deeper into the design system, the example design system, I highly recommend you to check out the source code you can find on my GitHub. And you will also find a link to the Figma design file from here. So don't hesitate to go there and to ask questions on the issues from the repository if you want to. Thank you. I hope you enjoyed this presentation and the other presentation so far. I let you with the other Vikings. I'm sure you will learn a lot of things today, so have fun and goodbye.
Excellent talk again. Amazing tips and tricks about how you can actually build up your design system in the Flutter environment. It's really great to see these kind of stuff because once you work in the companies, these are the simple things, so to say, that are neglected easily. But actually, everything that you see here is going to make your life way more easier than you have right now if you're working with Flutter. The next talk is something really important and particularly interesting for me because in my day-to-day job, I'm building desktop applications with Flutter. And in the next talk, Walid Arshad is going to talk about how you can use shortcuts and actions in your Flutter applications. Walid is one of the people who are in the Google Developer Expert community for Flutter and Dart. He is leading the Flutter community in Pakistan, and he is the first Flutter and Dart expert in Pakistan as well. So it's really going to be an interesting topic and talk. So we are with Walid's talk about spice up your Flutter apps with shortcuts and actions. And stage belongs to Walid now. Let's go.
Hello guys, this is Walid from Pakistan, and finally we are here. We are having Flutter Vikings, finally, and it's a great pleasure to be here. And I would like to thank all the team members who are organizing this event, including Majid. He's an awesome person. He's an awesome, the community is really thankful to have him. So let's just begin, and we'll be, what today we'll be studying about some things related to your desktop and your Flutter web apps. So we'll be studying about giving control to your Flutter apps. So what you will be studying today, obviously we'll be studying, and we'll be looking at the code as well. So we'll be looking at how to add shortcuts and actions through intents in your applications, and we'll study why we are doing that, and why it's important. So this will be, a lot of it will be a live coding session. So I'll be coding in front of you the whole thing, and then we'll look into the use cases and applications of how we can get the best out of our Flutter apps. So just to begin with, I'm Walid Arshad. I am from Pakistan. I'm a Google developer expert in Flutter here, and I recently published a book named Managing State in Flutter Pragmatically, which is a state management, a book on state management, a lot of recipes combined into one. Excuse me. I'm a Flutter developer at Tendermint. It's a blockchain based company, and as well as along with that, I'm leading Flutter Karachi. It's a Flutter community here in Pakistan. So let's get going. Today's agenda, we'll be studying that why we need shortcuts, first of all, obviously. Then we'll study some keywords, some classes, and some widgets that we'll be using in the live coding session. And then obviously we'll hop on to the live code session. So why shortcuts? The prime motive of having this talk is you use a lot of applications on daily basis, including IntelliJ, VS Code, Adobe Photoshop, Premiere, and a lot of other applications that you use daily, and you implicitly know what shortcuts are there, what common shortcuts are there. And for those who are using specialized software like Photoshop and Premiere, they have their specialized set of shortcuts, keyboard shortcuts that do a lot of stuff that would be very hectic if you go and hover through the mouse, right? So this is the whole idea behind today's talk, that we'll learn to study that since now Flutter is going towards web and desktop, and we are having some great releases planned ahead. Obviously we all know that it's going to get more stable as we move along. So you will be creating Flutter web apps, Flutter desktop apps using Flutter. So in order to make your user experience a lot better in terms of shortcuts, in terms of usability, we are going to study how we are going to do that. We'll be studying two sorts of widgets. One is shortcuts, widgets. Shortcuts is a widget. It's not a plural. It's a singular widget that is called shortcuts because it takes an array of shortcuts obviously. And then we have another widget called actions, which is obviously not a plural, but it's a name of widget. Other than that, we'll be using these three sort of classes, which are called intents, actions, and logical key sets. So these are classes, within the Flutter framework. So we won't be using any third-party packages for any sort. We'll be using the whole Flutter code, obviously. So these are the three things that we'll study. So let's directly jump to live code. And if if you can see right now that this is a sort of desktop app we are running right now. So this whole presentation is a desktop app, and I have added shortcuts to navigate through this presentation. So I have a shortcut added to the front, to the right arrow key, that when I press the right arrow key, the presentation moves forward, and when I press the back arrow key, the presentation moves backward. So this whole presentation is itself a practical implementation of what I'm going to tell you. So we don't need to jump into any other thing. The live code is itself inside this presentation. So for understanding, for the sake of this talk, what I have done is I have added a text field and a button. So first of all, what I'll do is I'll create an intent and an action, which will do what? Which will just clear everything that we write here using this button. So we are not going to add any shortcut right now. Like ideally what we are going to do, what we will do is we will press escape button on the escape key on the keyboard, and then this text field will be cleared. Like the expected behavior is that when we press escape, so the text field should be cleared. So that's what we are going to do. But for that, first of all, what we are going to do is we are going to call that specific action on this button press. So let's just remember this, and I am just pulling some code. So let's just pull this code here, and let me just zoom in a little bit. So this is my main file where we have all the slides. So slide 9 is the one which we'll be working on. So this is the last slide that let me just zoom in a bit more. So this is the last slide, which has simple a row and a text field and an icon button. So what we are going to do, we are going to clear the text field on this button press. So let's just create an action. So there's this folder. I've created a folder in which I have created some actions previously for navigating my presentation. So let me just create a new action file, which will be called clear action. And let's create an intent first. Clear intent. Extend intent. So intent is something which is inside the Flutter framework, which allows you to call the actions using dynamically using dictionaries. So I'll tell you why we are doing that, why we are creating all this hassle. You will just understand what's the benefit of creating all of this. So this is an intent which will be used to call our action. So let's create an action as well. Clear action extends action, and inside it we'll give an intent, and this will have an override function. So we'll have to override this. We need to add this covariant for the sake of logic. What we'll write here, we'll just write the logic of clearing our text field. So in order to clear our text field, we'll have to have something that gives us the control over our text field. So we'll have a text field controller here, which will be used to clear our text field. So in order to make this available, we'll have to assign this into our constructor as well. Now what we'll do, we'll just add controller.clear, which is going to clear our text field. Whatever controller we pass into this action, it's going to clear this. So this is a simple code that we can obviously we can just call this single line inside the button press directly as well, but I'll tell you why we are doing this. We are doing this because at the end of the day we have to call this whole thing on an escape button, and that's the tricky part. So let's just go back and to our slide 9 and call this action on a button press. So in order to call this action on a button press, we'll have to wrap this whole widget into another widget which is called action. So here comes the widget actually, and we'll have to provide it the actions parameter, and this action parameter is a dictionary of type and action. This actions is a dictionary which takes your type, like type means clear intent, your intent, and gives you the action that you want. And here we'll pass a controller, like controller of the text field controller. So here you go. You just created a dictionary where we are just picking up the action, the correct action against an intent. So why we are doing that, I'll tell you, when we are going to put that on the escape button. So this is what, when we are defining actions, we need to define it like this. Clear intent, this is a dictionary, it takes a key and it gives you value of clear action. So what we are going to do is we are going to just call some actions.handler context. It will take a type of our intent, clear intent, and it will take our intent as a parameter. Simple. So what we are doing here is we are just calling this actions is not something we created, it's from the Flutter, Flutter widgets. It's inside the Flutter library. So what we do is, this is a simple syntax. We need to call the handler function which handles our intents, and when we call this clear intent, it will automatically pick up the action from here, and it will just pass our controller whatever state our controller is in, it will just pass it into this action, and then our clear action will execute this whole controller thing. So let's just try it once, that if it's working or not, and then we'll see how we'll add it to the escape button. So let's just save it and just move a little bit. I guess there is some issue. Let me just see what went wrong. So let me just restart it. Maybe restarting will get it done. So we restart the application, we'll have to navigate it to the end. This is a little tricky part which I didn't expect to happen. Oh, it's still cannot get, there is something wrong I am doing. Let me just see what I am doing wrong. Clear intent, there is something, yeah, we need to pass the parameters right here. I guess that's the issue. Let's see what happens, if it works or not. Maybe it should work now. Ideally it should work. No, there is some error. Clear intent cannot be handled by an action of a runtime. Clear action, there is something wrong I'm doing. Let me just check what's happening here. Clear action, clear intent. Oh, that's the problem. So this is what we need to do. So now it will, I guess it should work. Okay, so let's just try one more time. This is the whole essence of live code. You always get something special every time. Okay, cool. So we have this, we did all the stuff. So let's just, go back to the stuff again. Once again, what we did was we just called our clear intent using the actions.handler. Our clear intent should pick up the clear action. Our clear action should, pick up that controller that we passed, and it should clear the controller. So let's just go back, just type in something and just press this button, and it's working fine. Cool. So I guess, this is the good part of live coding. It finally works. So now what we wanted to do initially, we wanted to have this good user experience of adding our shortcuts to our, using our keyboard, like keyboard shortcuts. So what I'm going to do, I'm going to add a shortcut which clears our text field using the escape key of the keyboard. So now comes the other class that we are talking about, that was the logical key set. So you see, you need to wrap your whole, home widget or the bigger widget, the outer part, inside the widget called shortcuts. So this shortcut widget takes a map, dictionary, obviously a map, which takes logical key set as a key, and it takes an action or an intent as a value. So what happens is, now my arrow right option says that I need to call the next intent. The next intent is actually this, and it calls, the next page of the controller that we pass, like page controller. So what I'm doing is I'm just, passing the next page into, I'm just navigating to the next page using the next intent. So now why we did the whole intent and all the actions thing. Now you see that inside of slide 9 we have given our action, and inside this we are passing our controller, which is inside our stateful class, and this controller is not accessible here inside. Let me just zoom it if you can't see. Okay, so we don't have access to, to widget specific things inside here. So therefore we use the intents to pass to, to call our actions. So now ideally what we should do, we should just add another logical key set which says that escape key should call clear intent, and that's it. That's just single line of code that we. So now what we did is, if you use actions in all of your application, like at everywhere, whether you want to use shortcuts or not, if you're using actions and intents, then at some point in time you can use the specific function, that specific action, through your shortcut at any time. So after some days that you decide that this is a cool action that I'm performing, that I'm already performing using some button inside the application. So why not I should give it a shortcut. So you just need to write this single line, and you will just, if you have laid down this architecture of intent and actions, then you'll just have to write this one line, and it will start working. Just this intent is going to, just let me zoom this as well, so you just see what the code is. So this intent is going to call this action, and that's that's going to go. So we just added this escape, and let's see what happens when we run the app again. I guess we'll have to go through the slides again. I also didn't expect this as well, that I'll have to go to the slides again. I should have created a button which should just directly land me to slide 9. So let's see, we just added some keys here, and once I'm trying to pull off the escape button, so I'm just doing it on my keyboard. Let's just see, I just pressed the escape button and it's gone. It works like a charm. So this was just a single example of escape button. Let's see what happens if we want to copy the text, or we want to paste it somewhere. So what will ideally do is, I have already added a copy intent already. So let me just show you some code here. So this is a copy intent, same like all the intents that we created, nothing fancy here. This copy intent will be called from outside. Obviously, we'll call it. It's not right now. It's not there right now, but we'll call it. And then what it will do? It will take the controller, and I have some, I have added some logic because it was, it was not, it was giving some index out of bound exception. So I just reverted the base offset and the extent offset of this controller.text just to make it work. If we select, so if we select from the beginning till the end, so the whole offset changes, and if we select from the beginning to the end and from the end to the beginning, so the whole offset signs it reverts. So therefore I've just added this whole logic. So this is nothing, this is just setting a selected string to whatever the controller's selection is. So whatever the controller text is there, we are just selecting it, and whatever the user has selected, we are just putting it into a selected string, and we are just taking it to the clipboard. So this is inside Flutter's repository, and this is a function which Flutter gives us to set the data to the clipboard. So what it's doing is it's just adding the data to the clipboard, and then we can paste it any way we want. So let's just call this copy action and copy intent in our code through the logical key set again, and here we'll give copy intent, and now we want to use two keys to to copy our text. So for the sake of argument, I want to have control key, and I want to have logical keys, keyboard key dot E. So this is just for the argument that we usually have control C for copy, but for the sake of just showing you guys that we can do it as much as we want. Like the whole keyboard is there with us, and we can program any keys to do anything in our application. So what I have done is I have just asked it to add this combination of keys and call the copy intent directly to the code. So what I'm doing is when I press Control E, the text inside the controller, it should be copied. But we need to do one more thing, is we need to add this inside here, so that copy intent should know that I have to call a copy action with the controller. Like we have to call the copy action on this specific controller inside our widget. So we'll have to add this here. So remember, widget specific things are going to be added inside the actions widget, and then we'll have to have the shortcuts in our global sort of thing. So let's just try it if it works. So how we'll check it? We'll just select some text. We'll just hit Control E, and then we'll come back to our code and paste it inside our code somewhere, just to see that whether it copies or not. So let's just, okay, so this is giving me some more errors. Let's see what it's giving. I guess it should be fine if we restart the application again, once again navigating through the application again. I should have given a button. I regret it now. Okay, so we say hello Viking, and we select this, and we hit Control E as per our code. So now if we paste it here, like suppose let's paste it. So see, we got the text pasted, whatever we wrote inside the text editing controller. So this is the whole idea. Like you can put any sort of combination of your keyboard keys in order to perform any sort of action inside your desktop application or web application. So this is the actual power of intents, actions, and shortcuts. And this, you know, we don't realize it in our daily lives, but this increases a lot of user experience in our applications. So I usually use Photoshop a lot to design stuff for the community. So there are a lot of shortcut keys that I'm using, like T, R for ruler, control R for rulers. So there are a lot of other keys that we use in our daily lives, and that we don't realize if they are not there. When they're not there, then we'll realize the power of shortcuts and actions. So this was all about it. Thank you so much, and I'll probably open source the code for this whole presentation, so you can just make up your presentation as well using intents and actions, arrow key, and forward and backward. By the way, it works backwards as well, so you see it works backwards as well. So I have given both the keys to the next and back intent. Therefore both arrow right and arrow left keys are working. So you can build it as per your feasibility. I'll try to open source it as soon as possible. And thank you so much, guys. This was awesome. It's awesome to be a part of Flutter Vikings, and thank you so much. If you have any questions, you can just reach me out to LinkedIn, Twitter. You just type my name on Google, you'll find me. I am Walid Arshad. So if you want to take a look at the name and spelling once again, so you just write Walid Arshad on Google and you'll find me on LinkedIn and Twitter. And I usually reply very frequently on both the platforms. So I have a rule that I keep 0 unread messages on all the platforms. So whoever texts me for any sort of help regarding anything in Flutter or in general, I try to answer them as soon as I can. So thank you so much. It was amazing, and looking forward to more events in the future. Thank you so much. Bye.
Very, very informative and great talk about it, and seeing everything in the works right after you implemented it was also really impressive. I'm sure everyone learned a lot. I also see that Walid is in the chat, so if you have any questions, please just ask him, and I'm sure he will be more than happy to answer you. So the next part is not actually a talk, but it's actually the activity phase. I know that one of the things that you're looking for, because you can actually win some stuff. So that is going to be really, really amazing. And for the activity phase, I would like to invite a special guest, Andrea. If you're in the backstage, let's bring Andrea.
Hello, everyone. Well, I hope you're all having a great time at this great conference. I'm sure we had so many great talks, and I can't wait to catch up on the ones I missed. And there's still lots more to do. So I think, the schedule is just amazing with so many things up until the end of the day. And I guess this is a good time to have a little break and maybe a little bit of fun with a quiz. So for the ones of you that have already done this before yesterday, the instructions are all the same. So first of all, you need to go to menti.com and enter the pin code that you can see shared on the screen right now. And I think we'll just give it maybe a couple of minutes so that everyone has the time to join.
One thing to remind them is about the ticket thing. If you can show it on the slide. So
that's right. And right after that, this is super important so that we can just track the right people. Basically, it will make it a lot easier for us to track the winners. So as soon as you join Menti, you had to use the booking reference that you received in your online ticket. So you can find that on your email from when you signed up for Flutter Vikings. So just make sure that you use that booking reference, because we'll be use this to track all your details if you win any of the prizes. So once again, just make sure you get that. And without further ado, I just want to list the prizes for this quiz. Well, I mean, you might already know that I have a number of different courses around Flutter and Dart. So by taking part of the quiz, you enter a chance to win some of these courses. And so for the winner, you'll have actually free access to all my courses, which are the ones that are currently already available, plus 3 brand new courses that I will be launching this year over the next few months. So yeah, I hope you'll do well on the quiz and get the chance to win all of that. For the second spot, you get free access, but only to the courses that are currently available. So yeah, those will be shared with you. And we are expecting to have quite a lot of people coming up doing this challenge. So for the remaining, well, for the 20 next best answers, we'll also have a 50% discount on all the courses as well. So I hope this will kind of give you a lot of value and will help you along in your Flutter journey. And I guess if we are all good to go, I can already see there's so many people joining, so we can get started with the first question.
Yep.
All good.
Awesome.
So, wow, yeah, there's so many people, so I'm just gonna get it going. So you'll have around 35 seconds to answer each question, and go ahead. And I'm gonna read it for you. So the first commit on the Flutter repository was made in, and the answers are...
Andrea,
Yes?
sorry to jump in, but right now I think there's a problem with the screen. So can you share only the tab that you're in for the questions?
Yeah, I'll see if I can do that.
Okay.
Let me just try that.
Yeah.
Okay, can you see that now?
And let's share it. Let's see it. Okay, perfect.
All good?
Yeah, now
All
we can
right.
see it.
All right, let's carry on. I think the first one is completed, so we can go to the next one. So second question, coming very soon. All right, so this is about when the first beta version of Flutter was released. So I'm not talking about the stable version, but the first beta of Flutter. Can you guess when this was first released? And the options are March 2018, December 2017, June 2018, and September 2017.
Yeah. How long have you been doing Flutter, Andrea? Because
I actually did start around the first beta, so this is
yeah,
actually
exactly.
this is an answer that I remember quite well. It was actually when I've written my first article as well. So
Yeah, I
yeah,
remember that.
it's been a little while. Cool, a lot of interesting guesses there. All right, let's carry on. All right, let's go on to the next question. Let's see, we still have everyone on board, so I'm gonna start it.
Yeah.
So the question is, when compiling a Flutter web application, which renderer is used by default? And the options that you have available are HTML renderer, CanvasKit, Auto, which is a hybrid mode that uses HTML or CanvasKit depending on device, or WebGL. So which one do you think is used?
These are nice questions. It's also showing a couple of interesting points if they have worked with any Flutter web or if they have any prior Flutter experiences and so on. So it's really interesting.
Let's see. Time is up, at least on my side. Okay, yeah. A very interesting set of responses. Yeah, the answer was Auto. All right, let's carry on. So the next question. Let's see. It's coming. So which one of these is not a Flutter widget or class? So which one of those is actually not part of the SDK or doesn't exist? And the answers are shortcuts, platform view link, metadata, or fractional scale.
Wow, that's even a hard question for me. I need to Google that up.
Yeah, honestly, this was a bit difficult. I went on the whole widget catalog, and I'm like, wow, I actually don't know half of these widgets.
Yeah.
What they are. There are
It's
so
really
many.
hard. Yeah, it's really hard to keep track of all of these.
Yeah, I figured there might be some people that really know quite a lot. So fractional scale is actually the answer. Cool. All right. So let's get on with the next one. All right, number 5. So the question is, out of these packages, which has the least number of likes on pub.dev? They are all fairly popular languages, but one of them has the least. And the options are permission handler, auto route, Cloud Firestore, and Google Maps Flutter. I guess with 30 seconds, you might even be able to go on pub.dev and figure it out,
Yeah.
but the time is pretty short. So you might have to take a guess.
Yeah, I mean, maybe there's a block, maybe there's a plot twist around here, so it's really interesting.
Yeah. And sometimes the answer is not what you think it is, but I think people got it right. Most of them
Yeah.
are this.
Yeah.
Cool. Very cool. All right, let's carry on to the next one. All right, so question number 6. And this one is, which version of the Dart introduced null safety in experimental mode? So this is not when it was officially launched as stable, but the first ever version of Dart that supported null safety in experimental mode. So the options are Dart 2.8.4, Dart 2.10, Dart 2.12, and Dart 2.9.2. This is also one that I remember a lot myself because I was creating my first Dart course back then, and I just had all these versions changing, and they changed the way they enabled the flag, and then they made it official. So that's an interesting one.
So all these questions come from personal experiences.
Yeah, a lot of them are.
Yeah.
I have a feeling maybe some of them are a bit hard, but yeah,
Yeah.
we got to pick a winner, right? Cool. All right. So let's go for the next one. Number 7. So which of these folders is not added by default to git ignore when you create a new Flutter project? So as you know, there are a lot of folders that are already git ignored because you don't want to commit those files, and one of those isn't. So which one is it? And the answers are all the prefixes with .svn folder, .pub folder, .vs code, and .idea. So you have to guess which one is not added to the .gitignore file.
Okay, I think this one is the one that I think everyone will feel more comfortable about, hopefully.
Ooh.
Okay.
Some surprising results there as well. All right. Let's go for the next one. Okay, question number 8. So this one is, which ex-Googler now left the Flutter team in September last year? And the options here available are Philip Kracek, I hope I spelled the name right, Emily Fortuna, Matt Carroll, or Craig Labens. So these are all people that have been involved with Google, might have been or might have not been at certain points in time, but one of them left the team in September last year.
Yeah, if I remember correctly, Craig is watching right now, so probably he will be surprised to see his name.
I mean, some people are definitely still in the Flutter team.
Yeah.
Yeah, I think that one had a pretty good response ratio there.
Yeah. Yeah.
Cool. All right, the next question, number 9. So yeah, getting towards the end now. So which of these packages is not a Flutter favorite? And the options are Flutter block, getX, auto size text, and build collection. So yeah, many amazing packages out there. A lot of them are Flutter favorites, but one of these packages is not a Flutter favorite.
Yeah. The options are really amazing as well.
Yeah.
So let's
I'm so
see
tempted
what
to say
people are
something,
going
but
to
I'm not
say.
saying anything.
Yeah, me neither, me neither.
And it looks like, yeah, people guessed quite well on that one.
Yeah,
Cool.
definitely.
All right, so let's go for the last question. Number 10 of 10. Okay, so who created the flex color scheme package out of these people? So we have some Flutter celebrities here. Mr. Remy Rousselet, Mike Ridstrom, Felix Angelov, or Thomas Burkhardt. So which one do you think created flex color scheme? Probably that's another one where you can just go on pub.dev and find out in 30 seconds. But yeah.
Also, if you're using Twitter, probably you have already seen some tweets from the creator of
Yeah,
this
I
because
think yeah, there's definitely a lot of. I mean, to be fair, all these people are very active on Twitter. So
yeah, that's true. That's true.
and here we go. Yeah, good guess for most people
Yeah.
there. Cool. So well, I hope you've enjoyed that quiz. And I think some of the questions were a bit on the tricky side.
Yeah.
We have a leaderboard who is
Yeah.
showing a lot of interesting results.
So,
Mr. or Miss EUWD1, you are the winner. So congratulations, and congratulations to everyone
yeah.
else as well.
Awesome.
Cool.
Yeah. You will be contacting with these people, I guess, or Majid will be contacting these people. So from this point onwards, we just congratulate the others. And
Yep.
also, I would like to thank you as well for taking time preparing these amazing questions. I'm sure people learned a lot today about the history of Flutter and how is it working.
Yeah, it was a pleasure, and I hope it was fun for everyone.
Awesome, cool. So, and I have been introducing several people, and now I realize that I've been introducing actually a lot of GDs back to back. Like I had Sakina, Walid, Alois, and now we had Andrea. And the last speaker that I'm going to be announcing will be another GD. And he's a good friend of mine. It is Dominik Roskowski. He is working for Very Good Ventures. So if you are doing any Flutter apps, I'm sure you already heard about them. He's working there as a principal developer. He is doing a lot of beautiful, amazing stuff with animations and Flutter itself. And today he will talk about animations as well. So first, I would like to invite him to the stage and talk about animations to us. And I would like to say goodbye to you, everyone. And it was a really big pleasure for me to be here and MC these amazing speakers. Thank you very much and have a nice rest of the day. Bye-bye.
Hello there. Welcome to my presentation. I'm Dominic. I'm a Flutter GDE and I work at Very Good Ventures. And today we're going to talk about animations in Flutter and how to improve your animation skills. I hope that after this presentation you will leave with some more inspiration how to improve your animation workflow when doing Flutter applications. If you have any questions, feel free to drop me an email or find me on Twitter. And also, if you're interested, at VGV, we are hiring right now. So if you look for new opportunities, head over to Very Good Ventures/careers, where you can find more about all the positions that we have open. Let's jump in straight to the topic that we're going to discuss today. So, like most of you probably at some point tried doing some animations in Flutter, and there is like this popular notion that in Flutter animations are like one of the easiest and most convenient thing to do, and today I'd like to support this with some examples. So every application has some kind of animations, right? It's like a trivial sentence, but I just also want to the people like understand all the people that maybe don't have much experience with mobile that animations are a vital part of the mobile application market right now. Every app that tries to conquer the market needs to have at least some degree of animation support, some micro interactions, some specific features that actually can drive the user engagement. And some of the most popular apps use it heavily. So in the center of the screen, you can see Reflectly, one of the most popular Flutter applications, which like uses animations as one of the main features. It's like the driving force for this particular app. But many other applications also have this kind of notion that the animations are, for instance, gratification for the user engagement, or they make you feel more important as a user because some animation is like dedicated for you. So there's many ways to do it in Flutter, and today I'm gonna show you from like the basics up to some more complicated use cases how to make that happen. So again, over and over, you will probably hear that there's like implicit and explicit animations. And frankly, when you work with animations like on a daily basis, you rarely like think about like whether you want to use one or the other. I think it's more natural thing to do. Like sometimes it will feel more natural for you to just try out and make quote unquote implicit animation. And in other times, you will just have to implement your animation controller and make it much more elaborate than with just a simple, I would say, widget. So implicit animations are like the go-to tool when you have to animate something simple, something quick, maybe as a result of some kind of state change. So for instance, on this slide, you can see the animated container. An animated container is like a generalized solution for the implicit animations. You can animate almost anything inside the animated container. Quick side note. Together with this presentation, I have prepared a simple application. This is also available as a Flutter web application. The link should be somewhere in the description and also at the end of the presentation. And in this application, we have several tabs, and each of them has some examples that will correspond to the slides that we have. So for instance, you have noticed that I had animation inside of my presentation, but if you want to try it out, you can just click here in the application. There's also source code available if you want to see how it's been done. At the beginning, everything will be almost trivial in the implementation. However, at the end, we'll have some more interesting cases. So just for those that may not be aware of like the basics of the implicit animation, right? Here we have the animated container. Whenever you click on that, some properties of that change. We have also some other animation, implicitly animated widgets. So for instance, here we have the animated opacity. So whenever you click on that, the opacity changes, right? From 1 to 0.3 and then to 0. And here we have also another interesting case of animated, implicitly animated widget, which is animated physical model. And this is, I would say, very interesting because this shows this aspect of Flutter that you can find widgets for almost any use case that you need. And animated physical model is one of the most, I would say, odd or like uncommon widgets that you will try to use, but at the same time, it's everywhere. And if you want to learn why, I recommend just head over to the documentation about the animated physical model. So we have a bunch of these implicitly animated widgets, and for most of the use cases, you should be able to use some of them in your app. Like animated padding will make the padding animated. Animated switcher will switch between two widgets that you provide, and will try to animate between them. So yeah, as I said, at the roszkowski.dev/animation, you will find the application as a Flutter web application, and you can just try it out for yourself. So how to use implicitly animated widgets in your code, right? The usage is like trivial, right? If anytime you have some animated widgets, it will start with the prefix animated, and it will mean that usually it's either implicitly animated, with some exceptions where it's not implicitly animated, but you have to provide some animation. But here we have animated align, and the only thing that you need to do is to change the property of this widget. In this case, alignment, right? So here on the onPressed, I just set alignment to some random value. And also if we go back to our example application, if you click on that, you will see that it just changes the alignment smoothly between some predefined values. Really easy, nothing to be worried about or like concerned. However, sometimes you need to make something more custom, right? So let's say none of the provided by Flutter widgets can support your need, or you just feel like you use like 3 or 4 different implicitly animated widgets, and you maybe want to generalize or unify this somehow. And here where custom implicitly animated widget can come and help you. So in my case, I came up with an idea of having a loading indicator. So this loading indicator is just a typical circular progress indicator, but with a smooth transition between steps. This can be helpful, for instance, if you have a download indicator or upload or this kind of stuff, and you want to show to the user some kind of smooth indication of a progress. So in order to implement the smooth loading indicator, you will have to use the implicitly animated widget class. You can compare this to be almost the same as stateful widget in a structure, right? So implicitly animated widget has some description, similarly as to the stateful widget. Here you can provide any API that you want. I just provided progress, color, and background color. An important part is that you have to also have the implicitly animated widget state. Let me move myself to the right. Yeah. So implicitly animated widget state is something equivalent to the state in a stateful widget. So if you go further, you will see that the implicitly animated widget state just extends animated widget base state. And in this, you will have your build method, right? The one that will return the widget that you want to animate. So for instance, here we have the circular progress indicator, the thing that we've just seen in the animation. And it has some properties like background color, and value. Usually when you have a value, you provide something like 0, 1, 1.0, or you don't provide the value and then it just spins indefinitely. However, what we do here is that actually we call the evaluate on the tween that we have here. And where does this tween come from? And we're going to talk about tweens in the one of the next slides, because I know that for some of you at this moment, tweens can be a bit something new, right? So let's focus for now on this particular widget, and then we're gonna look into the tweens in particular. So the animated widget base states requires to override also another method called for each tween. So this widget will call this method for each frame, and what you have to do is that you have to call also function provided by this method, right? So here you will receive a function called visitor, and you have to call this with the parameters that you have access to. So the progress is the current value. So this, as you set state with your parent widget, let's say you will receive an information from your API client, HTTP client, that the progress is now not 0, 0, but 0, 1. Then this will be called because you called, for instance, set state, or maybe your change notifier was called with notify listeners. So this will be called, and the current value will be provided here. Then you have to provide the target value. So what I do is that I take this progress value that I just received from the parent, and I clump it just to be safe between 0, 0, 1 and 1, 0. We don't want to provide, for instance, 1.2, but it's just like redundant security. And then the third important part is this callback, where you have to provide a tween. And tween has this nice property that you don't always have to provide an end parameter to that. So this value that you will get here is the value of this will be called by the animated widget base state between the previous and the current value. So for instance, between 0, 0 and 0, 1. And this tween will be used to interpolate the value of your animation. So in this case, it will be linear interpolation of a double. So the value that I have here will be interpreted as a double and will be just frame by frame interpolated between 0, 0 and 0, 1. So let's see in practice how it looks like. So I also have this widget up here. So if I click, you see that it smoothly goes from previous value to the next one. As you can also see, I use it not only for the progress indicator, but also for the just textual representation of a percentage, right? So you can see that here the value changes immediately from 0 to 0, 2, and this smoothly goes through that. So if you would like to see this, we can just go to the smooth. I need to find this, sorry. So implicit and implicit loader. So here, if you go to the GitHub repository, you will find a smooth loading indicator. There is a serial progress indicator, and also there is a counter. So smooth counter is also implicitly animated widget. And in this case, what I do is just for each tween, I just take my double value, and then I just put this double value inside of a text, right? And I format this to be in percentage. Nothing fancy, just a very simple usage of implicitly animated widget. And trust me, in many cases, using implicitly animated widget should be just fine. I saw my colleagues and other developers, after seeing this example, just trying out this implicitly animated widget with various different kinds of use cases. So just to recap, if you want to implement some kind of more uncommon implicit animation, you may be able to use implicitly animated widget. You can provide any type of value to that. It's all up to you, whether you provide a string, integer, double. If you can interpolate this value, you should be good to use it. And this is useful when you cannot find any suitable implicitly animated widget. Like I would say that the good thumb rule could be to just like, if you need to use more than 2 or 3 implicitly animated widgets to implement your feature, then maybe it's worth looking into the implicitly animated widget as a custom solution. Of course, the next level when doing animations are explicit animations. And this means that in this case, you will have to drive the animation somehow on your own. Typically, you would use something like animation controller. And this animation controller is a class that hooks up to the Flutter engine and allows you to get some more, allows you to synchronize your animation with the Flutter frames. However, sometimes you may skip also the animation controller and use something different, and we're gonna look into that later. And when you have animation controller, you can create something like animation object, and then this animation object can be used for various widgets like scale transition, faded transition, or animated widget. And in my example app, you will find a bunch of different custom animations. I've been doing these and publishing them on CodePen, right? And here you can find some of them, and we're gonna look into some of them today. In particular, we're gonna look at this very simple animation that I have in the bottom left corner. But if you'd like to maybe learn how this kind of Flutter animated logo has been built, or like this animated Slack logo, the source code is all here, and you can just browse and see for yourself. So let's have a look at this particular guy. So in this case, we just have an icon button in this particular example, and we have a glowing border around it. Whenever you use animation controller, you have to instantiate this and provide something called vsync. And vsync is a way for the animation controller to know when each new frame gets rendered by Flutter engine. And you can get this from the ticker provider state mixin or single ticker provider state mixin. In order to engage or like start animation, you have to call forward on the animation controller. And in my case, I wanted this animation to repeat indefinitely and also with reverse. So you can also call repeat and reverse with true. you also need to remember about disposing the animation controller whenever your widget gets disposed. Then, if you want to use the animation controller, you would usually use something like Animated Builder. Animated Builder can accept any listenable. So, for instance, if you have even like your change notifier or block, you can use the same here as a dependency. In my case, I've implemented this, that I use a decorated box, and what I do here, and my child. The child will not be rebuilt with each frame. However, anything that's in the builder will be rebuilt with each new frame as the animation controller is moving forward. So in my case, I have my decorated box with some decoration, and here what I do is that actually I'm animating a padding of this container, right? So the padding changes from 8 to 0, because the animation controller will cycle the value from 0 to 1, from 0 to 1 each second. And here I just have my icon button. We can quickly go back here, and then, as you can see, this is how it works. You can also find this in my sample. So for instance, you can go here and you will find animated radiating icon and the same source code for you to browse. So you noticed that I've used Animated Builder, and Animated Builder is a very handy widget that you will most often use when working with animation controller. What it does, it accepts animation controller and listenable, and here the builder will be rebuilt anytime a new frame or a new tick is scheduled by the animation controller, and the animation controller will know this based off the widgets binding from Flutter engine. I mentioned twins several times already, and I wanted to clarify more or less what are they. And I know that for many people at the beginning, twins are not something intuitive, and I wanted to make it more intuitive for you guys because I know that it's very useful. So I found that twins actually as a term appeared much earlier than programming languages even became a thing. So for instance, anytime you maybe when you watch like an old cartoon, like some Hanna-Barbera or some kind of Bugs Bunny or whatever, or Flintstones, you may notice that sometimes the characters in the animation appear to be like smudged, or like they are not super in focus, or however you would like to call it. And actually tweening or in-betweening was known in the animation industry many years ago. One of the biggest companies that used like heavily used tweening also in computer animated graphics was Pixar. And in-betweening means that you give like the appearance of motion for an object. So you don't draw every frame, every movement of a character as a frame of the animation. You maybe draw the character a bit smoothed, like with like no detail, just to show that, for instance, the hand is moving or the character is running. I highly recommend you to look into this article about tweens in the graphics animation, but I hope that this gives you like a nice hint of what a tween in Flutter actually is. So tweens are objects, classes that allow you to interpolate the motion, or in practice any kind of value that supports interpolation. So you can imagine a case where you have something that goes from 0 to 1 and want to map this to not be between 0 and 1, but maybe between 20 and 100. And tweens allow you to do so. So for instance, in the case here, and these two usages are exactly the same. Sorry about switching. And these two cases, something's wrong with my presentation. No. So these two code snippets are the same in the effect, i.e. they will give you the animation object. What's important, you can drive the controller with the tween, or you can animate the tween with the controller. So this is equivalent to each other. So for instance, maybe as you remember, controller will give you value between 0 and 1 by default, but you can map it onto some different scale. So for instance, in this case, what I want to do is that I want to map the value of 0 to the offset of 150 and value of 1 to offset 200 and 300. So it means that the object can be animated or like moved using this controller, but in a completely different scale than 0 and 1. And this is very handy. You can apply many different classes here. And then, for instance, if you have animated positioned or like just a positioned, you can just animate the position of a given object on a screen. And in my example app, I have prepared like an overview of how to use tweens. So for instance, if you go to this page, you will notice that there's a bunch of different behaviors or characteristics of a tween. So when you are using tween, by default, you will map linearly from one value to the other, right? So the value 0 will become 50 and value 1 will become 300. And in between of these values, the value will be linearly rising. However, sometimes you want to make it a bit more smooth, or maybe your movement shouldn't be like super exactly linear. You want this to be more natural, like physical, and this is where you can use curves and apply them to your tween. And in practice, every time you have any kind of interaction with the user, any kind of button, any kind of bottom sheet sliding up, this kind of stuff, you never want to have linear behavior. You always want to have a bit something that's eased or smoothened. So for instance, often you can use curve called ease that will just ease the movement all through the timeline, or you can also use something called let's say in this particular case easing out or decelerate. The decelerate is often used if you have something like iOS-ish UI. This looks pretty good. Sometimes maybe you want to show like a winner badge to the user, then maybe bouncing or something like elastic could be pretty nice to use, because then it just gives you this appearance of surprise. And how to use these curves with your tweens? It's also pretty easy, because when you have a tween, you can wrap a tween with another tween or something with a called curved animation. So curved animation is a class that will accept any curve that you like. So for instance, if you go to my presentation and find tweens, you will notice that I use a bunch of different curves, and I just apply them with my on my tween. So my tween is of offset between -2 and 2. So this is like what you can see here, from -2 to 2. And I just apply different curves onto this tween just to show you that you can modify a tween just with a simple operation. Important part is that you can actually provide your own custom curve. So if you go to any of the curves that are defined, you will see that every curve just allows you to define some method, like for instance transform internal, and here the Flutter team just used something like bounce function. There is some maps involved, and you can of course create your own function. Let's say maybe you'd like to have a sinusoidal movement, or maybe something more complex, maybe something more custom just for your application. You can do this very easily. When you have tweens, you also have something called Tween Animation Builder. This is, I would say, a handy way to not worry about animation controller and still be able to use tweens. So on the right side, you can see that we have a Tween Animation Builder class widget, and we can provide a bunch of different properties, very similar to what you can provide to animation controller. However, in this case, you will have you will not have to instantiate the animation controller, and the animation controller will be disposed by you. The difference is that you cannot customize the animation controller. So for instance, in this case, you will receive the, you will have a builder and a child, same as with animated builder. In this case, you can just apply a tween. So what I do here is I just apply tween between 0 and 1, and also this accepts a scale, so I can override the scale, and whenever the scale changes, so whenever I rebuild this widget, this tween will also nicely animate. Let me show you what I mean. So here's my example application, and maybe you have noticed that when I open this, the text and the Flutter logo actually animated from 0 to 1. So let me go back again, and you can see. So this was the actual code that you have seen here, where tween animation builder was animated between 0 and 1. And I can also change this value maybe to 10, and you can see that it changes to 10, and also I can change it to 30, and then to 1, and to 10, and then to 30, right? And the nice thing about tween animation builder is that, for instance, if you need to continuously or like several times change your value, you can do this easily with the tween animation builder, and it will remember the previous implementation. So this is the previous value. This is similar to what implicitly animated widget can do for you, but it also allows you to apply a custom curve, right? So this is handy, and you can also interpolate custom values. So you can sometimes choose between the implicitly animated widget custom or Flutter, the tween animation builder. The next important thing with animations, and this is often visible in many applications, are staggered animations. And staggered animations are sometimes used, for instance, to indicate some entrance or to make some kind of more complex process a bit more acceptable for the user. So let's have a look at how we can do this. So here also in the example, you will see the staggered animation example. You can also like pause in the meantime. So let me play. Right, so we can see first the top thing comes, then the second row, and then the third row. So how you can do this? Let me show you. So there is like official guide how to do it, but I find that you can make it a little bit more friendly for yourself or also for your colleagues. So what I usually do in such cases, if I need to implement a staggered animation, is that I create my own builder, right? So this is, you remember, animated builder is just a widget in Flutter, and what you can do is you can also create your own animated builder, and this is this one I just called homepage animated builder. In this case, I'm just wrapping the animated builder, and I have my transition builder. My transition builder here is just typedef, and this typedef defines that it will accept a function that can return a widget, and this function will accept context, child, that will be not rebuilt, and something called home page enter animation. And home page enter animation will be my custom class. And this class, you can just think of it as a state class or a description class. And this class will have a bunch of different properties, which will be animations. And in the constructor of this class, I will just define some properties. So for instance, if I want to animate my header between header opacity between 0 and 1, and this is actually what is happening here. So if you go back to the application, you will notice that the header, when it comes, it's here at the top, sorry. The header as it appears, it fades from 0 to 1. So what I do is that I apply something called curved animation. You remember this was with the we used this with tweens to apply custom curve, and then our curve won't be any of the built-in Flutter curves. It will be our custom curve or like custom interval of a curve. So there's a class called interval, and you can apply a given fraction of a timeline to be used for this animation. What I mean is that here my interval is from 0 to 0.2, and I apply curve called ease in. what it means that the ease in function will be applied and the movement will happen between 0 and 0.2 part of this animation. And then the other animation for the row 1 offset will be applied between 0.1 and 0.25, and then the other between 0.15 and 0.30. So let me show you what it means in practice. So here, whenever this animation appears, right, this was done in the first like 20% of the animation duration, then this was done in like another 20% of the animation, and then in another. This was overlapping as well, right? So it didn't happen one by one, it was actually overlapping one onto another. And what I really like about this solution is that if you have this two classes, the builder and the animation definition class called in my case homepage enter animation, you can call it whatever you want, then you can just use your homepage animate builder. You still need to provide the animation controller from somewhere, so I just pass it from upper widget, and here I have my homepage animated builder. And what I do here is that I just can access the animation properties in my builder. So here I just access animation.header opacity.value. Then for the opacity and for the slide transition, I can just pass the animation. So I just pass animation.row1 offset and so on and so forth. And sometimes you can even get a specification for your animation in a way, in a form of a timeline. So for instance, in this case, you can have a text field opacity, then text field transition, button opacity, button transition, and then for instance, button color. So you can have a really complex animation, but the moment you need to implement this, you will always break it down into smaller pieces of the animation, try to put them onto your timeline, and then this way you will be able to implement this just by using like a simple class for each of the properties that you want to animate. I really recommend trying this out. For instance, the same approach was used for the Flutter puzzle that we've built at VGV for Google, and you may look for the presentation by Bart, how they implemented the Flutter puzzle theme with custom animations. They use the same approach, and I think it was implemented pretty like robust, and you can just also learn a lot from this example. And sometimes you have to go on a lower level with your animations. So you may not use just the animation controller, but maybe something more powerful or more customizable. And what I usually do in such cases is that I use change notifier. So change notifier will just allow you to call function called notify listeners. So if you have any listeners for that, for instance, animated builder, you can trigger a new rebuild of this widget. And important part is that you want to synchronize this with the Flutter rendering new frames. So what you will do is that you will use the vsync, the same thing that you passed to your animation controller before, but in this case you will just handle this manually. So what you can do is that when you receive a vsync, and vsync is just a ticker provider, so for instance single ticker provider mixin, you will create a ticker out of that, and this ticker will give you a method called onEachTick, and in this method onEachTick you will be notified how much time has passed since last frame, and you can do whatever you want with that, maybe do some calculations, await for some result, anything you need. And you also need to start this whenever you want to start the animation. So I have prepared, I would say, a bit more elaborate example here with Boyd's simulation. So the Boyd simulation is just simulating flock of birds, and in here you can just modify some properties of that. The birds can be a bit more willing to stay together, or maybe it can be faster, slower. You can also make their number a bit bigger, and the full source code is available, and you can just see how they operate. The funny thing is that at some point they just become like a one big blob, and I think they just went away. Yeah, not sure if they can come back. Yeah, so you can see they behave strangely if you put some different properties, but I hope that you can just see for yourself. Let me just reset them to be a bit more comb. And this was actually implemented with change notifier. Some maths is done in between. So for instance, if you need to calculate the position, you can do this on the side. Sometimes maybe you don't have enough time to calculate everything, so you can just optimize this and maybe just calculate roughly, right? Because you will know how much time has passed since the last frame. And for instance, if you want to achieve 120 frames, so you can just assume that 1 second by 120 is 0.08 of a second, so 8 milliseconds per frame. It's not much, but you can, for instance, have some more like you can maybe divide the calculations between 2 frames, whatever you need, just to optimize for this time. So just to quickly recap, ticker provider is a thing that will let you know when a new frame gets built, and you can out of that you can create a ticker, and the ticker will have a callback, and this callback will be called every time a new frame is built, rendered by Flutter. Another very interesting thing in Flutter is physics simulation. So Flutter comes with several physics simulations. So for instance, you can have a spring simulation. This is used in some vanilla Flutter widgets, and how to use it is very simple. When you have a spring simulation, you just provide some properties, for instance, mass, stiffness, damping. If you ever studied some kind of engineering topics, you may recall the spring equation. These are actually the things that you provide here. And then when you have your simulation, it sounds very like cool, right? You have a simulation, then you use the animation controller with some high upper bound, because this animation won't last between 0 and 1. This can last much longer, and you rarely know how long it will take to finish the simulation. And then you can animate the controller, the simulation with your controller. And this is all that you need. You will receive some values, and you can use these values out of the controller to show something on the screen. So the controller's value will indicate the value of a simulation, right? So in this case, the spring simulation, I'm not sure if I can click on that to make it move. No. You can see how something would appear as a spring, but also we can do something more cool. Like in this case, you have the ball, and I implemented this with gravity simulation. So I can drop the ball, it will try to bounce, and this way you can have like a very basic gravity simulation. Again, the source code available in the repo. At the end of my presentation, I wanted to leave something about performance measurement. So we can have all the animations we want, but if they appear sluggish, janky, you will have a hard time convincing your client or maybe your users to like them, right? And there's a lot of possible optimizations that you can do, and this is a topic for another talk, maybe on like a real life in-person conference. So stay tuned for more information about this. However, the most basic thing that you can do to optimize or to see if there are any problems with your animation or with your performance of your app is to use performance overlay. This will render a timeline of how much time it takes to render something for your app. And of course, right now I'm running the debug mode, right? But if you would run profile mode, it would be even more interesting. So let's say performance overlay. So when you use VS Code, you can just call Flutter toggle performance overlay, and you will see this in your app. So if I go to my custom animation, you will see that, especially in debug mode, there is some junk, that not all the frames get rendered equally well. And it depends, of course. And the nice thing is that after time, Dart compiler is so smart that it would just optimize the code even in debug mode. But you can also run this in profile. This is really interesting. And another thing that I sometimes use is FPS widget. Here I have just some kind of basic implementation of that. There's many packages that allow you to do so. So for instance, here I can see how many frames I can see on my screen. So 60 frames easily, with some junk, of course, because of the debug mode. But it works pretty nicely even in debug mode with all these animations. If you happen to have any problems, then the Dart performance, DevTools performance page can be handy. This is a beast. Let's recap what we have learned today. We have a myriad of implicitly animated widgets, and you can use them almost like any other widget in your app. However, if you need, don't hesitate to use animation controller. It's not bad to use, it's really handy sometimes and gives you a lot of possibilities. Sometimes you can use just Twin Animation Builder and you should be good. You don't even have to instantiate your own animation controller. Then, of course, there's a possibility if you need to create something like custom controller. And this would be, for instance, change notifier. And if you'd like, you can even use block or anything like that. Just use ticker provider. Then, if you need to do some kind of funny or even interesting simulations, you can try Spring simulation, gravity simulation. If you want, you can just take the existing simulation and create your own. Maybe you like to make a bit more advanced gravity simulation that takes into account the aerodynamic drag or something like this for your game. And of course, there is much more to learn. And like every month, possibly, a new animation related package or video is presented somewhere on YouTube or Twitter or Reddit. So definitely, if you want to learn animations in Flutter, there is a ton of knowledge. What I can recommend is that, for instance, I want to recommend you like the animations package, the Flutter Europe talk about animations, and also the talk about performance measurement. And also, when you're a developer, you sometimes forget, we sometimes miss the joy of building animations and all these like front-end related stuff, because there's like business stuff to be implemented, some API calls, maybe some hardware integrations. But frankly, for me personally, I find the most joy when building the app UI, and animations. So if you can, maybe try to and do this kind of tasks from time to time, so that you can have some more experience and also more joy in your life. And this is what I really wish you for this year, and also for your work, so that you will be joyful and you will get as much satisfaction from your work as possible. My name is Dominic, and you can find me on Twitter, on my website, and also the source code for this presentation and slides is available on my GitHub. Thank you very much for watching, and I hope to see you soon, maybe in real life. Thanks a lot.
Hi everyone, and here's Evgeny Kot, and now I am the boss of this stage, and my job here today is to prevent you from sleeping. Thank you very much. Thank you very much. I love you too. I love you too. And please welcome our next speaker, and I need other sound effect. Our next speaker on this stage is, where is the drum roll? Is Chris Swan, and Chris works at company, and he would talk about full stack Dart. Please welcome.
Hi, I'm Chris Swan. Welcome to my Flutter Vikings talk on full stack Dart. So I'll start out with a brief introduction of myself. I'm an engineer at the At Company, where we're building a platform that puts people in control of their data. The way I describe this is we're giving everybody and everything on the internet a tiny little server so that they can store their data there and be in control of who has access to that. I'm also the co-host of the Tech Debt Burn Down podcast, a cloud editor at InfoQ, and I keep a blog at thestateofme.com. You can find links to all my socials, etc. at chris.swans.net, and I'll have some contact information at the end of the deck. So here's my agenda. I'm going to start off talking about why Dart. Why is it relevant to talk about full stack Dart? And then look at some of the trade-offs between just-in-time compilation and ahead-of-time compilation. One of the great things about Dart is having those choices, but that means that you've got to actually make a choice between one or the other. I'm going to talk about Dart on Docker and look at what's involved in creating Docker files and building images, especially images that contain AOT binaries. I'll touch upon the functions framework for Dart because this is something that Google have created to make it much easier to build functions-based backends using the Dart language. And take a look at profiling and performance management. Dart, as a relatively recent language, has got some amazing tools built into it. So things that have previously been paid for third-party extras for lots of other languages come in the box with Dart and very easy to access. Then to look at back-end architectures. And so we now have great choices between x86 and ARM architectures, but there's some trade-offs involved in choosing those, particularly when looking at how we manage continuous integration and continuous delivery pipelines. Then look at other places where you can learn more, and I'm going to finish with a call to action, which is try out the Dart framework function example. The really good way of just kind of getting in and trying something out quickly. So why Dart? Well, let's start out just with a reintroduction of what Dart is and what it was put into the world for. Dart is a client optimized language for fast apps on any platform. You can find out all of the core information about Dart at dart.dev. But this is a Flutter conference. So if you're using Flutter, you've already come across Dart as the thing that's underneath Flutter. And in fact, Flutter is the thing that's really pulled Dart into the top languages. So there's a research company called RedMonk, and every 6 months they produce a languages ranking. That's created by looking at both GitHub and Stack Overflow to see how much people are using languages and how much people are talking about using languages. And from that, they compile a top 20 and they take a close look at the languages that are up and coming. So at the start of 2021, Dart was identified as one of the up and coming languages, and that was being driven by Flutter adoption. And then as we got to summer of 2021, and the most recent report at the time that I'm recording this, Dart had just made it into the top 20, displacing Perl from what had been there before. And so you can see the languages above Dart in popularity at the moment are all pretty familiar names. They're all very popular languages. But Dart's established itself now in that list. And that's largely because of the popularity of Flutter as a back-end language, as a front-end language. So if you're attending a Flutter event, you're probably writing Dart already. So why not use it for the back end as well as the front end? And I think that's the thinking behind this idea of full stack Dart. All right, so let's look at the different types of runtime and compilation that Dart makes available to us and the trade-offs between just in time and ahead of time. So I've got a trivial application here called Dart Show Platform, which I treat as being a more useful version of Hello World. And when it runs, it prints out some platform version information. So exactly the same kind of information you'd get if you ran Dart minus version, but it's just a simple application that's doing that. So I'm importing Dart.io, show platform and standard out, and then avoid main to print platform.version. And the example output of that is below there. So you can see at the time that I ran this to create the slide, I was running Dart 2.14.4 on a Linux machine on an ARM architecture. So with just in time, I can take that Dart source file and run it in the Dart virtual machine. And if I put the time command before that, I can see how long it takes. So in this case, you can see on the particular device I was using, that trivial application took a little over 6 seconds to run and produce its output, which is quite a wait. So that's the time that it takes to spin up the Dart VM, to turn the source code into bytecode, and then to run that bytecode and show some output. So we can do a lot better than that because that's what's typically known as the cold start problem. We've started from zero, and it's taken quite a considerable amount of time to run something that's got trivial output. And if we're trying to run Dart in this way on a back end, we don't want our users waiting all of that time for the Dart virtual machine to spin up. So ideally, the Dart virtual machine will already be spun up, and better yet, because it's got a just-in-time compiler within it, we'll be running the same code time and time again so that the just-in-time compiler can optimize across those runs. So our alternative is to do ahead-of-time compilation, compile the application first and then run the binary. So we can do this with Dart compile exe, show platform.dart, and then we can time the execution of the execution time of the binary produced by that. And so in this case, we can see that it takes about 28 milliseconds to run a trivial application, which is much more like it. So no hanging around for 6 seconds for the VM to start up, just a really snappy output from the application. But of course, there's a trade-off with this. The compilation process itself is slow, or comparatively slow. So if I time the compilation process, we can see that that's taking in the region of 20 seconds in order to compile the executable into that platform native binary. Now, in many cases, this isn't going to matter because that compilation time is going to be taking place within a build pipeline and users aren't going to be experiencing that. So it's a minor hit at build time in order to give much better performance at execution time. But bear in mind as well that when using ahead of time compilation, there's no opportunity for the virtual machine to optimize across the code paths that it's seeing being executed. And so ahead of time binaries may not be quite optimal versus a long running virtual machine. Okay, so moving on then to Dart on Docker. Here's a typical Docker file for an ahead of time compiled Dart binary. And it's a two-stage Docker file. So at the first stage, I'm using from Dart, and I'm declaring that as my build image. And this is taking the Dart official Docker image and setting up a working directory, copying some code in there, running pubget in order to fetch some dependencies, and then compiling the executable into a native binary. We then move into the second stage of the build, and we're starting off then from the scratch image. And the scratch image is a special image which is just 0 bytes. It's completely empty. Now, Dart doesn't create statically linked binaries. It needs dynamic linked runtime underneath it. So essentially libc and a bunch of other dependencies. But they're all collected for us in the runtime directory within the official Docker Dart image. And so we can simply copy those from build into the root directory of the scratch image. And then with those in place, we've got the minimal dependencies for the linked application, and we can copy the application in and define an entry point into that application in order to run it. So if we look then at the image sizes for that trivial application, they're pretty small. The application itself is tiny, and the runtime dependencies are also relatively lightweight. So we can see on an x64 platform here, it's just under 4.5 megs, whereas on an ARM v7 platform, it's just over 3.2, with ARM64 on v8 somewhere in the middle there. And it's actually not much different for a non-trivial application. So here's a snapshot that I took of our secondary server. So when we say that we're running a server for everybody on the internet, these are tiny containers that have got compiled Dart native binaries inside of them. And you can see that those binaries are ranging from 5 megs on ARM to 6 megs on AMD 64. So turning to the functions framework for Dart. So this can be found on GitHub at Google Cloud Platform functions-framework Dart. And the framework is there to provide a way to write lightweight functions that can run in a variety of different environments. So they can include a local development machine, Google Cloud Run, and there's even a Cloud Run Quick Start, Google App Engine, or Knative based environments on top of Kubernetes. And to quote the page here, Google Cloud Functions does not currently provide an officially supported Dart language runtime, but we're working on making Google Cloud Run as seamless and symmetric an experience as possible for Dart function frameworks projects. So what that's essentially saying is we can't just take Dart code and run it on Google Cloud Functions because it's not supported, but we can take Dart code, put it into containers and run it on Google Cloud Run. And the functions framework is making it super easy to write Dart code that implements functions. So let's take a quick look at what that looks like. So from the examples of really a hello world kind of an example here, just importing a couple of things. So the functions framework itself and a package called shelf. We're then declaring a cloud function and saying that the response from that function to a request is going to be response.ok hello world. And having then built that, we will get from the build process an app URL. And from a command line, we can run curl against that app URL and we will get back hello world. And so all of that's been done without any need to worry about writing an HTTP server or request handling logic or any of that plumbing kind of work. That's all just been taken care of. And so that leaves developers to simply concentrate on their application, the data management that's going on within it, and the business functionality provided. Moving on then to profiling and performance management. So if you've been building Flutter applications, you might already be familiar with Dart Dev Tools. But if you haven't come across Dart Dev Tools already, then it's a really excellent set of tools that come with Dart that help you understand how your application is behaving and performing. And so the suite of dev tools includes a debugger, a logging view, an app size tool, a CPU profiler, a memory view, a network view, performance view, and Flutter inspector. And you can see from this table that that complete suite of tools is available to developers for Flutter mobile and desktop applications. But aside from Flutter inspector, all of those tools are also available for developing a command line Dart application. And that means that if you're getting into full stack Dart, you can use the same dev tools for the front end and the back end in order to understand application performance. So here, for example, is the memory view. And this is particularly useful for understanding what's going on with things like garbage collection. So the view is giving indications of when garbage collection events are taking place, and that will help understand when the application might be pausing because of a garbage collection. It also gives a great indication of how much garbage the application is creating and how much stress is being put onto the garbage collector. And there's often lots of ways that the code can be redone in order to minimize garbage creation and maximize performance as a result of that. Flame chart is an ideal way of understanding the call stack and where time is being spent in parts of an application. So this is really useful for diagnosing possible performance issues and where they can be localized. But there's a little bit of a gotcha when it comes to the back end, because DevTools need to connect to a virtual machine. And so DevTools can only be used with the just-in-time compiled approach to running applications. And so I reached out to one of the Dart SDK core engineers who's published some great blog posts on the topic of Dart performance and profiling, and asked him about whether it would be possible to get metrics out of an AOT binary. And you can see from his answer here that it is possible, but it is a bit complicated. And so his suggestion to me was to go and compile my own SDK and change some of the parameters to do that. And this is the first time I've come across things that would make me want to compile my own SDK. But it's a complicated endeavor, and it's also something where once you start doing that, then you also then need to keep up with SDK releases, so it becomes a bit of an ongoing overhead. So that's not something I've done yet with the AOT binaries that we work with. What we've ended up taking as our approach instead is where we're trying to identify performance issues, we will actually switch from the AOT environment into a VM environment and then connect the Dart DevTools to that. And we refer to that as an observable secondary. So if we're normally running a secondary server and having a very small footprint with that, the observable secondary's got a slightly larger footprint, and it has the startup time associated with the cold start of the VM. But actually, once that's started up, we can then start getting a lot of the Dart DevTools data out of it to understand the performance of the application. All right, so looking at some of the options for back-end architecture then. So the Dart SDK supports all of the popular operating systems and associated architectures that go with them. So Linux, macOS, and Windows are all supported as of Dart 2.15 across these architectures. So you can see it's a little bit more of a wide range on Linux. So we've got x86 64-bit and 32-bit flavors, and ARM 64-bit and 32-bit flavors. Whereas on macOS, we've now got full ARM support for the new M1 chips, which is a good thing. And then on Windows, there's x86 for 64-bit and 32-bit, but no ARM support. So I think about readily available in the cloud. Most cases, I'm certainly not willing to pay for a Windows license just for running some binaries. And so the operating system choice normally defaults to Linux for that reason. And architecture-wise, in the cloud, x86 64 is the typical default, but ARM v8 is becoming much more common and generally has the better performance price point. And that performance is often greener as well. And so using less energy and thus being more sustainable. Then if we look at IoT platforms, it tends to be ARM all the way. Now, there are IoT platforms that use other architectures like MIPS, but MIPS isn't the supported architecture for DARMs. for Dart, so that's kind of irrelevant. RISC-V is coming along, but again, no support from Dart on that yet. And so really that kind of focuses our effort onto ARMv8 and ARMv7. So with Docker, there's a part of Docker called BuildX, which is the latest build environment. And that can build ARM images on x86 64-bit. And so what that means is it's possible to generate multi-platform images from hosted CI/CD pipelines, such as GitHub Actions. But there's a few gotchas. So it uses a thing called QEMU, and that can be slow. And that slowness can then affect commit cycles within CI pipelines. I'd also note that it's pretty reliable for ARMv8, but with Dart, not very much so for ARMv7. So there's a number of well understood and now reasonably well documented problems with compiling ARMv7 binaries inside of emulation within Docker BuildX. And so the upshot of that is if you want to build ARMv7 images, then it's not practical to do that using emulation. That has to be done on native silicon. So what then of building multi-platform images without using BuildX? Well, doing that, it means each architecture has to be built on its own underlying hardware. So we can normally build x64 in the regular CI type of environments. And if we're not using hosted CI, there's still plenty of choice of places to find x86 64-bit hardware out there. Things like AWS Graviton instances can be used for building the ARMv8. And for ARMv7, Raspberry Pis tend to be the reason for doing it, and hence they become a good place to actually do the building as well. And there's hosts like Mythic Beasts have Raspberry Pis as a service. So those can be used in similar kind of way to any kind of infrastructure as a service in the mainstream cloud. So once an image has been created for each of the architectures, that then needs to be stitched together into a multi-platform manifest, which is assembled from the platform-specific images. And that manifest process can be run on any of the architectures. It just needs to have sight of the images for the platform-specific pieces. All right, so where else can you find out a bit more about this stuff? So last year there were a couple of good sessions in Google I/O. One was an Ask Me Anything on Cloud Dart and Full Stack Flutter, and the other was a talk on going full stack with Kotlin or Dart on Google Cloud. And so you see some of the same faces on those. So Tony Pujals was a speaker on both, and he's been very much involved in getting Dart on Docker kicked into good shape and one of the official Docker images. You can also hear from Tony and Kevin Moore on the topic of full stack Dart on one of the GCP podcast episodes. And I've got my personal kind of collection of links about Dart stuff on Pinboard. So take a look at that. For instance, you can see there a link to the micro benchmarking Dart article, which was what led me into the conversation with the Google engineer that I referred to earlier. All right, call to action. Try out the functions framework examples. And one way of doing that is with Quick Labs. So if you've not come across Quick Labs is Google's hosted learning platform where they'll spin up temporary Google Cloud Platform environments that can be used to try stuff out. And there's a Quick Labs dedicated to the Dart functions framework. So that gives you a hosted way of doing that. And you can get a free Quick Labs account by signing up to the Cloud Skills Challenge. So just follow that link. It offers a range of challenges, but all of them come with 30 days of free access to Quick Labs. And it's not just Dart Functions framework that you'll find there. There's some Flutter material as well. You can also try out some of the other courses on things like Functions Framework and Cloud Run, and the more general ways that Google has got to support backend. Okay, we're pretty much at the end. So a quick review. I started off looking at why Dart, and I think for this audience in particular, the answer is you've already taken the time to learn Dart to do Flutter on the front end, so why not use Dart to write the back end and then have a full stack Dart application. I've looked at the trade-offs between just-in-time and ahead-of-time. So just-in-time has a bit of a cold start problem, but can potentially optimize very well in the long run, whereas ahead-of-time is going to run super quickly, but won't be able to optimize over time. And there's also the hit of compiling things to be ahead of time ready, but that'll normally take place in the build pipeline. That build pipeline will often be creating Docker images, which is why I spent some time looking at Dart on Docker. And the functions framework for Dart is a way of really simplifying the code that needs to be written to go into those Docker containers. Dart DevTools provides some amazing tools for profiling and performance management, so they're well worth checking out. And then for backend architecture, there's some trade-offs between x86 and ARM. So ARM is increasingly popular, but building for x86 and ARM at the moment still has some challenges, especially since a lot of the hosted CI/CD pipelines that we use at the moment still are x86 based. Touched upon some other places where you can learn more, and my call to action is try some of this stuff out, and I think the best place to start is with the functions framework examples. So if you'd like to contact me afterwards to talk about any of this stuff, I'm Chris Swan. You can reach me chris@atsign.com by email, and also find me as @cpswan, not just on the app platform, but most other places on the internet. And if you want to try out the app platform, you can find out about it at @atsign.dev, or go to our GitHub organization, @sign Foundation, or see our activity on Twitter, or join our Discord community with that QR code. And now I think we'll be cutting across to some questions. So I look forward to hearing what you'd like to know more about in terms of full stack Dart. Thanks for watching.
What's that? Can you hear the sound? It's like and you know what does it mean? So this sound means, first of all, that I've got my favorite bass, and second thing is that we have a break, and not hard break because of these talks are too awesome for us, but just a regular 15 minutes break, and slightly less. So I encourage you to go. You probably have the access to the platform, because otherwise what are you doing? So there are plenty of opportunities to have fun. So go there, make a photos on a photo booth, do whatever you want. There are plenty of rooms, so you can chat, you can talk, you can chill and relax, you can grab your favorite coffee, and we will return in 15 or so minutes and slap it, yeah. So please stay with us for awesome talks, and we will connect to you in 15 minutes. Unfortunately, it was the last chord of our 15 minutes break, even though it was 10 minutes, but still. So we're ready to proceed to next speaker. And our next speaker is Kagatai Ulusoy, who is going to talk about motion design and how to, transfer from motion design specs to Flutter code. And please welcome.
Hello everyone, welcome from Finland. I'm Çağatay. I'm a software developer at Volt. I was actually hired as an Android developer, but luckily nowadays I'm only doing Flutter development. So today my topic is from motion specs to Flutter code. We will start with rendering pipeline and then understand how the framework works. Then we will talk about the motion specs, which sits between the design and implementation. So before starting, I also would like to thank to the organizers and thank you for bringing the community together. So let's start. Although now I am the only one who is presenting today, this is actually the result of a teamwork. Scott and Maria, they are the ones behind the design. Scott did the UI design, and Maria provided these motion specs to me. And then I implemented the Flutter code. Today, you can access the demo application that I will show soon in my GitHub repository. This is actually a big concept called multi-page scrollable bottom sheet. And I would like to mention 4 steps when presenting this. So as a first step, with designers, we had this talk at Flutter Global Summit, Flutter Global Summit Volume 2. And there, Scott and Masha talked about the design specs and motion specs, UI design and motion specs, and the reasonings behind those. So how the bottom sheet is used, why is it important? And Masha talked about the decisions behind these behaviors of the UI components in the bottom sheet. And I had only 17 minutes to explain the Flutter code implementation. As you can imagine, it was really challenging. So as a second step, I decided to have a talk in a longer time, just to explain this Flutter deep dive, which is necessary to understand this multi-page scrollable bottom sheet implementation. And today, now we are in the third step. I have again 30 minutes to explain how to implement the motion specs that are provided by our motion designer and implement the Flutter code accordingly. And finally, after all this, I will publish all my learnings in my Medium series of articles. And before going to the next slide, I would like to briefly mention that we are hiring at Volt. And if you would like to join our Flutter team, let's be in touch. Okay, let's start. Flutter is fast. Depending on the device capability, Flutter can deliver 60 or 120 frames per second performance. Why is it fast? Because it's simple, and simple is fast. I took this phrase from Adam Bart's YouTube talk, Flutter's rendering pipeline. So it is, I think, a bit more than 1 hour, but it talks about the topic extensively, which is, I still think that it is still not enough to understand everything. But anyway, so Flutter is performant and fast by design thanks to Skia, its own rendering library, and a simple rendering pipeline, which we will talk about today. So what is the first method that we call when starting a Flutter app? It is run app method, right? Inside this method, framework does 2 things. One, root widget is attached to the widget tree. Widget tree is created actually, and then element tree and render object tree created from top to bottom. And then the second thing is that framework initializes the widgets Flutter binding class. It is really important class. It's a glue between the engine layer and the framework layer. This class contains 2 important classes for rendering pipeline. One is the build owner. The other is pipeline owner. Here, you see them. These are the manager classes. So how does the framework produce a frame? This is about rendering pipeline, producing a frame. When it is time to produce a frame, the engine calls draw frame method on widgets binding. which starts the rendering pipeline with the build phase. The build owner class is the manager of the build phase, where all the dirty elements in the widget tree are rebuilt. And after the build phase, we have the pipeline owner class, which manages the laying out, painting, compositing, and generating the drawing instructions. The output of the paint phase is the layer tree, which is consumed for rasterizing and compositing. And the final output is translated to GPU render instructions to draw pixels on screen. So in the end of the rendering pipeline, we see the pixels in the screen. So what is our role as developers in the rendering pipeline? Simple, two things. One is provide a widget tree to the framework so that the build phase starts with that. And then we mark the widgets in the widget tree as dirty. For example, when we press a button, we call set state in a stateful widget, and this widget becomes dirty, and in the next frame, it will be rebuilt. Okay, let's now cover how Flutter optimizes the amount of work by reusing the element and render objects as much as possible. The phases in the rendering pipeline has one direction, from top to down. And in the build phase, elements are examined by parents from top to down. So according to this examination, framework decides whether a child element can be reused, a new child element should be created, or the existing child element should be removed from the element tree. And this examination is done in the update child method, which is, according to Flutter documentation, it is the core of the widget system. Let's now see the possible scenarios with update child. So in the first scenario, we have the existing child element, but in this build phase, there is no corresponding widget for this child element. So element is not needed. And elements marked as deactivated, inactive. And then at the end of the rendering pipeline, at the end of the build phase, the element is still, if it is not reused in anywhere of the tree, it will be demounted, its resources will be cleared. In the second case, we have this element, but now we have the new widget. So in this case, the last widget in that child element is compared with the new widget for that child element. If they have the same reference, then we reuse the element as it is. We don't update element, we don't update the child render object. This is really actually where we want to be from performance point, because this is preventing extra builds. And this is also why we use const widgets. And in this third case, we have element, we have new widget, but this time the references are different. So in this case, there is this can update method. We will check with this method if we can still reuse this element. If the runtime type of the widget, old widget, is same as the runtime time of the current widget, and if the keys are the same, then widget can be reused, element is updated, render object of that widget is updated. In the fourth case, can update returns false. So we don't have any option than creating a new element and removing the existing element. But this is also expensive in terms of performance, because we are creating element, we are creating a new render object. And in the last case, we don't have an element, but we have a new widget to be inflated. So in this case, of course, a new element will be created. So this was how the update chart works. Now we are going to see this rendering pipeline in the big picture. We have this widget tree, and then there is this stateful widget. And in the state object of this widget, there is this widget subtree. And when we press the L, widget L, the on pressed button, let's say it's a button and we press on pressed. So then we press it, the button actually, yes. And then what happens there? We set the state. We call the set state method, which marks the element C as dirty. And in the next, build owner knows that this element is dirty and adds it to the list of dirty elements. When a new frame starts, widget binding first calls draw frame, which build owner starts build scope, which starts the build phase, starting from top. And then all the dirty elements are rebuilt one by one. So update child method is called on E, then it will be called from top to down. But let's see that element E can be updated, and then its render object is updated. If the widget configuration changes so that it has a different width, which requires again performing another layout, then the layout is marked as dirty. For example, if the opacity of the widget configuration, opacity of the widget changes, then it needs a paint. So in the paint phase, it will be painted, and so on. So here, build phase is completed. Now, pipeline owner starts the rest of the stages. First, layout phase, then compositing bits, and then paint phase. After the paint phase, we have a layout tree, and then root render object sends bits to GPU, semantics sent to the OS, operating system, and then build is completed by calling final last tree on build owner. After the just enough technical background, now we can start talking about motion. Masha explained in her talk at Flutter Global Summit Volume 2, she said that motion sits in between design and development. Let's see what motion she's talking about on our demo app. Here, first the scroll motion. We have this bottom sheet page. As we scroll, the top bar gets visible, top bar title gets visible, and then it goes down. Translation Y, transformation. And now we go to another page. We have a hero image this time, and still we have the same. Top bar gets visible as the scroll position changes. And the second one is this pagination. Now I'm showing with, sorry, this was supposed to be the first page. Okay, this is the first page you see. And then let's see. Here the animations are slow to show the transitions clearly. So what I want to show in the end that there is this pagination, the sizes of the pages are different, and now we have this motion, and when we don't have these translations with speed, I can easily show here that this is Apple, you know. Yes. I don't know why it is not working with this. Yes, simulator. Yeah, this is the animation, that motion animation that I'm talking about. Anyway, let's go back. This is what we are going to achieve today. Okay, scrolling in the page spec. So after the motion designer chooses a suitable approach for the motion, she delivers specs to the developers. The specs is basically the changes in the parameters based on the scroll distance here. These parameters are translation, scale, and alpha. How do we calculate the transform value? Well, here, every component has a height, donated here, so notated here. And then we do the calculation. We calculate the progress, and then we find the actual value within the lower limit and upper limit. Okay, now flow widget. The scrolling motion specification relies on the size of the UI components. And among these components, top bar title, and the hero image has fixed size. But the page title has intrinsic height, and we cannot know its size before laying out. In the rendering pipeline, what we do is providing a widget tree, right? We can actually use size transition, opacity, and slide transition widgets to describe these changes on the properties. But the main challenge is that we need to first lay out the page title to do this logic. We can actually go in the rendering layer and play with the render objects to implement custom layout. But this is risky and too complex because if we do things wrong, we will have performance issues. But widget library provides us this flow widget. It will be very helpful transforming these components with using its delegate. Here, we will have two flow widgets, one for hero image and one for top bar title and top bar. So let's now analyze the delegate of the hero image, which is hero image delegate. Okay, in this delegate, we will paint the children in the paint phase. We will calculate the transformation value based on the scroll position. We have the scroll position provided from the scroll controller. So let me remind again, this hero image is inside this main content, which is a scrollable list. And then it has a scroll position, which is a listenable, which is holding this scroll position in pixels. Okay, having this value, pixel value, current scroll position, we can calculate the transformation value, calculate the opacity, calculate the transformation value for scale, and calculate the opacity, and then paint the chart with a transformation matrix, such as matrix diagonal 3 values. Here, we provide the scale factors in X and Y, and then provide the opacity. Then the paint child paints the child, actually, paints the hero image. Now for top bar delegate, it is very similar to the hero image, but here the difference is that we are actually using page title height in these calculations. How do we get the page title height in this top bar? We are providing a global key of the page title and provide it to the delegate as a constructor parameter. And then when painting the child, we will access the current context of the global key and then the height of the global key. Because at that paint phase, the page title is already laid out and we can surely get the height of it. Another thing to consider here is that Masha provided us for the pages which have hero image and which some of them don't have hero image. So the specification changes depending on the available presence of hero image. So we have the start point depending on the hero image existence. Now, should repaint or not repaint? This is the question. First of all, let's understand what this is about. To understand it, let's analyze its render object, render flow, which is the render object of this flow widget. So when we set the delegate, what we do is that we mark the layout as dirty or paint as dirty, paint stage as dirty. So if should repaint returns true, then in the next frame, we need to paint again. We need to call paint children again. Also, if this repaint has an update, then we will again need to paint this flow widget. Here, we provide a scroll position as repaint when constructing the flow delegate. Scroll position, as I mentioned, is a listener. It listens for the current scroll position, and yeah, we will pass it there. So here, when a scroll position value changes, it will be the widget will be marked as dirty. The children will be painted, and then if any of these values are different than the previous widget delegate, then we are again marking it as dirty. This was a bit complicated, but let's continue with this pagination. What is pagination? Pagination is sequence of screens that user goes one by one. So in the specs, you see a timeline and elements properties such as opacity, position, X position, and height, the size, changes according to this timeline. Again, the challenging part here is that keeping the heights of the pages same when we are having these transitions. We will see why this is challenging in the next slides. Okay, now this is the anatomy of a page. A page consists of a primary button, is optional, a back button. If it is the first page, we won't have it. The content is required. It's scrollable content. We have a close button and then top bar, which is visible when we scroll. Again, we will use the same approach as bottom sheet. Sorry, we will use the same approach as bottom navigation bar. Remember, in bottom navigation bar, we define the bottom navigation tabs. The bottom navigation tabs are not widgets, but they are configuration. And then inside the bottom navigation, they are created. So here, similarly, we will define the scrollable bottom sheet page properties and inside the scrollable bottom sheet, we will create the children. For example, entire thing is a stack. We will place and position main content, top bar, close button, back button, and primary button accordingly. We have both ongoing, outgoing widgets and current widgets during the transition. What are these widgets? So we group the widgets to two. The widgets belonging to the outgoing page are inside this class, the components of this page, and then the components of the current widgets is inside these current page widgets. We already have this off-stage main content again. I will talk about what it is about in the next slides. Okay, now let's go to the content of a button page. This is the root widget, value listenable builder. It has a page index listenable, which holds the value of page index. And whenever the page index changes, this triggers a build, and everything inside this is rebuilt. Now, here the important thing. We have this scrollable bottom sheet skeleton, which is a stateful widget. We will override the change dependencies and the update widget methods of this. Because when there is a new build, the widget runtime type and the key, they are the same. So element will be updated. The state will be reused. And then this time, the page index will be different. And that's how the update widget will be called. We will add a page with animation. But when we are first creating the state, we will just add a page without animation. Okay, how we add a page? We have one animation controller for each transition. This animation controller will rule entire animation, this 350 during 350 milliseconds. This is also called staggered animation. We also track this animation controller so that when it is completed, we will set the animator value to, controller value to the upper bound, and the outgoing widgets will be null. We will delete them. We will get rid of them. And then during this adding page, we will set the, before adding a new page, we will set the current page as outgoing page, and then start the animation controller if we have animations enabled. Sorry, yeah. Now the skeleton. This is actually skeleton holds these components in a switcher layout. Each component of the skeleton is this stack, which holds the outgoing, the widget from outgoing child and the widget from current child. For example, let's go into this animated builder for primary button. We have the primary button for the first page, for the outgoing page, and primary button for the new incoming page. And then we will have this transition. So the transition between these two buttons are given us by the motion designer with the motion specs. Depending on the motion specs, we set the begin time, end time, and the curve type, and the begin and end values. So when the widget is built, this animation will start, and then the transition will happen. Opacity, I guess, right? Yes. We are now analyzing the transition of the main content for the outgoing page. Here, the challenging part is, again, implementing the size transition, because we need to calculate a size factor according to the heights of the current and outgoing widgets. But we are in the build phase. We will use size transition widget. We cannot get the height in the build phase. Somehow we need to lay out the page and get the height. The off-state widget helps us here because it lays out its child as if it was in the tree, but it doesn't paint. So it only does the calculations, layout calculations. We will not see that the page is bigger now for some reason. Okay, here is what we will do step by step. First, we will create extra main content widgets for outgoing and the current page. And then we will assign global key to these extra main content widgets. We will wrap these contents with the offstate widget, and finally get the size from the global key. Okay, this is already a bit complicated, but I'm not going to details because we are already running out of time, and I will share my articles. There will be more information here. Please check the source code also. Let's stop here. Thank you for listening.
Hi again, and hopefully you liked the talk because it was outstanding, just awesome talk, as well as all the talks we've seen, and we will have more. And now we have a couple of minutes, and I have a big question for you. Where is my background? So the question, probably you know that these horn helmets actually are fake. Actually, Vikings never use them. And what do you think? And probably you know the answer. Who invented them? I mean, not Vikings, but these horned things. And why we think that Vikings were wearing these things? I don't know. How do you call them? Helmets with horns, probably. And this is a really interesting question. What do you think? Let me know in the chat. Who was the author of this myth that Vikings wear these horned helms? No? Viking boy cartoon? Actually, I don't know. I don't know what you're talking about. You mean this, how do you call them? With the Asterix and Obelix. When the guy drinking a lot and then get mad and crushing everything. Yes, that's true. That's true. We have a winner here. Where is my? No, it's wrong. Wrong button. Well, actually, yes, it's true. Where is the clapping? That's true. It was. And I have things here. So Richard Wagner invented the opera Der Ring des Nibelungen. Sorry for my Deutsch pronunciation. It's not that great. But yeah, first time we've seen the Vikings with horned helmets in Wagner opera. And actually it's segueing us to our next speaker. Our next speaker is Krzysztof Krasinski-Sroka, who would talk about when Flutter goes red. You mean like, you know, when Flutter eats a lot of mushrooms and go into berserk mode and wearing this horned helm. So let's welcome Krzysztof on the stage.
My name is Krzysztof Krasinski-Sroka. I'm a tech lead of Widgets, a Flutter consultancy based in Poland, and a Google developer expert for Flutter. This presentation is called When Flutter Goes Red, and it covers the topic of bugs and errors you might encounter while developing a Flutter application, and how to address these bugs. This presentation cannot cover everything. Dealing with bugs takes easily a third of a software development time, and we have less than 30 minutes now to discuss it. So without any further ado, let's start. This talk is about 1. Where do the errors in our code come from, and 2. Most importantly, what can we do about it? So on the topics, where do the errors come from? There are basically 2 things that cause errors. 1, it's equipment failure. Basically cosmic radiation, end of life of any of the hardware that we use. Could be somebody even tripping on the wire in a data center. But the ones that we are going to cover are caused by incorrect expectations about what the code does. These are not necessarily expectations with respect to your code. These can be expectations of people writing a dependency that your application uses, such as the SDK or a library. Code is actually never wrong per se. It does exactly what it was written to do. You cannot bargain with it to have it work without bugs. It cannot be reasoned with, and it will absolutely not stop doing what it was written to do. There are several types of failures common in Flutter. The most common thing is a precondition failure, when the application is in a state where it cannot really execute what it's tasked to. This includes things like invalid function parameters or variable values. From very simple examples like division by 0, where 0 is an invalid parameter, or index out of range in an array lookup, as well as more complicated and Flutter specific things. For example, calling setState when a stateful widget is unmounted, or having multiple identical widgets with the same global key. UI failures are the other type of failures. It's basically when the UI doesn't render as we expect it to. This might be wrong size, wrong alignment, or positioning, or clipping, things that really don't look good, or at least don't look as we want them to. The third common failure is performance failure, when the application works correctly and looks correctly, but it does so much slower than expected or is taking too much resources. Flutter isn't really a problem of itself, but naturally might affect the rest of the system and slow down the whole application. There are more things, there are more failures like syntax errors, but I won't focus on them now. Let's focus on the first three types of problems. What to do when we encounter failures like these? Have you ever seen a Stack Overflow question where the OP asks for help with an error and includes at most one line of debug output from the application? It's really hard to help anybody if they don't provide the most useful information, the output logs. Output logs in Flutter are by far the most useful things to start with. Flutter, unlike some other tools such as a C++ compiler, produces very readable output when it encounters an error. Let's take a look at some common cases and try to analyze them by looking at the output logs. Let's take a look at this application. This is an application I wrote some time ago, and its main orientation was supposed to be horizontal. However, I didn't really check what happens when we go into portrait mode. So let's see. Whoopsie. We can see that on the screen it appears that there's a mark saying, well, right overflow by 244 pixels. You need to trust me, this is very small. And that actually my name on the right hand side doesn't really fit into the widget space. So how can we go and see what's going on? Well, let's take a look at the debug console. I'm using VS Code as running this application from VS Code, so it appears in an integrated debug console here. But if you use other IDEs or you run the application from a console itself, you should see a very similar output. I'll hide the application window for now, and let's focus on what's here in a console. We see the following assertion was thrown during layout: render flex overflowed by 244 pixels on the right. Well, that's nothing new, but we can see already some things. The Flutter message actually prints out which widget was the one responsible for this. Let's take a look. Okay, so this is a widget, the render flex widget, that we actually seen overflowing. And yeah, it contains a text. It contains, well, two texts that are not really visible in the screen. What can we do about this? Let's see in the debug console. Well, we can inspect this widget in Flutter DevTools. We will do that later. The overflowing render flex has the orientation of axis horizontal. Well, that is a row. It has a horizontal orientation. The edge of the render flex has been marked in the rendering with the yellow and black striped pattern. Well, yes, we can also see that. Thanks, Flutter. Consider applying a flex factor, using an expanded widget to force the children of a render flex to fit within the available space instead of being sized to a natural size. So here we actually have even a suggestion. What can we use? Well, we should use the expanded widget somehow. And I won't go into details of how this works, but let me try applying expanded to the text widgets. Okay, no, this is actually going to be expanded column. Wrap with widget, expanded. Let's see what happens now. Well, the application looks okay, although I still have some problem here, I think. No, okay, no, I don't. Reloaded one of the 574 libraries, and that's it. That's how the application looks now. And yeah, the suggestion that the Flutter SDK said was actually correct. Let's apply some expanded. I won't go into details as I said, but if you don't know what flex is and you want to learn, then you can take a look at the flutter.dev documentation on box constraints and how to apply them. Let's go to the next error. Take a look at another example. Now I have a screen that I can add new icons to. Let's take a look. I added the first icon, it's an eject icon. These icons are random. Let's add another one. Well, this is a back icon or share icon. I'm not really sure. Let's add another one. Oh no, something failed. Well, this message, as you can see, isn't really useful to us. Let's take a look at what's happening in the console. When we open the output, we might be a little bit overwhelmed by the amount of messages that Flutter outputs here. This is unfortunate in some cases, but Flutter tries to be more verbose than it really needs to be, especially when it encounters a particular error for the first time. Well, we can take a look at these messages, but the real clue to what's going on is on the very top. You should always take a look at the first message that the Flutter SDK puts to the debug console. Well, what says here is that animation controller.animate2 called after animation controller dispose. However, this link goes to the animation controller, which is in Flutter SDK. Is it possible that the animation controller is so dumb? Well, let's take a look more into what the message says. Well, failed assertion there. The relevant error-causing widget was list view. When you go into list view, it's really not that much of animation controller being done here. However, we pass this animation controller further down, which isn't a good practice, but it's here just for demonstration purposes. We might go into what's going on later. So actually the third element here is another widget of ours. Let's take a look at this one. Yeah, this animate2 was called after widget animation controller was disposed. Although the real problem, of course, is multiple disposes. We need to be aware that the problems are not exactly caused by the lines that the Flutter SDK points us to. These are just the reasons why the Flutter doesn't want to proceed or produces an error. We might do a bug in some other place, and we need to be aware of what we do and really read what's going on. The hint here was animation controller.dispose, and here we might take a look and see, well, when animation controller gets disposed. could not only read the debug console, but write information to it. Well, fortunately, Flutter SDK allows us to do that. In cases where the default debug messages produced by the SDK don't really provide too much detail, we can use utilities such as debug print to write some information on what's going on. Let's here write some useful information of what's going on here. Well, we run dispose, but which widget does dispose really? Well, I know that we actually have this nice property called key. See, an icon card gets past a key. And maybe we can use that key to identify what's going on. So, widget.key interpolating in this string. Let's now save and try to add a few new icons. Let's see also what's going on in the debug console. Well, nothing disposed so far. Disposed with the key 0/1. Oh no, and that's the error. Well, let's filter and see what messages do we have. You see that we disposed of the widget 0/1 and 1/2. How do these keys get constructed then? Let's go up and see. Okay, we run dispose for the widget 0/1, so that is, well, I wouldn't decipher this for you, but that's the first widget in the list out of 1, so that was a widget when it was only one icon on the screen, and the second dispose was a second widget when there are 2. It's a little bit odd. Actually, when you take a look at this key is oddly constructed as well. We keep the widgets on a screen, however we shouldn't really dispose until we really leave the screen. What's wrong here is that the list view actually keeps track of its children, and if the key doesn't match, then it disposes of that widget. And when it runs dispose multiple times, well, we have that error. Let's just fix the value key, removing that mutable part. Well, now every icon should have a value key that's just entry.key, which is its index. Let's see if we can repeat this error. Oh no. Well, let's restart. Restart complete. Yes. Let's add some new icons. Great. Great. Marvelous. Nothing crashed. Oh, wow. This is how it looks. However, we could see that we can use debug print for small diagnostic messages. Nothing gets disposed right now, as we can see. Well, we remove this filter. We'll see some messages. Well, there's only one. We started application 355. But there are many more things that we can print out of the console. Of course, we can use debug print, but there are more specialized debug print utilities. Debug print stack, for example, can be used, and let me remove iPhone simulator. Debug print stack can be used to print out a stack trace in a nice form, similarly to what we've seen in the output, the default output by Flutter SDK. This is really useful in catch clauses, where we can inspect the stack trace of an error and see where did actually the cause was. Other things include, that's a lot of them. Debug print, for example, begin frame banner, end frame banner, which can be used to investigate what's going on between the frames in Flutter. And debug print layouts, debug print mark needs layout stacks, lots of very detailed things we can use with DRSprint. Most of the time you won't use them. However, it's nice to know that Flutter actually gives you some tools for you to just crudely inspect what's going on. Let's now go to the next kind of problem. Now go back to the first problem that I've shown you in my app, the overflowing widget here. There's another way than just inspecting debug logs and figuring out what to do. For some time already, Flutter has what's called the Flutter Inspector page integrated into the DevTools, or called previously Dart DevTools, which is a suite of tools helping you develop Flutter applications. Let's take a look if the widget inspector or Flutter inspector can help us with this. So when I click on this icon in VS Code, I get this kind of view, which is really nifty. On the left hand side, you can see the tree, the widget tree of my application, including the root, my app, material app, down to the images and text. The right hand side is yet not visible, but it will shortly change. So this is actually the view of my application. When I hover over some widgets, we can see some printed values of it, or inspected values of it, like what's child. But it's not important for now. We want to fix the original layout problem. And with Flutter DevTools, it's really easy. Let's go to the row which was the source of our problems. Well, you can see that actually the Flutter DevTools opened up the editor with this row being highlighted. This is really good, because if we want to actually see which row is that, we don't have them described here and have multiple similar widgets, we can get navigated exactly to the line that we should care about. However, the Layout Explorer also shows us something interesting. You can see that this information wasn't really available or clearly available to you in a console, that the width of this row widget is 358 pixels, well, with the constraints from 0 to 358, but the children take 602. So let's try to find out how we can fix these children without touching code at all. We can actually inspect the children of a row as if it was a row, but in a kind of a scrollable view. And then we can expose a column that is a source of our problems. As you can see, it also has this striped bar, and it also has a message. It's maybe a little bit unclear if I show it a bit more. Well, that its width is 494, and it's more even than the total width of a row. However, we can manipulate some parameters here. For example, we can add flex, and adding flex 1 is similar to what we would do in case if we wanted to add expanded widget. This actually doesn't change the code, but lets you manipulate some parameters to see how the layout changes. You can also manipulate the position. It's actually along the main axis. It's not going to change anything here, but if we do a cross axis, you can see a slight change in the positioning of the avatar. Let's go back to center. So that's one of the functions of the Flutter Inspector. There are a couple of more interesting features. For example, we can fine-tune the animations to run them by default 5 times slower to see what's going on when the animations go on. Sometimes the animations that we use in our production apps take only 100, 200 milliseconds. So this helps us to see better if something's going wrong there. We can also add overlay guidelines
which will show this kind of grid, including the paddings on a widget and the direction of some widgets. But this might be quite useful in discovering that, well, we actually have a position there because we have a padding and it might belong to some widget. One nice thing is also the select widget mode, which allows us to select any widget and be navigated directly from the UI to the widget in a widget inspector that's responsible for that part of the UI. Let's go and see another function. These are text baselines. Let me remove this first. Text baselines also fine when we actually want to inspect why the text doesn't align with each another. And there's one nice thing, which is a repaint boundary, which we can see now when we try to move pages forward and back. It's a boundary that changes the size, changes the color whenever a repaint in any widget happens. So actually we can only see it really clearly here around the whole material app, because it's a material app that repaints itself. You can see also on some other screens that repaint themselves, and they are tagged with different colors to see different phases of the animations. We can also highlight images that are using too much memory, but in our case, well, this is just me. I don't think I use too much memory though. Let's go to the next tool. So what I'd like to show you is a debugger. Many of you might know debuggers, since it's a concept that predates Flutter and Dart by many years and is available in many other languages. However, I think that many Flutter developers don't really use it, outright disabling it, or not using it to its full potential. And it's a very nice tool because it allows us to inspect a running application by stopping its execution and taking a look at what's really going on. So in VS Code we have this nice debugger view, and in other IDEs we have something similar. By default, the debugger will stop whenever we have an exception when it didn't catch, or there was no catch block associated with it. But we also can set our own breakpoints, and the execution of a program will stop when the program reaches the instruction on a line that the breakpoint is associated with. Let's go and see. Here we have associated a breakpoint on line 69 on the icon button that leads to the next page. So what happens when I press right? Well, the first thing we can see is a call stack. Basically, it's a sequence of calls that led to the execution of this onPressed. So you can see handle tabs, invoking some callbacks, and on the top is our very line. On the top we have variables. These include everything that's in a current scope, is accessible in a current scope as a variable, or this level variable, and unfortunately here we can only see this, that is my home page. We can also add some expressions to watch them during the executions independently of the local variables. These can be, for example, date, time, now. Or something that is evaluated only in the current scope. So let's say controller dot page. Now, on the right hand side in the toolbar, we can see several things. These buttons allow us to go navigate through the call stack, or through the instructions that we are actually going through, by either stepping into the deeper level of the call. So let's see what happens in the next page. It's actually jumped a little bit because it decided, well, it's not really important to go through this next page and page steps. They might have been optimized out. the locals have updated, and you can see that now that the controller page is not really accessible, we have error. However, datetime now works as expected. We can also press any on any position in the call stack to navigate to that place with naturally locals and watch expressions reevaluated when we do that. We can go up, down. Now, this button leads to a higher level, which actually also skips some stages and proceeds with just finishing on this unpressed. We could use also this button, which would step over the expression on the lower level, but continue on the next expression on the same level, and continue, which would lead us to continue the execution until the next breakpoint. As we can see here, one nice feature of breakpoints is also that we can edit them to evaluate some conditional expression when these breakpoints should be active. And let's say the expression is controller.page equals 0. So that this breakpoint is not going to stop us anymore when we press it many more times. However, when we go back to the first page, it's still going to work. That's it when it comes to debuggers. I think you should explore what they can do for you. And now, let's go to the final part.
I hope that you enjoyed my presentation. As I said in the beginning, this was just a brief intro into some of the most common causes of problems and solutions to them. For more information, I recommend reviewing documentation on flutter.dev or asking questions in the community forums, be it on Stack Overflow or elsewhere. Thank you and have a nice day.
Thank you very much, Krzysztof. And we're slightly but unavoidably moving to our next part. And our next part gonna be a little bit strange or not. We'll see. So if you're familiar with the matryoshka thing or babushka, or I don't know how it's called in English. So it's like when one doll inside our other doll, so we're gonna have the same. So inside your applications, inside this platform, you're gonna see me, but then we will restream guys from the Flutter team because they're gonna announce really awesome thing. This thing is related and segueing us to our next activity, and our next activity gonna be lightning talks about desktop, because this is a topic for Flutter team, desktop. And by the way, while we're waiting for the beginning, we can have one nice thing, and I would like to know personally. So where are you from, guys? So if you're able, please post in chat emojis with your country, and we will see how many people from one country or other country. And yeah, it's really interesting. Netherlands, Brazil, wow, it's a long way. Germany, and hopefully I know all the countries, all the flags for the countries because it's gonna be embarrassing. Yeah, wow, Portugal, Scotland, wow. And Nigeria. And looks like I opened something because we have I don't have time to read everything. Nigeria, Brazil, probably Portugal, Ukraine, Portugal again, Sweden, Ukraine. Wow, FGV, I don't know, you have 5 flags, so looks like it was a while. Russia, Ethiopia, Mexico. That's long way. And guys from other part of the world, probably right now you have 6 hours different, 7 hours difference. That's a lot. Iran, real Norway, real Vikings. And yeah, talking about real Vikings, we're waiting Flutter update on Windows, and It's a bit lonely to sit here, and I hope that someone will join me in the future, because after next activity, we're gonna have MEA with Flutter team. So stay with us. And yeah, the conference time for Brazil was great. Nice. And yeah, for right now in Central European time, it's 7, and it's totally okay. Iran. Wow, the conference time. Cameroon. Yeah, it's nice that you said it, because actually I didn't know about the flag of Cameroon. Sorry. Yeah. Canada. James. Hi, James. Canada is great. A little bit cold, but yeah, it's great. Egypt. Hi, Ahmed. Really nice to see that not only people from one part of the country. It looks like Flutter is kind of, yeah. I think we have 2 minutes, and I'm passing the microphone to the Flutter team, right? Or we will wait for 2 minutes. Yeah, we have additional 2 minutes. Ben is from the Peaches and USA. Nice one. Nice. Iceland. Wow, this is pretty far away. Not far away from Norway, but far away from others. Dominican Republic. Wow, nice. Florida. I didn't know that Florida is a country, but yeah, nice one. Brazil. Thank you, guys. This is really awesome, because knowing that Flutter gathering people from all around the world is really inspiring, because otherwise, I don't know, hopefully that programming languages, Flutter and Dart, will unite us all, and we will talk not in English, not in, I don't know, Spanish, or we would talk Dart language. And okay, I think we are ready to transfer the microphone and the time to Flutter team, because it's only 30 seconds left. And if you're standing, you should sit, because otherwise you will fall knowing this awesome news about Windows and Flutter support. Okay, I think we're ready. I'm ready to shut up and pass the microphone to the Flutter team. 16, 15, 13, 12, 10, 9.
Hello, and welcome to this Flutter update. I'm Chris, and I'm here with my friend Zoe. Hey, Zoe.
Hi, Chris, and hello, all.
Zoe and I are product managers on the Flutter team, and today we've got an update on building Windows apps with Flutter that we're excited to share with you. We're also going to be diving into the architecture of Flutter to support Windows, and then doing some coding. And finally, we'll show off what partners are doing with Windows. So lots of Windows today. As you may already know, Flutter is an open source framework sponsored by Google for building beautiful, compiled, multi-platform apps from a single source code base. With Flutter, we want to give you the tools you need to build a great experience that's portable across multiple platforms. Flutter allows you to create beautiful experiences where your brand and design identity come to the forefront. Flutter is fast, compiling your source code to machine instructions. It's also productive, thanks to our support for hot reload, allowing you to make changes while your app is running and see the results immediately. And finally, Flutter is open, with thousands of contributors adding to the core framework and extending it with a huge ecosystem of packages. And there are already millions of developers using Flutter. In fact, it's the most popular multi-platform framework according to recent surveys from Statista, JetBrains, SlashData, and Stack Overflow. Collectively, these developers have published nearly 500,000 mobile apps using Flutter. That includes big apps from brands like BMW and WeChat and Google itself. It also includes next-gen apps from startups who want to reach their iOS and Android users quickly and easily from a single source code base. Now, 2 years ago at our Flutter Interact event, we shared our vision to expand Flutter from mobile apps to include the desktop. And you took our vision and ran with it. Let's take a look. Now, of course, if we're going to focus on the desktop, we have to start with Windows, which runs on more than 1 billion desktop computers. And so today marks a significant milestone for our desktop vision with the stable release of our Windows support. This enables Windows developers to benefit from the same productivity and power that mobile developers have already been enjoying with Flutter. And there's a lot that carries across to the desktop from our experience on iOS and Android. From the portable hardware-accelerated graphics engine to the Flutter rendering system, core primitives like animation, theming, text input, and internationalization, the hundreds of widgets that Flutter includes, as well as thousands of packages from the community ecosystem. But if that's all we did to make Flutter apps run on the desktop, that still wouldn't be enough. Even though it's the same source code, desktop apps aren't just mobile apps running on a bigger screen. They're designed to run on a completely different set of hardware, a monitor, a keyboard, a mouse. All of that provides a completely different user experience. Beyond that, every operating system has its own conventions for critical things like accessibility, input method editors, and visual styling. And finally, great desktop apps integrate with the underlying operating system, taking advantage of the tens of thousands of APIs for everything from file system pickers to device hardware to local data stores. If you're building for Windows, then we've now got an offering for you that takes all of these considerations to heart. And to tell you more about our Windows-specific support, I'm going to hand it over to Zoe.
Thanks, Chris. Let's take a look at how Flutter works on Windows. The Windows implementation of Flutter builds on the work that we've been doing for the last 4 years on mobile and web. Just like on other platforms, on Windows, your app runs using a native platform embedder. The embedder is the shell that hosts the Flutter content and interfaces with the rest of the operating system, including user input, rendering, and message handling. In addition, Flutter's architecture allows you to call any of the thousands of Windows APIs offered through Win32, COM, and the Windows Runtime, or WinRT. On top of the embedder is the engine, a small runtime that provides your app with the Windows implementation of the Skia library, which does the GPU-accelerated drawing. The engine also includes the Dart runtime and the text rendering libraries. This is the same engine that runs at top speed on much smaller mobile devices, so it has been tightly optimized for years.
Hi. Yeah, we'll have some.
The framework sits on top of the engine and provides the core animation, layout, and rendering services of Flutter, as well as the widgets against which you write your code. The framework also provides the widgets and the design system that gives your app its look and feel. You can choose from several widget libraries, The material design system can be fully customized to give your app a consistent UI across multiple platforms. Or if you'd like to provide a native Windows look and feel, you have all the widgets you need to build a beautiful app that uses the Fluent design system. One option for doing that is the excellent Fluent UI package provided by the community, as well as the Fluent UI systems icon package provided by Microsoft themselves. However you want your Flutter app to look on Windows, you have the power you need. The real question is, how hard is it to take advantage of that power when targeting Windows with Flutter? And there's only one way to answer that question. Chris, can you show us what it's like to build a Flutter app on Windows?
You bet, Zoe. I'm happy to. Let's start by creating a Flutter project. Okay, and let's see what we have. So each new Flutter project is going to have a sub-project for each one of the supported stable platforms that comes with Flutter. And as of today, we add Windows. Let's open it up in Visual Studio Code and see what we get. We have a new Windows app, but a pretty famous one. This is the Flutter Counter app, and it works like a Windows app should. We're also running under the debugger right now, which provides all of the debugger services and breakpoints and evaluation, and it also provides the Flutter Dev Tools. So let's load those up. If you're unfamiliar, the Flutter Dev Tools are the complete suite of debugging and diagnostic tools that you use when you're building real-world applications with Flutter. All these tools work great for your Windows app development. So I'm loading up an application called Photo Search. The idea of Photo Search is it's meant as a sample app to take advantage of more desktop kinds of features, menuing system and larger form factor and standard dialogues. So what we have here is another Windows app, but you notice that it is styled using the material design language. And that's pretty easy to see with the app bar and the floating action button here. However, today, what we're going to do is we're going to see how much we can make this Flutter app look and feel like Windows. We're going to take advantage of a library from the community that provides an implementation of Microsoft's Fluent UI. And so we're using this community-provided library, and we're going to change out the UI of our app. What we're going to actually do is remove the reference to material and instead use Fluent. And so when we change to Fluent, we don't want to use material app. We want to use a Fluent app. We're going to take out the reference to the material theme, fix up the const here a little bit. Fluent doesn't have a scaffold. It has a container. It doesn't have a background color. Instead, it has color. We'll take out the app bar. We'll take out the floating action button. We'll actually take out the reference to the action button, and we'll update the colors here a little. Okay, now let's go back. Notice that we're running our application while we're coding it, and that allows me to go quickly back and forth between the changes I make in my editor and what actually shows up on the screen. So now let's do a search. This dialog isn't right for Windows. For example, the buttons are in the wrong order. And when I press the Enter key, I expect one of them to be a default action, but I can't tell by looking at the buttons which one I'm going to get. So let's fix that. Let's load up the dialog implementation. And again, we're going to replace material with Fluent. And instead of an alert dialog, we've got a content dialog. And instead of a text field, we've got a text box. We'll get rid of this material decoration. Our buttons are in the wrong order, so let's fix that first. And we have some casing problems, so let's fix that. We want an actual button with an outline, so let's change that. Here we want a filled button, just to make it clear which is the default button. And notice right away, without recompiling or reloading my app, all my changes are right there. That is the power of hot reload in Flutter. There we go. I have a nice tree view that looks good with my blue background. I press on the photos and download them. Turns out there are a ton of packages and plugins and tools on PubDev that allow you to make your Flutter app look and feel like a Windows app. But if I wanted to, I could have a custom title bar, I could have a taskbar icon, I could even have multiple top-level windows if I wanted. But eventually, when I was done, the next thing I would want to do is ship my app to my users. And before I can ship my app, I have to have a release version. We want the smallest, lightest, fastest thing that we can give to our users. And that's what a release build is for. So let's see what we get. We'll see right away that we have a native executable, just like we would expect, except it seems kind of small. This executable is just all of your Dart code compiled into x64 assembly language instructions. It doesn't need to be very big. A lot of what you'll get in Flutter is coming from the runtime. But even so, this is a small app. And so when we double click it, and it started really fast, we call this zero latency startup. And it is one of the benefits you get with Flutter. Its tiny engine has been optimized and minimized to run on mobile. So when you bring it over to the desktop, you get a much smaller, faster experience than you might otherwise get. And at this point, if you wanted, we could zip up the contents of this folder along with some support DLLs that we document on flutter.dev. We have an enthusiastic Windows developer community for Flutter, and they have already provided a wonderful tool called the MSIX tool. Now, MSIX is a file format that Windows supports out of the box for setup, integrating into the start menu, uninstalling. So let's build an MSIX with this tool. Now, the way we do that is we take our pub spec and we add a little bit of extra configuration information. And once we have this information in place, we can run this tool to create an MSIX. And what it's doing is it's taking the contents of our release folder that we already showed you and bundling it up into an MSIX file. And here it is. It's about 10 megabytes. This is the thing that you can put up on your website and send links to, and your users can download and execute. And then this is the experience they'll get. And when I press the install button, it's going to take the files and copy them to the right folder on Windows. It will execute your app by default. Notice again how fast it went. Notice it's in the start menu. Or if we look in the apps and features dialog, notice we do a search and we see our app is there. And the other good news is this exact same file format is all you need to get into the Windows Store, which gives you the additional functionality of discoverability and updates as you change your app over time. And there you have it. We went from nothing to a generic desktop app, and then from a generic desktop app to a Windows app suitable for distribution on the Windows Store. And we did all of that in just minutes. Along the way, we took advantage of some of Windows plugins, but there are so many more. In fact, there are already more than 200 Windows-specific plugins, along with more than 10,000 Windows-compatible packages that you can drop into your Windows apps today. To call out just a few, there's the file selector, which enables the file and folder standard dialogues on Windows. There's the Win32 package, which provides FFI bindings for literally thousands of Win32, COM, and WinRT APIs to make it simple to take advantage of Windows services directly from your Dart code. And then there's Realm, a super fast local data store that has a Flutter SDK in preview today. And the best part, it supports Windows as well as iOS, Android, and macOS. So you can use it in your cross-platform apps. And then there's the camera plugin, which you can see in action here. There's Tom from CodeMate demonstrating their Dashcam app for Windows. And it's not just packages and plugins, but tooling support as well. As you've already seen, Flutter DevTools provides a host of advanced debugging tools for your Windows apps. And our tooling partners are adding Windows support as well. As just one example, Flutterflow, the low-code Flutter app design tool, supports desktop-sized form factors and Windows specifically. And another Flutter tool that's been updated for Windows is the CodeMagic CI/CD tool from Nevercode. It supports testing and building your Windows apps in the cloud, as well as deploying your app all the way to the Windows Store. You can take advantage of their Windows support today. Okay, Zoe, I think that covers the basics of targeting Windows with Flutter. Back to you.
That was great. Thank you, Chris. As Chris showed, when you build your Flutter app on Windows, you expect to have complete control over every pixel, just like you do on any other platform that Flutter supports. You want your choice of animations, control over the theming, smooth scrolling, access to a wide array of font choices, and the list goes on. And when it comes to taking maximum advantage of Flutter to build rich, interactive experiences, there's no one better than our longtime partner, Rive. And today, we have Guido from Rive to show us how they're building on Windows.
Hi, I'm Guido, the co-founder of Rive. Rive allows creators to add rich, animated, interactive content to their products, while providing open source runtimes to deploy to a wide variety of platforms. With Rive, designers and developers collaborate to make apps, websites, and games stand out with animated user interfaces and hero moments that inform, guide, and engage. Data visualizations that shape narratives around complex information. Animated icons, stickers, and emojis that help convey human emotions across digital channels. Rich characters like assistants, mascots, cartoons, heroes, and villains. 1 year ago, we released Rive for the Web, giving everyone the power to create interactive animations in their browsers. But our pro-level designers and developers need the highest quality app and the fastest possible performance. So today, we're excited to announce Rive for Windows Desktop. We use Flutter to build our desktop app for Windows, avoiding the legacy dependencies that come with browser-based platforms. Flutter widgets provide a great starting point for our UI layout management and interactions, while also giving us the opportunity to easily customize the application experience for our specific needs. Flutter provides a truly native experience, with Dart compiled to machine code for each desktop platform, leading to efficient memory usage and low overhead for all. All CPU operations. This puts the best possible performance in the hands of Rive professionals on Windows desktop and tablet computers. Leveraging Flutter and CodeMagic, we can deploy straight to the Microsoft Store, giving our users a standardized installation experience, easy updates, and confidence in the app's security. Check out this complex file we've got running in Rive for Windows. We have multiple artboards that all have their own animations. We then use nested artboards to create a rich scene. It's running all the separate animations at the same time, but we have more animations in this scene, which we can run in conjunction with each other using our state machine. As this state machine is running, you can see that we can interact with the inputs and make all the various animations and nested artboards react in real time. While it's running, we can quickly pan around the stage, zoom in and out, and even resize the entire window without skipping a beat. This is the power of Rive for Windows Desktop built with Flutter. Look for Rive in the Microsoft Store soon. We're so excited to see what you create with it.
Rive has done an amazing job of not just providing a Windows app that looks great and utilizing what makes the desktop unique. They've also done a great job integrating their app into the services of Windows itself. You may have noticed their custom title bar to provide a modern look, as well as taking advantage of those otherwise neglected pixels. Moreover, they integrate with the file systems, the standard dialogues, and install like any other Windows app. And you will want to look for the Rive app in the Windows Store. In addition, the Windows embedder for Flutter automatically integrates with services like global text input, so your Windows apps are global ready. Here you see the Windows input method editor in action using the standard Flutter text field. Also, Flutter is committed to supporting you in making your apps more usable, inclusive, and accessible. Now let's take a listen to what the Windows narrator can do with standard Flutter semantic info to provide a more accessible experience for your users who are visually impaired. We've blurred the image a little just to give you a sense of how important this feature is to users who need it.
Desktop photo search window, Flutter view, pane. Search for photos using the Fab button. Search for a photo, button. Alert, search query, edit. Cap Y, A, S, A, K, A. Cancel, button. Search, button. Yasaka, photo by Cosminsurban, button. The Hokanji Temple or the Yasaka Pagoda in Kyoto during sunset, image. Photo by Cosminsurban on Unsplash, button. Download, button.
One other differentiator for a native desktop app is performance. because Flutter apps on Windows are compiled to native x64 assembly instructions when you create your release builds. Those apps are going to have a small distribution size, launch with zero latency, run at native speeds, and with a memory overhead measured in megabytes, not gigabytes. This lets you tackle large data sets while still taking advantage of the rich animations and smooth scrolling you expect from Flutter. To show off the raw performance of Flutter on Windows, let's hear from Hannah what Rose has done in their next-gen spreadsheet.
Hello there, I'm Hannah, and today I'm excited to share how we are using Flutter to create the future of spreadsheets here at Rose. So, what's Rose? Rose is a spreadsheet with superpowers. It combines the power of spreadsheets with built-in integrations and a gorgeous sharing experience. This means you can send emails, send Slack messages, get data from LinkedIn, monitor crypto prices, all of that without code. And when you're ready, you can share this spreadsheet as a beautiful web app that's fully responsive and make it interactive with things like buttons, input fields, and a lot more. Rose is already live as a web app that has been in the making for some years now. But in 2021, we decided to create our own desktop app. We started this project with one principle in mind: performance. Creating a smooth experience that felt natural for the millions of people that use spreadsheets every day, and keeping a pixel-precise scrolling while handling thousands of cells with the most frames per second as possible was the thing that would drive our technical choices for this product. A spreadsheet can have hundreds of columns and thousands of rows, resulting in possibly millions of cells. Following that, we obviously have scrolling in both directions. This alone is a huge performance compromise, but the challenge doesn't stop there, as each cell can contain all different types of content. For example, numbers, formulas, charts, and even entire JSON objects. Another important factor for us is directly tied to our mission: create tools that make computation accessible to everyone. The value of deploying to multiple platforms was absolutely fundamental for us. There were three possible ways of creating the app: an HTML-based toolkit, fully native, and Flutter. And after considering these two factors, multi-platform and great performance, Flutter was not only a great choice, but the only one to fit the bill. And time proved how great that choice was. We worked on a sliver-based grid engine that can scroll outstandingly smooth. In normal scenarios, we can easily go to 60 frames per second. Even in 4K screens, where we have more than 3,000 cells in each scroll frame, we go for a comfortable and understandable 30 frames per second. Animated selections takes the best of the Flutter intrinsic animations to deliver a great user experience, while the formula composition takes the Flutter text editing system to an extreme, using text spans for highlights. And each cell takes advantage of the canvas to paint all possible types of content. You can try the Flutter version of Rose right now, as the beta for Windows and macOS are available for download at the Rose website. And we plan to ship an iPad version soon. Thanks to the Flutter team for the awesome job and for having me. Bye!
After seeing the amazing work that Rose and Rive have done to support Windows, and then the ease with which Chris was able to target Windows, we hope that you see how we've taken the power of Flutter and integrated closely with the world's most popular desktop operating system, giving you the best of both for your apps. And we're not done yet. In the coming months, you will hear more from us on delivering stable support for macOS and Linux, making the full set of desktop, web, and mobile platforms available for your production Flutter apps. Okay, so how do you get started with Flutter on Windows? All you need to do is install Flutter 2.10, which is released today at flutter.dev. If you're an existing Flutter developer, you'll be happy to know that Flutter 2.10 includes a number of new features, as well as performance and quality improvements. Check out our blog post, which covers those changes in more detail. We can't wait to see what you're going to build with Flutter 2.10 on Windows. Thanks for watching, and bye now.
I don't know about you, but my favorite emoji right now is like, this person with the blowing head, like, wow. This was amazing because like Windows and other stuff and rows and wow. By the way, we're gonna have AMA live session with guys from Flutter team. So if you have any questions about this one, like huge release or any other question, please post them in chat or hold them until the AMA session. But you can post them right now and we will check them and we will ask them. So definitely you should ask everything about this Windows release and others. And meanwhile, we're segueing to our next block of speakers. Outstanding lightning talks from Minas and Kevin, and we would start from Minas. And Minas would talk about using Flutter to build a native-looking desktop app for MacOs and Windows.
Hi everyone, my name is Minas Giannekas, and today I will be talking about my experience with building a native-looking desktop app with Flutter for macOS and Windows. So a few things about me first. I'm currently a self-employed app developer. My main background is web development, but I discovered Flutter a couple of years ago, and I have been using it constantly since for mobile and desktop app development. So for a quick overview, I am going to use as an example here a small desktop app I developed with Flutter called Shortcut Keeper. It's now available on both macOS and Windows, and it features a native-looking user interface for its platform. So let me bring it up here for a minute. It's a simple app in terms of functionality. So when you come across a shortcut that you want to remember and save, you open the app, you record the shortcut, for example Command T, what it does, like create tab, the app it belongs to, and you save it. It helps with keeping and all your favorite keyboard shortcuts or the ones that you want to learn in one place. So my main point here will be that it is indeed possible to build an adaptive app with also native looking user interface for its desktop platform, focusing here on macOS and Windows. So an adaptive app, as its name says, is simply an app that adapts to the underlying platform, in our case the desktop operating system. It's mostly about respecting its platform's idioms and norms, so how things are done or displayed usually in its operating system. It helps a lot with improving the user experience, since users expect apps that they use to behave similarly to other apps that they use daily on their system. So the classic example of this is how on macOS or Linux the confirm button is traditionally placed on the right side, while it's the exact opposite for the Windows. Another one, of course, is keyboard shortcuts. So when selecting the appropriate shortcuts for your app, you need to keep in mind that command is the main modifier for the macOS, while control is the main one for Windows or Linux. There are also differences in how keyboard shortcuts are shown, are displayed, and which ones are traditionally used for certain actions. For example, the command comma shortcut for macOS, which on every app it brings up the app's preferences or settings. You wouldn't want to bind this to another action, as it would be pretty confusing for users of your app. All these may seem to be small things, but they eventually make a difference on how the user perceives and navigates throughout your app. You can of course configure this stuff and build an adaptive app with Flutter's default material UI or your own custom design, but you can also take it one step further and try to go for a native looking user interface. So what's a native looking UI? It's simply a design for your app that not only respects the adaptive guidelines we set previously, but also tries to get closer to a native look and feel for each platform. For example, you can see here how similar our app looks on macOS with other Apple designed apps on macOS, the reminders and notes apps. You can see here we follow the same layout concept with the sidebar on the left and the content on the right, we have a similar design for the search field here. And in the top section, we have the Cupertino icons that look pretty similar to the other apps. The same can be said for Windows, so we can follow the same strategy. Again, you can look at the search bar, which has a more rectangular design, matching the one for the Windows settings app. There is a line indicator to show which menu item is currently selected. And the icons have labels, which is similar to how the Mail app on Windows does. So this approach, building a native looking user interface, helps with building trust with users of your app. It also feels as a more natural UI that can easily navigate and be more productive with it. And it's an easy win for you too. You immediately take advantage of each platform's best design practices. So as you might use the Material or Cupertino libraries to build to design an app for Android and iOS, it makes sense to adopt the corresponding design system for macOS and Windows. In this case, the design guidelines can be found in the Human Interface Guidelines for macOS from Apple, and the Fluent Design or Windows 11 Design Principles from Microsoft. You can check these resources to see the suggested design guidelines for each system, like how a checkbox should look, or how to handle opacity or animations for your Windows. Now let's see how we can get to a native looking UI with Flutter for desktop. We mostly use two great packages to do that, the macOS UI package for macOS and the Fluid UI package for Windows. They both provide a wealth of useful widgets like buttons, drop-downs, list tiles and so on, and also a basic layout scaffold to work from with the dialogues, the correct opacity, animations for each system. They also provide the default colors and shadows that you can use for each version of your application. So the real challenge with Flutter is to get both these libraries mixed in the same code base, then to handle all the conditional logic of this integration, so what happens when the platform is macOS and what happens when it's Windows, and of course to extend or customize each library in cases where some component or some functionality is missing. So let me now show you some methods that we can follow for this. First, in our main.dat file, instead of Material app, we build a macOS app or a Fluent app, depending on the platform. This is done simply with a conditional check, as you can see here, for if platform is macOS. This is required in order to be able to use each package's custom layout, its widgets, its animations, and all the default components that both these libraries provide. We then create the so-called platform-aware widgets. These function as simple forks, these stateless widgets here, that decide which platform-specific widget to build. So if platform is macOS, we build a macOS text field, and if it's Windows, we build a text box. These are both provided by the macOS UI and the Fluent UI libraries. These render differently for each platform. For example, you can see here that the macOS version has more rounded corners, while the Windows one has a different drop shadow. The same can be done for other components that already have widgets in macOS UI or Fluid UI, like the confirm button here or the loading spinner. This way we can use the platform text field widget that everywhere we need and pass the same properties and values, like the controller or the placeholder here, to increase our code reuse. This is pretty convenient, but since both the libraries are still in development phase, there may be situations where a component is missing from either one library or both. For example, this was the case with the drop-down button. There was no macOS styled widget for the macOS version of the app, so the app initially used the Material theme drop-down button, as you can see on the right here. So what I did, and what we can generally do in such cases, is to extend the library based on Flutter's basic widgets. This means that we need to adapt it to the platform design guidelines, so we try to replicate, to copy the pop-up button from Apple's Human Interface Guidelines. You can see it here. It's a classic system-wide select used in macOS. So we customize Flutter's drop-down button appearance and behavior functionality to implement a macOS pop-up button, which has a different design altogether. It has a characteristic double caret icon here on the right. It has, of course, macOS themed colors. Also, there is no scroll bar when the menu is open, as you can see here. And there's a different behavior when there are not items that are not visible in the menu. We can see here the final result of our customization. And this way we can have a native looking component that we can reuse anywhere we want in our application. With these simple strategies, we are able to build a simple Flutter desktop app like this that looks and behaves natively for each platform. You can see here some screenshots and comparisons for the final result. On the left is the app on macOS, and on the right is on Windows. So here is the main screen. You can see here the different font and typography used for each platform. Of course, screen and dialog animations are another one. So when we hit and open dialog here on the macOS version, you see that it has a white backdrop, while it's a darker one for Windows. These are both provided by default by using the macOS UI and Fluent UI libraries. Form elements, of course, like checkboxes, text fields, and buttons are also looking native and try to adapt to the underlying operating system. So you can see the difference here between each version. And of course, the one that we talked about in the beginning, the difference in the adaptiveness of the application. So the confirm button is here placed on the right side for the macOS version. It's the opposite for the Windows one. So let's see now some things to consider if you try to follow this approach. Platform design, first of all, is so how things look in macOS or Windows is changing all the time. It may also not be that consistent. Windows is probably more notorious for this. So you can see here 5 different text box designs that you can find on Windows. So you should know that you may not be able to follow all native UI design 100%. I wasn't able to do this for my own app, of course, but it won't matter that much. So these UI libraries and this approach can get you really far along the way to a native UI by default. So users will not be that disappointed if, for example, your own text box has slightly more rounded corners than the one used in macOS. So if the core of your app's UI design looks and works great, don't fret it too much. And what about Linux? I haven't worked on importing this to Linux yet, but it's definitely possible. There's a Yarrow package that tries to replicate the Ubuntu Yarrow style. You can see some of its widgets here, and achieve the look and feel of Ubuntu desktop. So we can follow the same strategy by adding the Yarrow widgets to our platform aware widget, and add another check, like if platform is Linux, to build another platform design with a Yarrow themed application. Finally, here are some resources that you may find helpful if you are going to try something like this. There is a great guide for building adaptive apps from the Flutter docs. There are also the Apple and Microsoft design guidelines we talked about previously. There are also these great packages you can use, the macOS UI, Fluent UI, Yarrow packages, which are immensely helpful. There's also a package from called the Widgets window, which handles how the Windows design of your app looks. And of course, there is a Flutter platform widgets package, which follows a similar approach, a similar strategy, but for Android and iOS design. So the Material and Cupertino libraries. So this was a short introduction on how we can leverage Flutter's desktop abilities and community packages to build a great native looking app easily for 2 different platforms, macOS and Windows. I hope you found this useful, and I hope you try to follow and expand on this approach for your own apps as well. And that's my cut. As a goodbye from me, thank you for listening. I am really happy to be able to do this, and a big thank you to Flutter Vikings for giving me this opportunity. Thank you very much.
Thank you very much, Minas. And you know what? Today is this special day, and not only because we have this awesome news and awesome releases, but also it turns out that today is the birthday of our lovely Majid. And Majid did so much for the community, for Flutter community. And if you don't know Majid, you should know him. And Majid, these claps are for you. You're an awesome man. I love you. This is for you. And yeah, you please clap in the chat because Majid is awesome. And so is our next speaker. And our next speaker is the Kevin Zuhaida, who will talk about how to build and publish Flutter desktop applications.
Hi there, I'm Kevin from CodeMagic, and I help people set up CI/CD for their Flutter apps. But as you probably know, Flutter is not just for mobile anymore, and you can build Flutter desktop apps for macOS, Linux and Windows. But this isn't a talk about how you can develop these apps, it's more a talk about how you can get these apps published to the stores. And as you know, it's already difficult to publish iOS applications to the App Store, so try to think how difficult it is for the other channels. So in this demo, I'm going to show you how Flutter supports desktop apps. I'll create a Hello World app on macOS and then publish it to the App Store. And I really didn't know much about this a couple of weeks ago, but fortunately we're a small, close-knit team, and I thankfully had people to help me learn all about how this works. And I'll link you to some of the resources I used at the end of this presentation, but hopefully you won't need them because it's not that difficult. Anyway, let's get on. Okay, so let's get started by creating a vanilla app called Sharpie. And let's change into that directory. And first of all, let's open up Visual Studio Code to see what we've got. So we'll notice that we've got an Android and iOS folder, but no mention of macOS, Linux, or Windows. Now that's because I haven't got Flutter desktop support enabled. So to enable this, you need to do flutter config -- enable macOS desktop for macOS desktop support, and likewise for Windows and for Linux. But you'll see that nothing's changed on the right hand side there. So for an existing app, to generate those folders, we'll use flutter create and a dot. And then you'll see that we've got a macOS folder, a Windows folder, and Linux. Great. Let's just tidy this. Okay, great. So the first thing you might be tempted to do is something like this. Build a Windows app, and you'll straight away get a message saying build Windows, only supported on Windows hosts. So if you want to build desktop apps for Windows, you're going to have to use a Windows machine. Likewise for Linux, you'll get the same message that it's only supported on Linux hosts. Now because I'm on Mac OS, I can build and test my applications on this platform. So let's do something like flutter run -d Mac OS and just let it build and spin up the test of this particular application. Now we'd always recommend that if you're building for different platforms that you have access to the platforms that you're distributing your apps to, especially when users start raising issues and you've got to debug for those platforms. And obviously when it comes to the CI/CD pipeline, platforms such as CodeMagic provide Windows, Linux, macOS machines that you can build and distribute on, but you should always have access to those machines for development purposes and testing. So we are just going to test this application quickly, make sure it's working. Yep, it's counting nicely. So I think at this point we can close the application and let's get it checked into source control, and I'll show you how we can actually build this on CodeMagic. Let's clear this. And just to reiterate the importance of smoke testing your apps on the platforms that you're deploying to, I thought I'd just show you the same application that we've checked into source code and cloned to this Windows machine. And we can just do a flutter run -d Windows and just make sure the app is doing what it's intended to do before we actually start setting up our CI/CD pipeline. Okay, so let's give it a try. And it seems to be counting beautifully. Okay, great stuff. So in order to actually publish to the App Store, you're going to have to make a couple of modifications to the macOS app itself. So open up the runner.exe workspace in Xcode. And if we just bring that over here, what you'll need to do is make sure that you've added the bundle identifier here. So I've got io.codemagic.sharpie and set the version and build, although these will be, or the build at least, will be incremented as we set up the pipeline in CodeMagic. Another thing to be aware of is that for macOS apps, you need to modify the info.plist file. So I've already opened this up here, and what you'll need to do is add in a new key called app category, and I've set this one to entertainment. If you check the documentation, there's quite a few different categories to select from, and I've also set the fact that my app doesn't use encryption, using app uses non-accept encryption, and set that to no, which just means that my publishing to TestFlight will go ahead without any manual interaction. So just make sure you've set those things before setting up the app for publishing. Okay, so let's proceed to discuss what you're going to need in order to publish your app to the macOS App Store. So first of all, you're going to need an Apple Developer Program membership, which is about $99 a year. And once you've got access to this, you'll be able to create the required bundle identifiers and certificates and provisioning profiles and be able to distribute your apps. Now, one of the things that you need to do in the developer portal is create a bundle ID. So you can see that I've created one here in reverse domain format, which is io.codemagic.sharpie. So you'll need to make sure that you do this by clicking on the plus button here and then following the instructions to create a new app ID. Once you've done that, the only thing that you'll need to do is to hop over to App Store Connect, which you'll have access to once you've joined the Apple Developer Program, and create yourself an app. So if you go to the app section there's a plus button to click on where you can create a new app, and once you've done that, you'll end up with an app record here. One thing that you'll need to do when you're creating the app is select the bundle ID that you used in the developer portal. And once that's done, we'll then be able to start publishing and using CodeMagic to call the Apple API to create things like the provisioning profile and distribution certificates, so you don't have to do that manually. Okay, so let's look at CodeMagic and see how we can set this up. Okay, so let's add this application to CodeMagic so we can start building it. So I've already added this application in my CodeMagic demo team, as you can see here. And to do this, I clicked on Add Application, chose the team I want to add to, clicked on the button to connect the repository, told it where my source code is hosted, which in this case is GitHub. And then I selected from the drop down here my Sharpie source code repository, told it that I'm using Flutter, and then clicked on Add Application. Now, if we go into the configuration, you can see that I've already added a Windows workflow, Linux workflow, and macOS workflow. Now, all this means is I've got distinct workflows for each platform that I'm building, each with different settings. And in this case, I've told it that I'm building for macOS, and I want to run my build on a macOS Premium. And then if we scroll slightly further on down and look at the build section, I can specify the Flutter version I want to build with, Xcode version, whether or not I want to build a debug release or a full release. And I've also specified some build arguments here. And then we'll look at the distribution section. Here we've got our information regarding signing the macOS application, and I'm going to just use the automatic signing. This means that if we've created and uploaded our App Store Connect API key to CodeMagic, it will be able to automatically generate provisioning profiles and, if required, distribution certificates and installer certificates for macOS applications. So the other thing that we need to define here is the bundle identifier, and I use this drop list to pick the IO CodeMagic Sharpie bundle ID. If you do a quick search here, you can see this is the one that I selected. And then to actually publish to App Store Connect, you have to check this box here, and again select the API key that you're going to be using to handle the publishing to App Store Connect. And then really at this point all you need to be doing is saving everything that you've modified and then clicking on Start New Build. Alternatively, if you're using webhooks, then you can initiate builds by pushing code to the repository, but in this case I'm just going to manually select the branch and tell it that I want to build the macOS workflow. Okay, so if we now have a look in App Store Connect, we can see that I've got some builds here. I'd already done build number 1 and 2, and the latest one was 3. And if you've installed the TestFlight app on your Mac, as long as you're using Monterey or above, you'll be able to actually distribute this app to your machine and try it out from there. Now that we've successfully built and published our macOS desktop app to the App Store Connect portal, I thought we'd just have a quick word about Windows deployment to the store and Linux. So in order to deploy Windows apps, you're going to need to be a member of the Microsoft Partner Center, and this is a one-time registration fee. I believe it's about $99 for a company and a bit less for individual accounts. And basically it's slightly different in terms of the approach that we've used for macOS. For example, you're going to have to manually build what's called an MSIX package and manually upload that to the Partner Center and answer some questionnaires. It's very similar to the way the Android deployment's done before we can actually automate it with CodeMagic, but it's quite straightforward, and I'll put some links to that in the notes towards the end of this demonstration. And I'd also mention that for distribution of Snapcraft or Linux applications, we'd use Snapcraft. All you need to do is create a free developer account, and then you can register a Snap name, which can be deployed to Linux operating system. So again, I'll put some links regarding this where you can find out more information. So here's a link to some of the resources that I used for preparing and learning about how to build Flutter desktop apps. I found quite a few useful articles on the CodeMagic blog, as well as the documentation from the Flutter team and documentation from CodeMagic. So that brings us to the end of today's demonstration. Hopefully you've learned something useful, but if you've got any questions, then feel free to reach out. And thanks again for your attention. Bye-bye.
Thank you very much, Kevin. And we're actually moving towards the end of the day, at least for me, which is nice. And second nice thing is that we're going to have still 2 awesome things before we complete our day, or maybe begin our day if you are on the other part of the planet. So first of all, I would like to ask you to ask your questions in the chat, because our last event of this day is going to be Ask Me Anything with Flutter team. actually live. We will have them through the magic of the internet. And yeah, you can ask any questions. There are no silly questions. Just hope you to reminded. And our last talk of today is the talk from Tom Gilder. We're going to talk about Navigator 2.0 and what's wrong with the push method. So please meet Tom and welcome on the stage.
Hello from Helsinki. I'm Tom from Rebel App Studio, and today we'll be taking a tour around the Flutter Navigator 2.0 APIs, first of all looking at why you might want to use them in your app and how to do so. Rebel App Studio is a specialist Flutter agency based here in Finland, and we're a new offshoot from CodeMate, where we've been using Flutter since 2017, which means, and this feels a bit crazy, that this year we hit our 5th anniversary of using Flutter. We use Flutter to build amazing apps for our customers, such as for the Finnish mobile phone operator Moi, where we built both the mobile app and then brought it to the browser using Flutter for Web. And we've also been working on Flutter itself, partnering with Google to, amongst other things, add features and improve the usability of the Flutter dev tools. So let's dive in and look at why you might want to use this new API, or why you might need to use this new API. And just a word on the naming, all the Flutter documentation refers to this as the Router API. I will try to call it that rather than Navigator 2.0. Navigator 2.0 was kind of used while it was in development, and people, including me, are still kind of in the bad habit of calling it that. So let's get this example app up and look at the classic Navigator and how that works and why it maybe isn't quite enough here. So with this example app, it's kind of a word processor where we start off with a list of the documents, user taps their document they want, and we call the good old navigator.of_context push and the document root. And so the user gets that document on the screen, and then we call another push after they tap that comment, and they're on the comment page. And everything is wonderful and great. And why isn't this enough? Why do we need anything else? Why must we have something new to learn? And, well, the first answer there is we might not. The kind of classic Navigator push API, there's nothing wrong with it. It does a great job. It's a really simple and clear API. And if it does everything you need, if you just want to push pages based on a tap of a button, then that might be just all you need to do. Just call the classic push method. And if you're learning Flutter, I would probably just stick with this and not go anywhere near the new routing API. Also, if you're just starting a new app, you might just want to stick with kind of the good old push. It's actually quite easy to move to the routing API if you need to do it later. I've added it to a couple of apps where we've needed the new routing API, and it hasn't really actually taken that long. Now, the thing with the Navigator push is it does have some limitations. And the main thing here is, what if you wanted to push all of those 3 pages onto the stack at once? You can't really just keep calling push. It doesn't work. You end up having to have hacks in place to kind of disable the animation. It's not nice, and it doesn't really do it. And, well, the question there first is, why would we want to do that? Why do we want all these 3 pages on the stack? And the biggest reason, I think, for mobile apps at least, is deep linking from a push notification. So here we have a push notification that there's a new comment, and we want to take the user directly to that comment screen, but still have that navigation stack in place as if the user has navigated there. So if the user presses the map button, they can get back to the document and maybe fix whatever they need to fix on it based on that comment. And then the other big reason is if you are bringing an app to web, you need URL support, probably. Maybe not all web apps need that, but I think most would want that if the user wants to bookmark a page, or if the user wants to share a link with another user. You need to go from that web URL to this stack of documents. And there's a couple of other reasons, like state restoration. So if the app gets killed in the background, you might want to restore the navigation stack there. Or if you just want to jump to this stack from somewhere else in the app, well, that's a thing sometimes, that you just want to completely replace the navigation stack. And yeah, how would you want to do this? So I guess you'd want something like a list, right? So homepage, document page, comment page. And there's good news, because that is exactly how the routing API works. You can spin up a Navigator and just give it a list of pages like this: homepage, document page, comment page, with the IDs of the document and the comment. And the good news here is that the router API allows you to do all this deep linking, web URLs, all of this stuff. It does it. But there is a bit of an issue here, which is it maybe is a bit too flexible. And yeah, generally Flutter is very good at kind of leading you down a path of obviousness, I would say, of giving you kind of a way of doing things which is fairly easy and you can just get on with things. But if you look at the architecture diagram of the routing API, there's quite a few arrows as to how it all works, all of these different parts. And then there's all these different objects you need to implement. It's all a bit complicated, and frankly, it's not very Flutter-like. And so let's take a look at what this practically means in terms of code for your app. To implement all the bits here, to implement navigation in your app, and web URLs, and all the setup for deep linking. When the routing API was announced, they released a sample app along with it to show how it works. So let's go through the various bits of code in that sample app and see what you need in order to implement this. So first we define a set of path objects to represent the different pages of the app. Then we define an app state object to define the current state of the app's navigation and to notify the router when the state changes and the navigation needs updating. Then in our build method, we use that state object to determine which pages are on the navigation stack using a load of if statements. To implement URLs for the web or deep linking, we have to implement a method which returns one of the path objects from earlier based on the current app state. Then we need to implement another method which, based on the path that last method returns the actual URL string to show in the browser address bar. And then in order to go back the other way from a browser URL to the correct stack of pages, we need to implement a function which passes that incoming URL and returns one of the path objects. And then we need to implement another method which takes that path object, updates the global app state object from step 2, which will notify listeners and rebuild the navigator with the correct pages. And then we need to implement a pop page method in order for back to work. And then we need another pop page method because we have nested navigation. And yeah. And then when we take a look at what this sample app actually looks like, well, there is a list of books here. You can tap a book to go to a details view, and then you can go to the settings tab, and that's it. It's maybe, I would argue, quite a lot of navigation code for not that much app. So yeah, it's fair to say that this doesn't really scale, even to a fairly simple mobile app, let alone a full-blown web app or a desktop app with kind of responsive design. You end up with a lot of complexity. It's so much more complicated than the classic Navigator.push, and you end up with a lot of code to maintain, which, yeah, not great. The Flutter team have kind of said this, that they know this is a fairly low-level API, and yes, there is a lot of complexity that this API needs to support. The number of different operating systems that Flutter now supports, and especially web as well, it doesn't maybe sound like it, but there are lots of differences in how the different navigation patterns work across the different platforms. So iOS has no back button, whereas Android does, and then the web has back and forward and the URL to deal with as well. yeah, doesn't sound like much, but it does introduce a lot of complexity. And as I say, it's a fairly low level API and not great for day-to-day development with. So, yeah, what's happened? Where do we go from here? Flutter community to the rescue. Hooray! And we have got a load of great packages that try to solve the complexity here, that try to make this problem a lot simpler to deal with on a day-to-day basis. My friend Mike, who also lives here in Helsinki, has made this lovely chart of all the different navigation packages he found on pub.dev. As you can see, there's quite a few of them, and it is maybe a bit difficult to know where to start. This feels a bit like state management to me, where pretty much all state management packages do the same thing, just slightly differently. And with the navigation packages, it's pretty much the same deal. They take a URL and they turn it into a load of pages and put that on the navigation stack. Pretty much the same thing, and they just do them slightly differently. So just with state management, it's kind of hard to know where to start. And where I would suggest starting is, well, with the Flutter favorites that are now available. So there are 3, Beamer, GoRouter, and Routemaster. GoRouter is by Chris Sells on the Flutter team, and Routemaster is actually by me. I was very honoured to find out that I had been my package had been made a Flutter favourite. It was a big privilege. And yeah, I thought because Routemaster is my own, we'd have a little look at that. But I just want to say these other packages and many other navigation packages are awesome. As I say, they all do the same thing in slightly different ways. Other packages, for instance, are using code generation. If you like that, great. Personally, something that I prefer to avoid with navigation, but that's just my own personal preference. Yeah, they're all great. They all end up pretty much doing the same thing in different ways. So, try a few out, have a look at sample code, and see how you get on. But yeah, Routemaster, I spent most of my life living in London. Routemaster is the name of these old classic London buses. That's where the name comes from. And if we take a little look at some code samples as to how this works and kind of how it compares to the full low-level API that you saw earlier, I think you'll see it's a little bit simpler. So this is how you configure the routing using Routemaster. You create material app.router and you pass in a Routemaster delegate, which kind of handles most of the complexity for you, or at least tries to. You set up these different routes, very similar to many backend systems of defining URL paths. So here we have 2 different pages. And then, so it will default to page 1, and then we can either call Routemaster of context push or replace in order to go to page 2. And then with nested navigation, for instance, if you want a tab view, here is how you set that up in Routemaster. So on the left, you can see that there is a route map, which specifies a tab page with the child of a home page and the 2 different paths, which are the 2 different tabs. And then on the right-hand side, you can see the homepage widget itself, which simply defines 2 standard Flutter widgets of the tab bar and the tab bar view. And it grabs this tab page object, which Routemaster provides, and this is all you need for URL routing with tabs. One other thing from Routemaster is that you can swap route maps kind of on demand. This is a very common thing that you need to do with routing, particularly with apps that support login. So when you're logged out, if you look at the top route map here, it just defines 1, which is the login page. And if you try and navigate to anything else, it has this on unknown route handler, which just redirects back to the login page. Then you would have another logged in map with all your actual app routes. And then in the Routemaster delegate, you can just look at your state. And depending on whether the user is logged in, it will return the correct route map, and done. This will handle everything. You don't have to worry about guarding individual pages and checking if the user is logged in. They just won't be able to access them. Now, as I said earlier, it doesn't actually tend to be that complicated to move from the classic Navigator.push APIs over to one of these new routing packages. It tends to cause maybe less chaos than you might think in an established code base. But there is one bit of refactoring that tends to pop up again and again, which is we are very, very used to being able to do this kind of pattern of having an object in memory and just being able to pass it to the next page. So, for example, if we are on a page with a list of documents and we have those documents in memory, well, it makes sense to just hand that document object over to the next page. The thing is, if we are running on the web and we're adding direct URL support to go to that document, well, when that document page is shown, that document just isn't going to be in memory. You're going to need to fetch it from wherever it comes from, a database or whatever. If we look at a routing setup in Routemaster, so you can navigate to /document/ whatever the ID of that document is, and the document page will just receive the ID, which is just a string for that document. And that documents page is going to need to handle retrieving that and possibly dealing with errors. If that document doesn't exist, you'll probably want to show a 404 page or something like that. I thought it might be fun to have a look at a real-world app that's using Routemaster, and I am kind of excited by this because I've actually been helping out an app team on a forthcoming really exciting Flutter app to add Routemaster support and handle quite a few fairly complicated navigation scenarios, and that app is Superlist. It is an awesome upcoming Flutter desktop app, and I'm really excited by it, and I'm really excited that I can show you it now as a sneak peek if I just switch over to my Mac. And yeah, here we are, Superlist. It is just awesome. I have been blown away at how good a job the Superlist team have done on this app, and it's just by far the best example of what you can do with Flutter for desktop, and also writing productivity apps, the kind of app we maybe haven't seen before with Flutter. And yeah, they needed a little bit of help with the navigation, things like adding deep link support. They were using the classic Navigator APIs, and we helped them move over to use Routemaster to navigate around. And I thought I'd just give you an idea of how that works with the various paths and how the navigation works. So as you can see, the kind of homepage here is a list of my tasks, and I've added a ugly readout of the current page up here. Sorry, Superlist team, for ruining your nice design, but you can see this is the path /Superlist/my tasks. If I navigate into this Write Vikings talk task, you can see it has called Routemaster of context and just pushed this string, this path onto the stack, which has brought up this detail view in the right-hand card. One of the interesting challenges with Superlist was that it needs to be responsive, so if I resize this, it shrinks down into just one task, just one card view rather, and you can navigate back and forth using the back and forward buttons up here. So how this works with Routemaster is it goes backwards through the current path. So it starts off here at the end going, okay, we've got task 2. We need to build a object to a widget to show that, a page object to show that. So that is this right-hand card. It then keeps going back through the path and finds that it's got the My Tasks page here. So it builds that page, and then it embeds it all in a homepage widget. And this results in being able to copy a deep link and send it to someone, and they can open it up, and that will open up their Superlist app at this exact navigation stack. And even with an app as complicated as Superlist, with all its responsive design glory and needing to support both desktop and mobile, it wasn't actually massively disruptive to the codebase to move from the classic Navigator.push old APIs over to using Routemaster and the new routing APIs. Generally, it's kind of a one-to-one swap. You used to push routing objects onto the Navigator, so calling Navigator push and then a material page route, for example, moving over to just pushing a route, which is just a string. So one-to-one swap doesn't tend to be that disruptive. You just then need to add a list of routes and you're done. Were a few more complicated things with Superlist than that with the kind of card views, but yeah, most apps, it will be not that much work. Anyway, that's pretty much it for this tour around the routing API. Just time to look at a summary of what we have been through. And yeah, the main point here is you might not need any of this. If you do not run into the limitations of the classic Navigator API, if you don't need deep linking support, if you don't need web URL support, you might be able to just stick with the classic APIs and be absolutely fine. This is one of the parts of Flutter that I feel like you can very much benefit from doing on-demand learning. When you know the limitations of the classic Navigator API and you know when you need to learn one of these new routing packages or the base API, then just do so on demand when you need it. There's no need to move over to this if you don't have any need for those things that I've talked about. Learning the actual API, maybe not that useful. As you saw, it's fairly complicated. And yeah, you might be able to get an idea of what is going on behind the scenes, but I don't think in the main that is useful for most people. I think it's much better becoming very familiar with one routing package and just using that. And so, yeah, that's my main recommendation. Pick a routing package based on your preferences. There are lots. They do the same thing, but slightly differently. And just find one that suits you and run with that. But yeah, that's it for our tour around the new Flutter routing APIs. I hope you've enjoyed it and not got lost along the route. This has been an interesting journey for me, writing Routemaster and learning about all the different navigation issues on the different platforms and trying to make one API that works across them all. It is a really interesting and difficult problem, both for the Flutter team themselves and for people writing routing packages. Even if you ignore supporting all the different platforms, if you just take, for instance, Android, which seems to be the most fun one that comes up again and again, I asked last year on Twitter, Android users, if you open an app and then just switch tabs, press the back button, what should happen? And there was basically a 50-50 split between what people thought, and then there were some other people replying that something completely different should happen. So yeah, just supporting Android is a challenge in itself. When you add web into the mix as well, it becomes quite complicated. But I think the community is doing an awesome job in moving this forward and coming up with really interesting new ideas for packages. And yeah, I think it will give us lots of fun for years to come. But thank you very much for Flutter Vikings for having me, and thank you for joining me today.
Thank you very much, Tom. By the way, really nice microphone. And right now is your last chance. First, not to ask questions, but of course, it is your last chance to have a selfie with true Viking. So, Majid, please welcome to stage.
Hi.
Hi, Majid. And you know, right? So these horn helms, they are not like
Yeah, let us be happy. Why did you mention that? I was quite happy having these horns. And I got a big one this year, actually.
Yeah, of course, it's horns, they are really important. So you can have a selfie. Probably, Majid, you can hide me so you can have a selfie.
Let's have 1 to 2 minutes, more or less, a selfie with Vikings, post it on social media, and you might win something. Okay, wait a second. 1, go. Now, You have another chance. I have also access. Give me a second. There you go. And all right, Flutter developers, this is awesome. So let's have Evgeny again on the stage. Thank you, Evgeny, giving me 2 minutes to give people this chance of taking some selfies with Vikings and have some memories with Flutter Vikings.
Yeah.
All
yeah.
right, so I'm gonna leave the stage.
No, no, you can stay. Well, you can do whatever you want because you are the Viking here. And you have a next.
Stage is yours, Evgeny.
Okay. So hopefully Majid will wear this for the rest of the year because why not? And we actually are preparing ourselves and our stage, our virtual space for the AMA session with Flutter guys. Flutter team, I don't know how to call them. Flutter, let's say main people in the Flutter area. But of course, it's not true because main people in the Flutter area are the developers and Flutterers. So, are you guys like excited about everything that's going on? Because I am, and this is late evening for me. And if you have a morning, probably with your sip of the coffee, you are excited or not. Tell me in the chat. What do you feel? Flatties. Yeah, James. What is your favorite emoji to explain? More coffee. Yeah, coffee. Coffee is nice. Is nice. More coffee. You know, a funny thing about the coffee and that excited. Salih, of course you're excited. By the way, we had some discussion with Salih right now. And I think that he did awesome job warming up for for me. And yeah, hearts, excited, coffee. It was a nice event, and I'm a little bit. I have a little bit sadness. Let's say sadness because it's the last session today, but still, hopefully, it's gonna be really nice. As excited as watching Firebar without Ace, so Firebase probably. I'm lucky to share the stage. And probably Majid, correct me if I'm wrong, maybe we can slowly kind of adding people on the stage. Okay, we need 1 or 2 minutes. So, and probably I should have some jokes prepared, right? But I don't have them. Okay, what's the common between a Viking and the unicorn? Mangirnis, I would not say it's live because yeah, it's the joke is a little bit. Both drink coffee. They both mythical. Nice one. Well, the thing is that I don't know the exact answer because it's just type of joke that's coming up on the stage. Both are mythical. I don't think that's not true because you just already seen the true Viking live somewhere in the middle of Norway in the cold winter Norway. They don't exist. Maybe I think the best joke gonna be something about mythical horns. So yeah, the horn make the difference. They use Rootmaster. No, I don't think so. How do Vikings hide secret nodes in their Flutter app? Norse code. Nice one. I think it deserves this one. Yeah. Both going on magical journeys. And I don't know, Majid, help me. Are we ready or not? Or we're waiting for Okay, cool. So we're ready to announce our next section. And as I said, it's AMA with the Flutter team, Flutterers. And you can post your questions in the chat. We will try to ask all of them, but as you understand, the time is limited. So we're ready to adding people on the stage. Some music, yeah. Our first guest today is Craig Labens. Hi, Craig.
Hey, how's it going?
Good, nice. And looks like you have a sunny day.
Yeah, in Northern California, pretty much every day is sunny. We could actually use some rain.
Yeah, I don't know. I prefer dark, gloomy Norwegian winters without any sun because it reflects the soul of a wanderer.
Yeah, I grew up in an area of the United States called the Midwest, and we rolled the same way there, so I feel you.
We're ready for the next speaker. Hi, Frank. Hi.
Hey there.
Our next speaker is Frank van Puffelen. He's from Firebase. Yeah, and hopefully, if you know Firebase, you should know Frank.
Yeah, I always say that if you use Firebase and you don't know me, then I've done something wrong.
Yeah. Our next speaker is, drumroll, is Fitz. Hi, Fitz.
Hello. How's everyone doing today?
Outstanding.
What are you holding there?
I am holding my Lego Dash.
Wow.
Nice.
Is it official or you just made it out of the standard components?
I just made it out of the random components I had around. Yeah.
The same as the Flutter libraries, right? Made out of the random components. Sorry.
It's just a bunch of widgets thrown together into a blue square.
Nice. And last but not least, pretty well known. I have a drum roll. Chris Sells.
Hey.
Hi, Chris.
Hey, how's everyone?
I'm good. How are you?
Yeah, we're great.
Excellent.
Yeah.
We managed to pull it off, so I'm happy.
Yeah, nice. And we have, I don't know, thousands of questions. So I'm sorry, dear Flutterers, Flutteristas, and Flutter engineers, developers. We will not be able to ask all of the questions, unfortunately. But let's start from the first one. So, and the first one and the most generic one. So probably, I don't know who is going to answer, so we will manage to do it. How do you see the future of Flutter? And I would add on top of that. So right now we see the huge milestone, Windows. And does it mean that, it's done. Ecosystem is done. We have all the platforms. We will not have to do anything. Yeah. It's done.
So no, we are not done, not by a long shot. Let me just harken back to 3 years ago when I joined the team. I actually got my first week on the Flutter team. I was in London when we did Flutter Live, and we launched the first production version of Flutter for Android and iOS. And over that 3 years, we have made such improvements to Android and iOS, right? I mean, that was the initial version. It was ready for production, but there was so much optimization, so many features. The underlying platforms changed so much over that 3 years. And, it was our job to keep up to date, and we have, as well as improving things along the way. Then, of course, March of last year, we reintroduced the web production into stable. And so now people can, build Flutter web apps in production, and we have continued to work on that, and we will continue to work on that. Now we released Windows in stable, and we have lots more work to do there to add features and to support new functionality that we don't out of the box today. And of course, we haven't made Linux or macOS available on the stable channel yet, so we still have those to release. And even when we have those released and we've made more progress across all those 6 platforms, of course there's Flutter on any number of embedded devices. We're working with partners like Canonical, who own our Linux distribution. We work with Toyota, who's putting Flutter in cars. We're working with Sony. We're working with Samsung and Tizen. And my summary for the future of Flutter is it's so bright you have to wear shades.
Nice.
Nice.
Yeah, one thing I want to add to that is we're paying a lot of attention to the good ideas that other technologies and other platforms are having. Like Swift is innovating with Swift UI, and we don't want to fall behind as other frameworks add really great ideas. We hope to not lag behind too much on those, and of course we also hope to keep innovating with our own good ideas. So no, we've not reached the end of the road by any stretch.
The higher level thing that I'll add here is we're focused on making a good developer experience, and so that's going to be deploying apps where you are, giving features that you need and want, and ways to make it better. So, as Chris and Craig have both said, there's plenty more to do in the future.
Okay, and Frank, probably you can answer the same question from Firebase perspective, because Flutter and Firebase, yeah.
Yeah, okay. I thought I was done. I thought this was going to be the last day I had to work on anything with Firebase and Flutter, but now they tell me there's more to do. So, no, especially on Firebase with Flutter, right? I'm really excited always to see these work together so well. Yet I also know that there's a lot more that we can do. So whether it's bringing Firebase to new environments, new platforms, or adding features that developers are asking for, making our APIs more usable, yeah, there's lots more left to do for us.
Mm-hmm. And actually, it's kind of segueing us to our next question, and talking about platforms and different targets for Flutter. So any update on how to build watch app or easier TV apps with Flutter?
Yeah, so the watch has never been a platform we have targeted, only because the Flutter runtime itself has certain both space and memory requirements, right? We have worked very hard to optimize the runtime, and it's down to about a 5 megabyte kind of chunk of your app, even for Hello World or whatever you build. It's the engine that is required, and so that right away puts it out of range of a lot of current watches. However, potentially in the future, as watches get beefier, we could imagine Flutter running on watches. Certainly on the TV side, while it's not an officially supported platform, getting Flutter Android running on an Android TV is largely a matter of configuration. We've seen many people make it work today. And there's also some enterprising folks in the community have taken Flutter and made it run on their own custom set-top boxes. They've made it run on Apple TV. Again, these aren't directly supported by the Flutter team, but of course the beauty of an open ecosystem is people can take Flutter and make it work wherever they want to.
Okay. Yeah, and probably like in 10 years we will see that something in between the watch and iPhone or Android phones, or I don't know, some wearable, wrappable phones, whatever. I don't know. We will see. Some question back from 2018, probably, what is the best way to tackle a null-safe migration where there are 1,000 plus warnings and issues? More on the technical side, yeah.
Yeah, it's funny. We have a couple of ways to deal with that. The first and foremost, there's the Dart migrate command. If you haven't done that, do that. I had a number of projects that I moved to null safety, and what I did, the tool is amazing. It's interactive. You could read through individual lines of code, and you could and you can say, oh, I don't want to migrate that, and it would update the rest. And the migration tool itself is fantastic. But what I ended up doing instead was just say Dart migrate, accept all of the recommendations, and then run all my tests and fix the small number of issues I had after the tool just did what it thought was best. And then over time, noticing, oh gosh, I don't even need this to be null. I can change that and update things over time. I found that to be the kind of quick and easy way to do it. But for sure, everything starts with Dart migrate.
Yeah, I do want to acknowledge that it's really a huge undertaking to migrate a mature app with a large code base. I know some folks have reported that it was a lot of effort, multiple days of effort, just spent kind of seeing to all of the details, even with the tool. So the one thing that I can offer is that you only have to do it once. And then you're null safe forever. But it can be tough.
Mm-hmm. And by the way, talking about like null safety, and null safety was the huge milestone, and on the other hand, a huge kind of breaking the code moment. So, and question, where is that? Sorry, and questions for Frank. So any plans, and of course, questions, I love questions about the plans because it's hard to answer, but still, any plans to have breaking changes to Firebase?
It's really nice that you're asking that one, because I saw it come by in the chat and I was like, yeah, I'm not going to answer that one now. And then, of course, you prompt me here. No, there are going to be breaking changes. Like almost every year around I/O or the Firebase Summit, we'll have breaking changes. Now, it takes a bit of time before those land in the Flutter SDKs, but I don't expect this year to be any different. That doesn't mean that I can tell you what features we'll be launching, by the way. So that's a whole different thing, right? But those are also not breaking changes. Those are new features. So I'm desperately trying to think through the list of like things that we are working on, which might be breaking, but no, it's hard to say. There's always updates coming out. Some of those are breaking. If they are in major versions, of course, only. And we really desperately try to limit those to once a year, either at I/O or at the Firebase Summit.
Mm-hmm. I see. Yeah, I believe, there is no progress without breaking changes. I mean,
exactly, yeah.
Hard to.
And on Flutterfire, we had a few bigger ones recently, right? I know that when we added type safety to the Firestore libraries, for example, that was a bigger breaking change that affected a lot of people. The best we can do there is write a good migration guide and then point people to it when they get the error messages, unfortunately. Right? That's what we do. So we try to limit them, but indeed, you can't make big improvements without sometimes breaking a few eggs.
Mm-hmm.
Omelets are in that same category. You can't make big improvements or omelets without breaking a few eggs. Yes.
Yeah. Breaking the omelets. And by the way, dear viewers, if you have like some problems with the sound or something like that, sorry for that, but it's internet. It's hard to control everything. So, and what do you guys think about the future of 3D? We've seen a lot of hype around that in the beginning, like WebGL or, I don't know, some glasses, wearable things. OpenGL, I don't know, some games. But right now, it's not on the hype, or I don't know. What do you think about the future of 3D and especially, of course, Flutter and 3D environment?
Well, I'm a big fan of 3 dimensions. That's where I live. And it is way better than just 2, for sure. In general, it is interesting. We have been working to expose essentially the low-level piece across platforms, the textures, being able to, essentially, control the screen, which allows you to do things like, hey, I'm going to generate a 3D scene and drop it into the Flutter renderer and do things like that. And we've done some work internally to do that, make that happen. There are some folks that have done some work externally, I've seen against this API across the platforms that support it. I personally, I've also seen crazy things like people forking the Flutter engine and then wrapping their own 3D engine around it, and so that they can use this hybrid of Flutter for, you know, all of the things that Flutter is great at, and then, you know, when it's time to do cool 3D things, and they drop into the 3D part and they get the best of both. I've seen some projects to integrate Unity and Flutter in that way to provide kind of take advantage of the multi device support in both of them and making them both work together. I think there is definitely work to do there. And of course, Flutter, and as Craig pointed out in his talk yesterday, Flutter and Unity, right, are both, you know, Flutter is an app engine, Unity is a game engine, right? They're not very different, and they could be, I think, with some work brought together, which would enable all kinds of interesting scenarios, certainly games of all kinds for sure, but also all kinds of business scenarios. That isn't on the Flutter team's roadmap today. However, it is kind of a gleam in our eye, and that is something I would love to see us do in the future.
And by the way, talking about the games, people in the chat asking Craig and Frank when the Maze game will be released, because it was outstanding and awesome.
Well, multi-maze.
Are you going to release that on the Steam store or anything?
We didn't discuss plans there. We are releasing it on there's this old software distribution platform. It was called HTTP and browsers and domains. And we've released it there officially at multimaze.app. Yeah. So no plans to take that down. So if you want to stumble into each other at any point, it'll be waiting for you.
I doubt we'll get the number of players we had concurrently yesterday, though, right? That was awesome to see. It's not often that I burst out laughing that loudly, right, where I can't control myself, because I don't often get this number of users on an app that I build. Most of the apps we build get like 2 users, right? Me and the person who's having a problem, right? And that's about it. This was really fun to do. It was also surprising how hard it is to steer an avatar to cooperate with essentially 80 to 100 people on the internet, right, with all the latencies involved, and steer an avatar to the exit. So it was really fun to do.
Mm-hmm. Yeah, and so right now we've talked about more on the, how to say, like a client side and not from the like company side Flutter, enterprise Flutter, if I can say so. And in the chat, some people asking on dev relations, and we have plenty dev related people here. So will be there any work on, I quote, convince enterprise assets, white papers, etc. in the next year? Something for a serious business, you know, banks, whatever.
That's a great question. I think, you know, one of the things that we're always trying to do in DevRel is meet people where they are and what they need in order to help use the thing better. In this case, the thing is Flutter, or convince other people that they need to use it. And so one of the things that we're looking at for this year in Dev Relations is just trying to find ways to create content, whatever form that might be, that is going to be valuable for people wanting to make production apps. Like that's a thing that people are doing, is making production apps with Flutter. And so how can we help people best do that? It's a question on our mind for sure. How that actually manifests, whether it's white papers, very focused videos in terms of the content, very focused blog posts in terms of the content, and how that comes about, we'll see. But it is definitely something on our mind. How do we help more people do better production apps?
The other resource I'll point out is that there have been a number of enterprise customers for Flutter that have published their own case studies. eBay, BMW, Nubank, Betterment, right? There are a number of blog posts and white papers and things that kind of dissect kind of how they approached it, what worked, what didn't, what they do, what the impact was, and these are we find these to be very useful for enterprise customers, because then they can go and say, oh, well, it was good enough for BMW and eBay and et cetera, then gosh, it's good enough for me. So those are the kinds of case studies and things that I would point you at. And of course, Nubank, IBM, or BMW, right? These are serious enterprise customers. So hopefully those will be convincing to your management.
Okay. Enterprise customers, they are pretty important, and their needs are sometimes completely different from average users. And let's jump into some kind of like question about the language itself. It's not that related to Flutter, but still. So there are a couple of them. Data classes can come to the core data class and dependency injections. And / next question is about metaprogramming. So what about this like fancy, not fancy, but kind of like language features?
I myself am very much looking forward to a number of new language features coming out of the Dart team. Actually, to me, it's amazing what the Dart team has already done, being able to add null safety to an existing language in a way that you can actually get all the way null soundness, right? Where 100% end to end of your code is null safe is amazing to me, and you get the performance and size benefits that come along with that. But yes, I like everyone are looking forward to metaprogramming in Dart, or I think we're calling it Dart macros now. But the idea is being able to decorate your code and be able to generate other Dart code to generate a bunch of extra behavior based on a macro. So being able to say, hey, gosh, I would like this to be serializable. And today, what you have to do is you have to kind of run a separate builder process that will take that metadata and then generate some code, and then you build it into your app, which is about 10 times harder than I want it to be. And the idea of Dart macros is you can have the same syntax, but all of that code can be run as part of the compilation, the normal compilation process, including the interactive compilation process. When you're in, the IDE or an editor that supports LSP, we've got the Dart analyzer running in your code, and that includes running macros for you, right? So that you can add a bunch of functionality to a class that's been decorated, and then you can get to it all, and the IDE knows about it. So when you say foo dot, it will have all of the extra functionality that the macros have added as well. I can't tell you how excited I am about that particular language feature.
Yeah, and unfortunately, Craig has some difficulties. But Frank, question is for you, not so you will not be bored about the questions about Flutter. So what about push notifications on devices without Google Play services?
I'm not bored about questions about Flutter. I'm learning a lot here. Also, I think Greg might be helping the avatar getting out of the maze. Got stuck in a corner. So that's what's happening here. You said push notifications to devices without Play services. Honestly, I don't think we're actively working on that right now. We've looked at that in the past. It's a lot of it is essentially outside of our control, right? Push notifications are done in Google Play services for the largest part, right? And that is not on those devices. So we always will need to work with those vendors of those devices. Yeah, we made some progress at some point and then not anymore. So nothing going on at the moment. I know it's a big wish. Most of those devices simply don't support that level of notification to begin with, right? They have local notifications, but no way to receive messages for all apps in the background, which is what Firebase Cloud Messaging in the end does, right? It's two things. It's delivering the messages from some server to all the devices, and then on the device there's some code displaying it. That last bit is normally not the hard part. It's the energy efficient way of listening for messages for all the running but not active apps. That is the hard part.
And I believe like adding features to any product is the same as the trying to answer all the questions from the chat. It's not possible, unfortunately.
I should know that, right? I answer a lot of questions on Stack Overflow, and then somebody is still going to be like, "You didn't answer my question." It's like, yes, there were about 100 today. That's a lot.
Yeah. And next question is about the Flutter, of course. For responsive apps, non-Flutter web apps have grid and flex systems, and iOS/Android have size classes. What should we use in Flutter?
Well, do you want to take it?
Go.
I mean, with Flex, you can normally get similar things with like column or rows, space evenly, space between. That seems most similar to Flex for me. With Grid, there's the wrap element, which will start to wrap things onto the next row. And then there is also a grid, which offers some of the same APIs. I know that the full extent of what you can do, you can lay out an entire website only using CSS Grid. And like that is some really powerful stuff out of that specific API. If we call a specific CSS rule set an API. And in Flutter, you do have to kind of use a wider variety of things, but I'm not aware of any UIs that are possible from Flex or Grid, but not via widgets. And to start to get the majority of that feel, again, look at like row and column with the main axis alignment. But anyone else have any thoughts?
I have a non-answer, which is you can use whatever you want. Which is kind of what Craig was saying too. But, I think part of the great flexibility here is that, we don't have one solid recommendation on what kind of layout to use because there are a variety and infinite number of different layouts you can do. And so Flex has its limitations, Grid has its limitations, row and column have their limitations, flexible widgets have their limitations. Any layout system you decide on is going to have its limitations. And so by providing the building blocks for you to build whatever kind of layout system you want, that's where we're focusing and giving you the options to do what works for your app, because we can't predict what your app is going to do.
Totally agreed with both Craig and Fitz there. I'll just add that, like Craig, to my knowledge, there are no layouts that you can't achieve with Flutter that you can achieve in CSS. The way you do it is different, but the result for the user is the same. And if you look on PubDev, you'll see a number of people have said, hey, I want a, like Bootstrap. I want the, being able to lay out my Flutter app with something like Bootstrap. And people have built those kinds of different layout algorithms that you can just dump into your app if something like that is more familiar to you than the ones that come out of the box with Flutter. And that's totally fine, right? Flutter was made to be flexible like that. So you can plug in at each one of the levels, and somebody's plugged in at a layout level. That's great. And if you like that style, feel free to use that style. If it makes your app look and feel the way you want it to do, then that's the right thing to do.
There is a question in chat. I would not ask it, but what is the best state management system for Flutter? But of course, yeah, well known. This is the best joke for Flutter developer. But actually, a little bit more provocative question and more generic. So, what about Flutter adoption or /dogfooding inside Google? And the question exactly is when Google will write more apps with Flutter. I think that at the moment Google Pay is only app written in Flutter by Google.
Oh, that's not, wow. Okay, wow.
It's not my question.
No, I get it. No, so certainly Google Pay is the largest publicly known app on Google to adopt Flutter. but it is by no means the only one. In fact, we have 30 teams, 30 plus teams, and I say plus because it keeps growing, engineering teams at Google that are building Flutter apps of various sizes. Of course, Google has the same problem that every corporation has, which is, hey, they want to target multiple platforms, they don't want to have multiple teams, multiple source code bases, and so Flutter itself is used across a large number of Google teams, and that number continues to grow. In fact, there are some very exciting teams building with Flutter across many different platforms that I can't share with you now, but will become public over the next the rest of 2022. Lots of Flutter use in Google, and that use is only growing.
Yeah, and there was a recent kind of fun revelation. For a long time, whenever a team at Google wanted to use Flutter, it was kind of a risky decision. Flutter was new. They had to research it. They would come to the Flutter team and do this preliminary kind of due diligence check to make sure Flutter was, in fact, a good choice. But we've recently started to find out that teams are just choosing Flutter and not even bothering to talk to us about it. So every now and then it'll be like, oh, that product is rewriting itself and they're 5 months into a Flutter, the next app is Flutter. They're 5 months into building it. Cool. So more are always coming.
Yeah, cool. It's I think it's hard to expect when 100,000 employee corporation has like. Just imagine everyone texting to guys in the Flutter team, hey, we're using Flutter, we're using Flutter, we're using Flutter. And the next question, it's I would try to ask it in a more generic way and not in the precise way that someone asked. So in the Flutter and all newcomers, they always struggling with a lot of runtime checks, like if this platform do that, if that platform do that. So, and the question is, when we will be able, or will we, to do a platform checks at compile time to better handle native-looking UI without creating separate build files or doing checks at runtime, like master text field widget that will be adaptive across all the platform UIs, something like, with benefits of tree shaking?
I'm not sure I understand the question. We have text editing widgets that work across all platforms now. We've got testing in both, widget, unit, widget, and integration testing end to end. I'm not sure I understand the question, to be completely honest.
So, for example, right now, as a Flutter developer, I have to write some amount of code checking what kind of environment I have and do something about it. What do you think, is it kind of okay-ish to write this amount of checks? Will it be somehow changed in the future? I don't know. Something like
I actually recommend against checking the specific platform if you can get away with it. Instead, what you want to do is look at things like screen size. How big is my app right now? Is it small? Oh, then I will provide a small based UI and arrange my navigation and layout appropriately. Is it medium size? Is it big, etc. I would not spend my time if I can help it. Now, it turns out that there are certain things you want to do that, for example, oh, this is only available on Android, this is only available on iOS. But when I write my code, what I try to do is have one, I call it a services implementation. I have a set of, a core set of services, and then sometimes those need to vary across platform. And that's where I put my platform specific code. And that way I can just reach up and grab the services object that's appropriate for where I am. I check once, am I Android, am I mobile, am I web, am I whatever? And then I just grab that object and then I have the right implementation swapped in. I do not, if I have little, is Android, is iOS, is web bits sprinkled in my code, I know I've done it wrong.
Yeah, I would add to that federated plugins are a really powerful tool that you can use to help with some of this. And granted, it doesn't, it kind of alludes to some of the question there, which is how do I avoid different build files and things like that. But, it's really powerful to be able to say, this plugin provides these particular features on this particular platform. And in my actual app, I just have that top level interface that is going to say, give me whatever this plugin provides, and then it'll federate out to the right platform. And then everything else Chris said.
Yeah, I do think there is another reality that a developer can find themselves in where this question isn't as avoidable as we're kind of making it seem right now. If you don't want to have a specific design language and you do want to be more platform native, like seem like a more off-the-shelf Cupertino app on iOS and Material and Fluent and whatnot, then I'm not aware of a way to get around those checks. Like something is going to have to check, right? Whether it's your code or like code that you use but maybe haven't looked at, and so it feels like the check is happening magically. But if you kind of wall those things off in adaptive, it could be a named constructor on a widget, .adaptive, you see it on some that are in the framework, then it can kind of feel at least more contained. The tree shaking one is an interesting question because a lot of those widgets are going to be, potentially it's like they're all kind of in the same file. Whatnot. I'm not sure if like the flavors of your adaptive widgets that don't get used would get shaken out. Tree shook. I'm not sure what the conjugation of that is. That's an interesting question. I don't know that. But something is going to have to make those checks, and it's, either secretly in a widget that you haven't kind of opened pulled back the covers on, or if it's a widget that you're writing, then I think you have to kind of make those checks.
Yeah, I mean, if the question is, hey, less about how do I avoid sprinkling that in my code, because every problem in computer science can be solved by adding a layer of abstraction, but rather, gosh, I'm not getting the tree shaking to work the way I want it to, which is the exception to the previous rule, which is performance problems are only solved by removing layers of abstraction. I think that it is entirely possible that we could do a better job of tree shaking when it comes to these cases, right? Which is, hey, I run on Android, I want to look like Material, I run on iOS, I want to look like Cupertino, those kinds of things.
Mm-hmm. Yeah. And there are plenty of other questions about that in the chat, but we don't have much time left, and probably I would ask some like specific questions to specific people. And a question to Craig: is any progress on Flutter development experience research that you could share?
That I can share? I don't think so. If you have specific like thorns in your side, then be noisy about them. But that question also doesn't actually feel specific to me, so I do want to kind of just bounce it right back to everyone.
I think a different answer would be to check out our quarterly report on the survey that we ask you all to fill out every now and again. I think that survey polls a lot of your experiences and development experiences that people have, and we report on it, and we dive into those really deeply and try to find, and we have a research team that runs those, and so that's going to be one of your really good sources of what we know and what we see as well.
Mm-hmm. Thanks. And it's hard to imagine any MA session with someone from the Google without mentioning Fuchsia. Of course, why not? So the question is Flutter still closely coupled with Fuchsia?
It is not, and it actually never really was. So Fuchsia considers itself capable of using any UI toolkit. Just so happens that Flutter is, in practice, the only one that's actually used seriously. But no, Flutter and Fuchsia are nicely decoupled for sure. I mean, Fuchsia can Flutter in particular can live a long life and not even know that Fuchsia exists. And Fuchsia is also able to do the same. It just happens to pretty much only use Flutter as its UI layer. But no, those two projects are nicely separated.
Mm-hmm. I think the hardest question about Fuchsia is how to pronounce this damn Fuchsia. Or Fuchsia or
well, the way you're pronouncing it, Evgeny, is the way I remember how to spell it.
Yes.
But we pronounce it fuchsia, like the color.
Mm-hmm. I see.
Yeah. So for a lot of native English speakers, they hear the pronunciation first and then have no idea how to spell it.
Right.
And so our version of that joke is it's impossible to spell.
Right. Right.
Yeah. And probably to wrap things up, I would ask some like pretty generic question, but probably it will help everyone from the community. So leading these huge, enormous projects, Firebase, Flutter, Dart, of course, you probably have your own backlog or like plan for upcoming years. And on the other hand, there is a huge community that demands something. Data class, and there was one question about when we have a second UI thread in Flutter or other questions. So how you guys manage this, and what is your strategy on developing this, on one hand open sourced, on one other hand is pretty complicated things, and how someone from the community would affect this? I don't know, raise the popularity of some issue, or I don't know, somehow inflect you to do something?
Yeah, those are all good questions. I mean, just to be clear, right? We are not a shell of an open source project, right? We don't do a bunch of our work internally and then eventually we reflect it externally, all completely done. Which would make my job easier, by the way, as a PM who's trying to create excitement and momentum around releases. We don't do any of that, right? We do everything we do in public. Our specs are public, our issues. It looks like we have a lot of issues because, well, it looks like we have a lot of bugs. We do have a lot of issues, but it looks like we have a lot of bugs, which we actually don't. That's actually a small number of P0, P1, and P2 bugs. But we have a lot of issues because we use the whole thing as a way to manage, sets of issues, work items, feature requests. We even, getting back to your, how do I influence things? If you want to get involved, we even leave a bunch of feature requests on the backlog, things that we know that we're never going to get to, but are kind of low-hanging fruit for people who want to get involved. And these are kind of good items that they could pick up and learn how to build Flutter and add some features and create a pull request and submit as a learning experience. We literally have hundreds of contributors around the world, partners, individuals, corporations, consulting firms, Microsoft and Google, and we do all of this work in the public. Kind of, we consider ourselves steward, but there's so many people doing so much work. They've forked their own version and building support for all kinds of other platforms, and Flutter is really 100% at its core open, right? And we take contributions that meet the standard as quickly and thoroughly as we can. And we do kind of set a high bar because we want to keep Flutter at its high quality level. So that means that we require tests and docs and things as well as working code, which tends to upset some folks that are just like, just change this line of code and my life will be better. Well, that's not quite enough to make it into Flutter. But also when it comes to influence, for sure, if you want something fixed and you don't think it's happening fast enough, if you can get 1,000 of your friends to agree with you and give it a thumbs up, believe me, we will notice, and that is something that will affect our priority. And in fact, that is how we decide what the engineers are going to work on in terms of what is it that our customers want from us, right? And so we have a number of issues, and we have to look at them from a impact. Are we really blocking somebody from doing something important point of view? But also, impact of do we enable a larger set of use cases with a fix here or a feature request? And if something is impacting you, and you think it's impacting a larger set of people, the more people you can get to jump in and comment and say, yeah, me too, thumbs up, right? That affects things. That really does. So there's all kinds of ways to get involved. And then just to wrap that up, we find that the people that are the most impactful are the ones that take the time, learn the coding standard, and submit good, clean PRs. And those we love taking. We love those. So if you want to really make an impact on Flutter, those are the kinds of impacts that have the most ability to change how things go at Flutter.
I'll add to that code changes themselves are not the only way to have huge impact as well. So we always look for more ways of explaining complex topics, more ways of helping people figure out how to do that, more documentation, more just there's a lot of extra things that go to making a framework really good. There's a question in the chat I saw go by about being more opinionated, and resources that show Flutter being used in an opinionated way are also a really important way to have impact in the area as well. So I'll just say it's more than just code. Code is great, is awesome. There's more to it as well.
Oh, for sure. Docs make a huge difference. Absolutely. And samples.
Okay. Probably, not probably, we're definitely hit the time box. So thank you very much for your time. It was a great pleasure to have you here. And by the way, great pleasure to have you here. And please not limit your questions to AMA sessions or YouTube or conferences, because I believe the Flutter team always open for new questions or issues or everything, can just go there and ask it, and they will answer. So thank you very much for your work. It's really nice to be a part of the community that lives together, and this is awesome. Thank you very much. Thank you.
Thanks for having us, for sure.
Thank you. Majid. Yeah, that's it. And Majid, could you come on the stage now, if you wish, for the Viking vibe? So, what do you think about the conference? Did you love it?
Actually, I will share some stats later that shows how amazing this time Flutter Viking was. I give you a brief but quick stats. We had around 1,530 people attended, and we still have 300 people watching us.
Wow.
And I've never done any online conference in the last 2 years of COVID that we end an online conference with 300 people still watching. This is amazing. So I would say this conference was a huge success. Thanks to everyone who helped to organize, to run it, to be in background, Flutter team for the great support, and Flutter community for sure. All the people who helped, being in the chat, moderating, going to the different virtual places, talking to people, do networking. This was amazing.
Totally agree.
I am very, very satisfied, and I hope that everyone enjoyed Flutter Vikings this time. But
yeah, I think that it's hard, extremely hard these days to make a conference. Because offline is not the same as online, and online conference they are. But Flutter Vikings is the probably best online conference out there. And of course, The Flutter is the best framework / language / tool in the world.
For sure.
So thank you very much.
Yeah. It's time to wrap up. We have some slides, and let's bring up Simon as well. Simon, are you ready? Let's wrap it up. There you go.
Hola.
So, hola. So 3 of us. It's time to wrap up a closing session. So I have few slides. I'll go through it quickly, and then last few words, and we can say goodbye. First of all, again, we learned a lot in the last 2 days. It was amazing. So many great talks. I was so surprised. So many of those talks were quite in depth. So we will make sure later we publish all of these talks with a better quality in Flutter community YouTube channel. And if you're not, if you don't follow us on social media, please do. So we will announce all of our winners, videos, everything about the conference in all of our social media, as well as subscribe to Flutter community YouTube channel. And shout out to speakers, because no conference is a great conference without their speakers, right? So speakers did a tremendous job, and they build this momentum. So all of the talks were so amazing that everyone still are talking about those talks. Thank you very much, all the speakers. Sponsors, of course, this conference would not be possible without their help. So both financially and also the support that they put behind this conference. So Google, Flutter team for sure, Invertase team, Stream, CodeMagic, Superlist, Rebel App Studio, the AdSign company, Very Good Venture, Software, Dev Angels, Bouvet from Norway, Manning Publishing, and Microsoft. Thank you very much for doing that for community. And we are wrapping up our session, but this is not the end. You still have time to go through the activities on our website. Unfortunately, our platform will be closed shortly, maybe around 10 minutes after the conference. You cannot come back to the platform, but you can check everything on our website. Go to our website, check our activity page. You still have time to submit your activities and win some prizes, including Dash, T-shirt, book reader, cash, noise cancellation headphone, and so much more. So make sure that you check them out. And we will definitely get back to all of your photos on social media. To be honest, we've been overwhelmed with the number of tweets that we received. We literally didn't have time to check all of them. So that's why we don't have a winner right now to announce. And we need to go again once more through all of the, tweets and check them out, or LinkedIn and different social media, and find all the pictures and find out which one is the best. And to be honest, all of them are great. Maybe we will give away stickers to all of them. So stay tuned on your social media. We will reach you out by private message on social media to you. And last but not least, this was a warm-up probably for the in-person conference, or a hybrid version that we're going to do August 31st and September 1st in Oslo, Norway. So if you are around in Europe and you can fly, hopefully by that time COVID doesn't hit us again, because, the last 2 days was supposed to be in person, but COVID happened, right? So, but hopefully next time it will not hit us again. And I'm sure that I will meet you. We can have up to 500 attendees. So grab your ticket. And I'm actually looking forward to meeting you, all of you, in person. So that's from me and you guys. Simon, from the master of Flutter Viking right now. Evgeny, any last words?
It's a great conference, right?
Yeah,
definitely amazing.
Amazing conference, amazing people, amazing everything. Yeah, I loved those people. And
I really think the platform has made a difference. Like, just bringing everyone together in one place is really, YouTube comments are great, but to bring everyone together in one place to have the reactions and have the audience there makes a big difference.
Absolutely. So
not to mention that this will also be online in August and September as well. But to get that Viking experience, you want to get your tickets now.
Yes. You'll get a chance to come to Norway and maybe visit me like this. Or actually, I'm thinking to have a Viking crew. So having some Viking shows. I'm not gonna spoil
You're not gonna make us all
I'm not
dress up
gonna
like
say
Vikings. I can't pull off that beard.
Okay, that's good. So I think we should then say goodbye. Evgeny, Simon, anything else you want to add?
Hope everyone had a great
base
time.
note. Yeah. Thanks, Majid.
Thank you so much. And we'll see you soon.
See you soon then.
Yeah, next Wednesday on this very channel, we'll be continuing the Flutter puzzle hack.
Sure.
Yeah. Maybe one prize for people who steal with us.
Yes.
We'll see.
Maybe we can play some music, no?
Go ahead.
Okay. Let's, play some blues? It's kind of live looping, so everything can go wrong. Let's see how it will work.